Hi guys, this is Leela. Welcome to my channel leelawebdev. Welcome to my new course Docker. So in the previous series we have learned about the Linux and all those things. So now in this new series we will learn about the Docker and all those things. So now before going into the Docker, first I want to tell you about the hypervisor. What is then hypervisor? So why? Because for the Docker implementation and all those things we will be using the virtual machine. Virtual machine means in the Linux we have already used the virtual machine, right? So the Ubuntu Linux. In the same scenario we will be using the virtual machine only. Whereas in the production we will be using the directly the not the virtual machine, bare metal server we will be using it. So let's try to understand what is an hypervisor before proceeding into the Docker and all those things. So we will start one by one. So stick on with me. So in this series so that you will understand. We'll go on one by one in this course. So now let's try to have it. So understanding the hypervisor. So hypervisor is a piece of software which creates the virtual servers on the top of physical servers. Here physical servers means let's assume that it is a system. So in the physical system, so system means your desktop computer or anything, the computer. So hypervisor is a software which creates virtual servers. So that means this hypervisor will be there in your system. And using this hypervisor we will be creating a virtual server. So that is the main thing. Virtual server is nothing but a virtual system, you can assume. So here we will be discussing about the server like this is a system. So don't mistaken with the server and all those things, systems and all those things. A hypervisor, also known as a virtual machine monitor. So hypervisor, virtual machine monitor, is a crucial piece of software that enables the creation and management of virtual machines on a physical computer. So here I am giving a clear explanation about the hypervisor. So it will monitor the virtual machines. So what I am trying to explain you is, so now in our physical system we will be having the one physical system, right? On the top of the physical system, so using the virtual machine we can have multiple guest operating systems. Like using the virtual server we can use the Linux, Mac OS, Windows again. So like this we can install the different virtual machines. So that means on the physical computer we are having different computers. So those are called as virtual machines. So these virtual machines who will be creating is with the help of hypervisor we will be creating it. So on the top of this hypervisor we will be creating these all the virtual machines. So that is the clear definition of this hypervisor. You can call your physical server as a bare metal server as well. So bare metal server in cloud technology or in the cloud terminology. So we call the physical system as a bare metal server also, as well, where that particular server will be allocated to a single user. So that means this server means the physical system where this particular system will be allocated to a single user, and we will not install any hypervisor on top of that. It is called as a physical server. So what I am trying to tell you is the physical system is nothing but we can also call it a bare metal server, on which the system is allocated to only a single user. That is nothing but your system, your system which you will be using. That is nothing but a bare metal system, you can say it is, or otherwise we can in cloud terminology we can call it as a server. Now on the physical server you will install some hypervisor to create the virtual machine. So whatever the physical server you are having, you will install some hypervisor. So hypervisor is a software, I told you, right? You will install that hypervisor to create the virtual machine. So this hypervisor will create a virtual machine. By using this hypervisor you will be creating virtual machines on the top of the physical server. That means if you want to create a virtual server, you need to take the help of the hypervisor to create on a physical server. So this is the conclusion of this one. So that means if you want to create a virtual server on your physical machine, you need to have the help of hypervisor. So now there are two types of hypervisors available in the server. So one is a type 1 hypervisor, that is hardware hypervisor, and the another one is type 2 hypervisor, that is software hypervisor. Type 1 hypervisor is also called as an hardware hypervisor, and type 2 hypervisor is also called as an software hypervisor. So these are the two types of hypervisors available in the internet or in the system. So one is a software hypervisor and another is a hardware hypervisor. Let's try to understand the difference between these two. So here this is a diagram. I am explaining you about the type 1 hypervisor and also a type 2 hypervisor. So the type 1 hypervisor and type 2 hypervisor. So this is the structure you will be having. I will explain you one by one in this one. In the previous diagram, on the left hand side you can see type 1 hypervisor, and on the right hand side you can see type 2 hypervisor. So this left hand side is called as a type 1 hypervisor and the right hand side is called as a type 2 hypervisor. In type 1 hypervisor you will see that there is no operating system on the physical server. So that means here in this is the hardware. So that means this is the what I can say is system, and in this hardware directly you are having an hypervisor. So that means in between this one you don't have any operating system. You will install hypervisor directly on the physical system. You will not take any help of the operating system. So that means, so this is the server or the system you are having. Directly the hypervisor will be installed in your system. So there will be no help of the operating system. So that means there will be no operating system in your system like Windows, Mac or anything. So there will be no operating system, and directly the hypervisor will be installed in this one. So this is called as an hardware hypervisor. So examples of type 1 hypervisor is VMware ESXi, Zen hypervisor and Hyper-V. So these type of hypervisors will be directly installed in the hardware. There will be no use of help of this operating system, and on the top of this hypervisor you can install your virtual machines. After installing the hypervisor, with the help of this hypervisor we can create the virtual machines. Any server that is created with the hypervisor is called as a virtual machine. So you will be thinking that what is this virtual machine and what is this virtual server. So both are one and the same only, but any server that is created with the help of virtual machine is called as a the help of hypervisor is called as a virtual machine. So that means here in the hardware hypervisor, so the hardware, the physical system will be available. So there will be no operating system installed in that physical system, and a hypervisor is directly installed. So the examples of this hypervisor is, I have told you, right, Hyper-V, Zen hypervisor like this. And on the top of this hypervisor we will be installing the virtual machine 1, virtual machine 2, like that. So this one will have its own guest operating system. So this is the what I am trying to explain you. In that virtual machine you can install the operating system whatever you want. There is no need to bother about the hypervisor. You can install the workloads, that is nothing but workloads means applications, in that virtual server. So in that virtual machine, so whatever the things you want you can do it. You can install your own operating system, you can install your own applications, and all those things you can do it. Whereas in the type 2 hypervisor, on the physical server you will install some operating system just like our desktop systems what you will be having. So assume that the physical system is in hardware. In that hardware we will be installing the operating system. On this operating system you will install the hypervisor. Then you start creating the virtual machine. So here if you try to see the diagram, so first you will be having a physical system. On the top of the physical system you will be having a host operating system, that is nothing but Windows, Linux, Mac or anything. On this host OS, so hypervisor, so that means this hypervisor needs any host operating system to be installed, and this hypervisor doesn't need any operating system. It will be directly installed in the hardware, whereas this hypervisor needs the help of operating system to be installed. On the top of this hypervisor we will be installing these virtual machines. So this is called as a type 2 or the software hypervisor. So examples of this particular hypervisor is which we are using right now, VMware Workstation and the VirtualBox. So we are already using this Oracle VirtualBox, right? So that is called as a software hypervisor only. Why? Because that hypervisor will be installed only if the operating system is there. Then without operating system we cannot install this hypervisor. You can use any of the type of the hypervisor and install the virtual machines. It all depends on the requirement. So whatever the type you want to install, the type of hypervisor you can install it. It all depends on the requirement. So normally generally on the production or in the production box we will be using the type 1 hypervisor. Whereas if you want to do some R&D, if you want to do some concepts, so if you are doing some research purpose R&D, and if you are developing some development means, then we will be using this type 2 hypervisor. So this is the main difference between this hypervisor and all those things. So hope you understood about this hypervisor concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. In this video we will learn about the another concept, that is limitations of the virtual machine. So in the previous video we have learned about the hypervisor. So now the hypervisor is nothing but which will create the virtual machines. So I will try to explain you what are the limitations of this virtual machine. So let's move on to this one. So provisioning of virtual machine is a time consuming. So what is this meaning of this one? So I will try to explain you. If you compare with the containers, containers can be created in 1 second or less than 1 second as well. It all depends on the configuration what you do. But when compared to the virtual machine, it is less. So that means creating of this virtual machine is somewhat time consuming when compared to the containers. I will explain you about the containers also. Just I am trying to explain you the limitations between a container and a virtual machine. So if you compare with the container can be created with less than 1 second or less than 1 second. Depends on the requirements what you are configuration what you are trying to do it. But when compared to the virtual machine, the creation of the container is somewhat less only. And another one is what I want to tell you is resource allocation is not dynamic. So something like memory or CPU is not dynamic in the virtual machine. So what is this resource allocation not dynamic? For example, I created a virtual machine and for that I have given a resource like 1 core CPU and also a 2 GB RAM. So I have created a virtual machine and for that virtual machine I have created a 1 core CPU and 2 GB RAM. Right now for the application in that server, it is sufficient. So whatever the application that is running in that virtual machine, it is sufficient because at the starting there are less number of users hitting that application. At the starting it is sufficient. Let's say when the days are passing, the number of users hitting the application will increase day by day. So whenever the application is days are coming on, the number of users or the customers or the visitors which are coming to that application are increasing day by day. In that particular point of view, the 1 core CPU and also the 2 GB RAM is not sufficient. So whatever the CPU and the RAM we have allocated at the time of creation of the virtual server, it is not sufficient. We need to increase, I have to increase it. So normally we need to increase it. It is not possible to increase it dynamically. So virtual machines cannot allocate itself with high memory and high CPU even though it is available in the physical server. So that means for example, let's say that virtual machine we will be creating on the top of the hypervisor, that is nothing but the hypervisor will be located in the physical server only. Even though if the physical server has the memory and the allocation memory and the CPU also, but the virtual machine cannot take it dynamically even if it requires. So that means even if it is available in the physical server, the virtual machine cannot allocate itself dynamically with the memory and the CPU. So that means at the starting of the creation, whatever you have created, the 2 GB RAM and 1 core CPU, so that is the only thing it will be using. So when the application is growing day by day, so that core CPU and also the 2 GB RAM is not sufficient also, it will not increase it. So you need to run the commands or you have to tell explicitly to increase the memory or to increase the CPU. So that means the virtual machine cannot dynamically increase the resource allocation, but there is a provision that you need to tell it explicitly we need to run some certain commands to tell explicitly to increase the memory or to increase the CPU. Let's say after some days you need some more memory, means again you need to do that same task again. So that means for example, let's say that for the days going on, so you need to increase the memory for 2 GB to 3 GB RAM, I need to increase it. So you need to run a particular set of commands to increase the RAM. So you have increased the RAM and after some days passed by, again you need to increase some memory. Then again you need to repeat that particular task again and again. So that is the limitation of this virtual server. So earlier days, what we need to do is, in order to increase the memory or the CPU, we need to shut down the virtual machine and then we need to increase the resource. So right now in the latest, so it is not needed. So you can directly increase it on the running instance, the memory and the CPU. So that is one thing. But when compared to the containers, containers can allocate the resources automatically. So whereas the containers can allocate the resources automatically. You doesn't need any help. There is no need to tell explicitly to the container. That's the reason resource allocation is not dynamic in the virtual machines. You have to run the commands to increase or decrease the CPU. It cannot increase automatically. So what I am trying to tell you, so containers can allocate the resource automatically. So there is no need to run the certain commands or anything. Whereas in the virtual machine, so you have to run the commands to increase or decrease the CPU or memory. It cannot increase or decrease automatically. So technically this concept is called as a scale in and scale out. So a scale in and scale out functionality is not available in the virtual machine, whereas in the containers the scale in and scale out functionality is available. Resource allocated by the virtual machine are utilized by the virtual machines and the rest will be used by the application. So here what I am trying to tell you is, so that whatever the resource allocated by the virtual machine are utilized by the virtual machine, fine, and the virtual not utilized or not are utilized by the virtual machine, so are utilized by the operating system and the rest will be used by the application. So what is the meaning of this one is, I will try to explain you with an example. Let's say I am running an application in the virtual machine. So we have a virtual machine and I am running an application in that virtual machine. We know that in the virtual machine we have one guest operating system. Let's say it can be Windows, Mac, Linux or anything. So in the virtual machine we have a operating system and in that operating system you will run your application. So that is the thing. So in that operating system we will be running our application. We know that for running an operating system we need a lot of services that should be running in the background. So for an operating system to make it working, so we need a lot of services and that those services will be running on the background. And if the services are running means those require and those services will consume some resources like memory, CPU and storage as well. That means the entire resource or the entire allocation, memory allocation, whatever you are trying to allocate to the virtual machine is not utilized by your application completely. So it is actually used by your operating system and the rest of the CPU and memory is used by your application. So this is what I want to tell you. The drawback is that the resource I have allocated to the virtual machine is not completely utilized by the actual application. So whatever the memory or the resource you are allocating to the virtual machine is not completely utilized by the application. Some part of the thing is used by the operating system and the rest will be used by the application, whereas in the that is in the virtual machines. This is the limitation what we have with the virtual machine. This particular limitation we can overcome with the containers. So that is something. And number of virtual machines that can be created is more compared to the physical server, but less when compared to the containers. So that means what I am trying to explain you is, so this example, so here let's say that I will try to do the paint. Okay, in the paint, let's say that here I am having a physical server. Okay, here I will be having a physical server. Let's say here we have a physical server. Okay, I am having a physical server. On the top of this physical server, so we will be having this operating system. Okay, we will be having this operating system. On the top of this operating system, we will be having an hypervisor. That is nothing but virtual box or anything, whichever it may be. And on the top of this hypervisor, you will be having an VM1, virtual machine 1, and VM2, virtual machine 2, and VM3. So we will be having like this. So that means the physical server or the physical operating system we will be having only one. So when compared to the physical operating system we can have only one, but that virtual operating systems we can have multiple. So when compared to the physical operating system or the physical server we can have multiple virtual machines. So that means here in this virtual machine we have one operating system and in this one we have another operating system and we have in this one another guest operating system. Let's say that here we can have Windows, Linux or Mac or anything, whatever the operating system you want, you like, you can have it. And in this one you can run this virtual machine for staging environment, and this one you can run it for the testing environment, and this one you can run it for the production environment. Whereas in the physical server you have only the one physical server and you cannot have it multiple thing. So that means when compared to the physical server you can have more virtual machines, but when compared to the virtual machines you can have more containers so than virtual machines. So here you will be having a limitations depending on the resource or anything, but here you can have as many containers you want when compared to the virtual machines. So that is what I am trying to explain you. So number of virtual machines that can be created is more compared to the physical server, but less. So virtual machines creation will be less when compared to the containers. So that is what I am trying to explain you. So these are all about the limitations of these virtual machines. So in the next video you will learn about the container concept. So hope you understood about these limitations of the virtual machine. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. In this video we will learn what is a container. In the previous videos we have learned about the hypervisor and also the limitations on the virtual machine and all those things we have seen it, right? Now in this video we will learn about what is a container. So let's proceed. So now the container is a simple another process in your machine that has been isolated from all other process on the host machine. So it may be looking somewhat difficult or somewhat confusing. So I will read it again. Container is a simple another process in your machine that has been isolated from all other process on the host machine. Host machine means here it is a physical server and it has been isolated. The process and all those things will be, the container will have a process ID and that process ID will be completely isolated from the all other process on the host machine. So let's try to understand this one. To understand this, let's say that we have a physical server and on that physical server means, so the host machine we are having or bare metal server we are having, and on that I have installed some operating system. So any operating system, let's say, and I am running some applications like app1, app2 and so on. So these are all the apps I am using. So now you know that in an operating system, so when you are running particular applications, so now these particular applications can talk to each other. So how can these particular applications can talk to each other? Through the process ID. App1 will have one process ID and app2 will have one process ID, and app1 and app2 will talk to each other using the process ID. The particular process ID which is created for this application can talk to this particular process ID of another application and vice versa. So the applications can talk to each other with their particular process IDs. And container is just nothing but another process. So that means it is another process container which is running inside of it. Okay. So inside it means inside the operating system. So if I create a boundary for app1, so if I create a boundary for app1 and this process is called as a container. So if a container, if a boundary has been created for the app1 means, then it is called as a container. And now the container will have a particular process, and how we can create a boundary using the how we can create a container for the app application means using containerization technologies like kernel namespace and the C groups, which I will explain you in the later here only. So but you need to understand that. So let's assume that I will be going to the paint. Let's take the new one, Alt F, new one. So here we are having the host operating system. Okay, here I am having the host operating system, and in this host operating system, let's say I am having the app1, app2 and app3. Like this we are having some particular applications we are having. Now this one will have a process ID and this one will have a process ID and this one will have a process ID, and these process IDs will talk to each other. But if I create a boundary for this one, so now this boundary will have a process. So this boundary will have a process and this one will have a process boundary and this one will have a boundary. Inside this boundary application is present. Now this boundary is called as a container. And how we can create this boundary is nothing but using the containerization technologies like kernel, namespace and also C group, which I will try to explain you. So this is one thing. So this container inside will have the properties only related to this particular application which are isolated. So now when what I am trying to do, so this container, so now this boundary, this container will have its application and the process ID will belong to only to this container, and which is isolated, and now this application is isolated to here, and this application is isolated and this application is isolated. So that is what I am trying to explain you. We can also say like this: container will have only libraries and binaries which need OS and the application to be running without any kernel packages. So here I am telling that this is another definition. So if you don't understand this definition means, so here container will have only libraries and binaries which need OS and the application to be running without any kernel packages. Actually in Linux operating system, we need kernel packages to talk to the hardware. So the kernel packages is needed to talk to the hardware, because as a human being, as an application cannot understand the binary language. So kernel will help you to convert human readable language to the machine level language and vice versa. That's the reason why we use the kernel. Containers doesn't have this particular kernel. So that is one thing which I want to explain you. Containers will have only libraries and binaries which are needed to run your operating system and the application. That's it. So the containers, the boundaries which we have understood, so we'll have only the nature libraries and binaries needed to run your operating system and also the application. The kernel related task will be done by your containerization tool, not by your container. That's the reason why containers are lightweight. So that means containers will have only an libraries and the binaries which are needed to run your operating system and application. The kernel related task will be done by containerization tool, not by your container. That's the reason why containers are lightweight. So here another one is isolation leverages the kernel namespaces and C group features that has been in the Linux for a long time. So this kernel namespaces and the C isolation. So I told you, right, the container will be isolated to each other. So how this isolation will be done is through the kernel namespaces and the C group features. So these are already present in the Linux for a long time. So we have discussed that container are nothing but a boundary, and these boundaries are created by the feature called kernel namespace and the C group. In the starting of the video we have discussed about this one. So kernel namespaces and the C groups, by using this particular feature which is existing in the Linux operating system from long back, now the containerization tool have adopted this particular functionality. They have not designed this functionality. So now in order to make a container and all those things, so now these containerization tools like Docker and everything, so they will be using this technology to in order to create the container. So they haven't designed this new functionality. This functionality is already present in the Linux long before only. So we will discuss this in the detail later. For now, understand that using this kernel namespace and the C group functionality, containers are able to isolate each other, although containers are running in a single host. So this is one thing which you need to understand. Container virtualize the operating system instead of hardware and more portable and efficient. Containers do not virtualize your hardware. So who will virtualize your hardware? There is nothing but a hypervisor. So it is virtualizing your operating system, which means the process ID, network, IPC, UTC, these all the softwares will be virtualized by your containers. The hypervisor, what we have discussed, is nothing but its hardware virtualization. Now containers are nothing but virtualizing the software operating system. So that is the major difference between your containers and the virtual machines. So Docker has worked to make these capabilities approachable and easy to use. Why we are talking more about the Docker is when we come across the containers, because we are creating the containers or managing the containers or building the images, creating our custom images, creating the repositories or pushing to the repositories, whatever the things we will be doing in these sessions. So it is much simpler in Docker compared to any other tool. So this is the diagram which I want to tell you. So here you will be having your physical system. In this physical system you will be having the host operating system, and in the host operating system at the top you will be having containerization tool. That is nothing but here I have shown you the Docker, and in this Docker we will be having the containers like app A, app B, app C, like this. So this is the diagram for the containerized applications. If you look at the diagram, there is a Docker, and the Docker will be installed on the operating system. So that is what I am explaining you, and the Docker is installed on the top of the operating system. It is not like a type 1 hypervisor. So type 1 hypervisor means hardware hypervisor. It is not like that one. Without having any operating system you can't install the Docker, and Docker is like portable. Imagine instead of Docker you can install any other tool. Just I am telling the Docker. This Docker will be installed on any operating host system, and then you will start creating the containers. Every container will have its own application related process that are running inside it. The resource what is consumed by your container will be used by your application. So here every container will have its own application. Let's say that one container can have Nginx server, and another container will have the MySQL, and another container will have the Tomcat. So like this, whatever the things you want, you can do it. So you can create the small scale applications like cache server or anything, the containers you can do it, as well as the large scale applications also you can create using the container like Hadoop, big data, like that also you can create it. And here I have told you that in the virtualization or something like in the virtual machines, so the resource allocation is not dynamic, whereas in the container the resource allocation is dynamic. So that means, for example, if you have created a container with a 0.5 core CPU and 100 MB of RAM means automatically, so for example, if the application consumes more resource or anything means, without using the command line tools and all those things, automatically it will contact the Docker, and the application will contact the Docker, and the Docker will allocate the resources to this one if the host system has the resource available. So this is that is why we can say that container is resource allocation is dynamic, whereas the virtual machines resource allocation is not dynamic. So that's it. So what are the containerization tools we have? So now we understood what is a container. So I hope that you have a clear understanding about the container and what are the containerization tools we have. So we have open source and also the enterprise tools. The first one is then LXC or LXD. So the older version is LXC and the newer version right now is LXD. So this is the first one which we use to create the containers. This particular tool is not popular. Why? Because it is only available in the Linux operating system. And the another containerization tools we have is the Creo and RKT, Containerd, Docker. So here I am explaining about the Docker engine and the Docker Enterprise, Podman, Runc. So these are the different types of what I can say is containerization tools available in the for creating the containers. So here if you try to see, except Docker, everything is an open source. So directly you can read the documentation and you can create the containers directly. You can create the containers in the operating system. Whereas the Docker, we have two versions. That is, one is community edition and another is enterprise edition. The community edition is an open source, whereas the enterprise edition is a licensed one. So it's a commercial. We need to use it. So that's what about the Docker. So in Docker we have two versions, enterprise edition and the community edition. So community edition is a freeware, whereas the enterprise edition is a licensed one. So in the next video, what I will try to explain you is why we need to use the Docker and what is the use of Docker, advantage of Docker and all those things. Let's try to discuss in the next video. Hope you understood about this container and the containerization tool and how the container works in the host operating system. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the Docker introduction. So what is a Docker and all those things we will try to learn in this video. So in this video, we'll see about the Docker overview and why we have to use this Docker and what kind of tools that are available in the Docker supports and which tool we have to use to create a container. So these are all the things we'll try to learn it in this video. As per the DevOps principle, we have to build, test and deploy the application in a fastest way. So this is the DevOps principle. For example, you are developing a product for a client. First we have to write the code using some particular X language. So here X language means any language. Any language you can take after that particular code was written. So any language you can take it. After that particular code was written, we do some static code analysis. Then we will compile the code. That means we will build the code and then we will do the testing and then we will do the deployment. So this is the actual DevOps cycle. So that means here what I am trying to explain you is, so whenever we have an application that was developed using a particular language, let's say Angular or Node.js or anything, any language. So first we will do some static code analysis and then we will compile the code or build the code, whichever it may be. And then after building the code and compiling the code, so we will do the testing. And if everything is working fine means then we will do the deployment. So this is the actual DevOps cycle. When we have this kind of culture running right now in the organizations, we have to find some common tools that we have to use so that developers and the operation team can sit together and find a common platform to run the application. Why? Because if you don't like that, developers will say that the code has been working fine in the local or in their local environment. They have tested it, and when it comes to the deployment, they will be saying that it may not work as per the expectations. So this is the common scenario which we will be having. So normally the developers will say that when they are working in the local system or anywhere, it's working fine and we have tested it, everything is working fine. But when we are coming into the production deployment and all these things, so they may be complaining that this is not working fine as per the expectations. So that's why we need to find a common tool so that in the local and the development environment and the deployment environment, everything must have a common platform. So in order to avoid these kind of gaps in the DevOps culture, so we have to find a common tool where we have to test the code, we have to build the code, and then we have to run the code. So for that, Docker is the right solution or container is the right solution for this kind of implementation. So that is the reason Docker comes into the place where the container and all these things is the right solution for this kind of implementation. Docker container technology was launched in 2013 as an open source Docker engine. So first it was started in like this. In 2016 they have used it for their internal purpose. After that they have made it an open source which is named as Docker engine. So first of all they have used it in their local internal purpose. Then afterwards, after the 2016 or something like that, they have made it as an open source which they have named it as a Docker engine. So now we can download, we can install, we can play around, we can do some particular tasks, we can create a container, we can build the image and we can deploy our application. So like this, these are all the things they have been doing all the things. After a few years later, they have made it into a product version and community version, as well as licensed and non-licensed version. So that means they have released into a product version and community version. That means licensed version and non-licensed version, they have released it. Docker platform provides multiple tools like Docker Engine. In Docker Engine, we have two versions. One is Community Edition and another one is Enterprise Edition. Community Edition is nothing but everybody can download and install, which is called as an open source. So here, Docker platform provides multiple tools like Docker Engine, and in the Docker Engine, we have two versions. One is Community Edition and another is Enterprise Edition. Community Edition is nothing but everybody can download and install it. That is nothing but open source. Whereas the Enterprise Edition is nothing but you have to purchase a license key where you will get a support from the Docker community. So Enterprise Edition is a licensed version. If you purchase the key, then you will get a support from the Docker community. Next one is nothing but Docker Desktop. So the next tool which I want to discuss is the Docker Desktop. This is used if you want all the features of your Docker in one particular platform, which means one particular tool. So if you want to have all the features of the Docker in one particular tool means then you need to use the Docker Desktop. If you want to run some Kubernetes containers, which is called as a pods, which we'll discuss later in our videos. So if you want to run some security and it has to be much faster, patching, bug fix, these are all the things if you want to run means everything should happen automatically means then you have to go for the Docker Desktop only. Now if you want to do it by yourself, then go for Docker Engine. So these are all the things if you want to do it automatically means Kubernetes containers, patching, bug fixing and all those things. You can go for Docker Desktop, but if you want to do it all by yourself means then you need to go for Docker Engine. In Docker Engine also we have two versions which I have told you already before, Community Edition and also Enterprise Edition. Next one is nothing but Docker Compose tool. So the next one is I am discussing is the Docker Compose tool. If you want to do some orchestration on Docker Engine, we have a tool called Docker Compose. So what is this orchestration? I will try to explain you. Orchestration means where we will write a file and we will tell what we want to do, what kind of containers we want to create, what image we want to use it for a container, what volume I want to use it, what port forwarding I have to do. All these particular details and all those things I will write in a file. So that particular file I will send as an input to my Docker engine. This mechanism is called as an orchestration. So that means that we have a Docker engine and what is the type of container we have to create, how many volumes we need to create, and all those things we will write in a one file and we'll pass it as an input to the Docker engine. So that mechanism is called as an orchestration. So that means writing a file and giving it to the Docker engine is called as an orchestration. This particular job is done by your Docker Compose. So that is what I want to explain you. The next tool is nothing but Docker Swarm. So before Kubernetes came into picture in 2014, earlier we used Docker engine to create a cluster called as Docker cluster. It is so easy to configure, but we don't have so many functionalities what Kubernetes is providing because we have less contributors to the Docker Swarm. So that's why you don't have those many functionalities with the as Kubernetes. That's the reason we don't use much functionalities. That's why we are not using this Docker Swarm nowadays to create a cluster. So Docker Swarm is nothing but, so in order to create a cluster we will be using. Next one is nothing but Docker Engine. So the last one is nothing but Docker Engine. It is a tool from the Docker used to build, spin and share the containers. If you are using Docker Engine, you have to configure, you have to maintain, you have to update some security patches, you have to monitor your images from security vulnerabilities. All these things you have to do done by yourself only if you are using a Docker Engine. But Docker Engine is the actual tool which we are using to create containers and to run the containers. So Docker Engine is the actual tool. Docker Engine runs on different platforms like virtual machines, bare metal, cloud, desktops, any desktops which is running on any OSS operating systems like Windows, Linux or Mac or anything. So the Docker Engine can run on any different platform. I can run my Docker Engine on virtual machine. It can be Oracle VirtualBox in your local system or any cloud, or I can go for bare metal server. I can directly install Docker Engine or Docker Desktop on the bare metal server, or I can go for the desktop version in Windows or Mac OS. That means Docker Engine is a cross platform. So I can install it anywhere I want it. So that's why I have explained all the different possible scenarios. So that means you can understand that Docker Engine is a cross platform. Since Docker Engine is a platform independent, we can migrate the container from one platform to another platform. So we can migrate the container from one platform to another platform. The meaning of this is, today we have Windows laptop. Let's say that you have a Windows laptop and I have installed Docker desktop in that one. Why? Because Docker desktop has will work only on the Windows platform. And I have created a container. That container I want to migrate to it, let's say Linux platform. So that means I have a Docker desktop in Windows laptop and I have created a container in the Docker desktop. Now I have another system which is a Linux platform, Linux OS, and I want to migrate that container into this Linux platform. Means I have another Linux diagram, and in that I have installed Docker engine. I can migrate the container from Windows to the Linux platform without any issues. That is why that is the reason why Docker engine is a platform independent tool. So that is one thing. Next point is that we can run any application developed by any language on the Docker engine. So any application developed by any language, we can run in the Docker engine. I can run small scale applications to the large scale application like Hadoop Big Data. Also I can run small applications like Memcache, Nginx application, or Apache web server. So this is all what about the Docker engine and the Docker thing. So hope you understood about this Docker concept. I will be providing this PPT under the description below, the link. So for more details, you can watch that link and all those things. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see about the difference between a Docker engine and a Docker desktop. So let's try to see what are the difference between these two. Let us see in details what Docker engine provides and what Docker desktop provides us. So first of all, you need to understand that. One sec. Yeah. So this one, leave it. Let us understand the basic difference between the Docker engine and the Docker desktop. Docker engine is the community edition and the Docker desktop is the enterprise edition. So this is the first one. So you need to understand. Whereas the Docker desktop means I have to purchase a subscription. For only limited access, it is free of cost. Means that if the employees are less than 250 means, and if you want only few features without any security updates means, then you have to go for a Docker desktop. Okay. So that means what I am trying to tell is Docker engine is a community edition. So community edition is nothing but it's an open source. So anyone can install it and you can use it. Whereas the Docker desktop is an enterprise edition. For limited access, you can use it for a freeware. So you need to purchase a subscription. For only limited access, it is a free. For example, if your employees is having in an organization less than 50, and if you want only the few features without any security updates means, then you can go for a Docker desktop. In Docker engine, it doesn't need any hypervisor to be installed. I can install Docker engine in any virtual machine, on bare metal server, or in the cloud, or inside the Docker also. So that means I can run my Docker as a Docker inside a Docker. So that means it is called as a Docker on Docker, or nothing but D&D. So that means I can run Docker inside a Docker also, I can run it. So Docker engine, we can run it anywhere. It doesn't have any use of the hypervisor. In Docker desktop, if you want to install in Windows machine, you need to have a Hyper-V. Since we are talking about the Linux operating system, for that we need to have a KVM install or any other hypervisor unit like QEMU or KVM. This particular KVM will try to create a virtual machine, and inside that it will create a Docker desktop. So this is how the Docker desktop actually runs. So Docker desktop actually needs an hypervisor, Hyper-V, whereas Docker engine doesn't need any hypervisor. You can install it directly. So normally the Docker desktop doesn't support for the Linux operating system. So recently they have given support for the Linux platform also. Earlier we used to have only for the Windows and the Mac OS only. So the Docker desktop supports only for the Windows and Macs. Now it supports for the Linux platform also. Anything if you want to update, if you want to maintain your Docker engine, if you want to build the images and all those things means, then you have to do it yourself only in the Docker engine. Whereas the Docker desktop, they will take care of it. So here whatever the things you want to do it in the Docker engine means, you need to do it by yourself, DIY. So do it yourself only. Whereas the Docker desktop, they will take care of it. Docker engine supports stable and testing one. So stable means nothing, but you can use it for production, nothing but you can use it for production level. So and testing one means, so you will be having a Docker engine testing pre-GA also it is available. So that means if any new features or requirements are there means, then you can use it. The Docker engine, you can install it and you can use it in your application, and you can use it as an thing. You can use it as thing. So then afterwards it will make it as a generally available. So in the production level, you can use it Docker engine stable version, and in the testing level, you can use it Docker engine testing version. Generally, we use Docker engine for server based machines. We use Docker desktop for GUI based machines. So Docker engines like server based machines means Linux with the server edition. So like that, which doesn't have any GUI based means. So then we will be using this Docker engine. Whereas the Docker desktop, if you are trying to use it, means GUI based engine like Windows and Linux desktop systems and Mac OS. So these are the places where we will be using this Docker desktop. So there the graphical user interface will be there present. Docker engine, they provide a server tool. So whatever the things the Docker engine provides is, it will provide a server tool, Docker CLI client side tool, and the Docker Compose for orchestration. So if you want any other feature means you have to configure it. Whereas in the Docker desktop, you get Docker engine, Docker CLI, Docker BuildX, Docker Compose, Kubernetes, and Docker Context Trust and Credential Helper. So these are all the things is available as a bundle. So as a bundle of features, so the Docker desktop will be providing it for you. Whereas the Docker engine, it contains of only server tool, Docker CLI, and the Docker Compose. Docker engine, we can build, share images, we can create volumes, we can create networking, but the only difference is we don't have any support for the Kubernetes. So we cannot create a Kubernetes parts. So it is not possible in the Docker engine. For that, we need to use a separate Kubernetes client. So we need to install it and we need to do it. So Docker engine, we cannot do it this one all. Whereas in the Docker desktop, they will additionally enable the latest version of Kubernetes, as well as it is much faster, stable, and it is natively supported for Hyper-V. So we can share the containers, build the images, and we can do a lot of more. So I am writing only some of the features only. In the Docker desktop, we can do it for more. So in Docker desktop, the Kubernetes will be available, and also the latest version will be available. That is also much faster, and it is natively supported by the Hyper-V. Docker engine is mostly used for the production based platform. If you are using the production server, or if you want to build the image for your organization, so then you have to go for Docker engine if you want only the basic functionalities. So for production level things, so we will be using the Docker engine. Docker desktop mostly used by the developers. So the developers will be using mostly by the developers. They want to first test in their local system the Docker engine. Afterwards, the Docker engine, they can install, they can create Kubernetes pod, they can create containers, and they can build the images. Whatever they want, they can build the images. If you want these many features by the developer means, then you can go for the Docker desktop. So that is one thing. If you want only for running the containers and building the images, then go for the Docker engine. So if you want only to run the containers or build the images, then go for Docker engine. In this course, first we will learn about the Docker engine, and later we will see the Docker desktop. So that is not our priority thing. So why? Because by using the Docker, we have to install only Docker engine. Why? Because if you want to integrate the CI/CD tools like Jenkins, or if you want to use the code pipelines in AWS or Azure pipelines or Travis CI or GitLab Actions or GitHub. So whatever the things, if you want to use the CI/CD tools means, then we need to use the Docker engine only. Docker doesn't support, the Docker desktop doesn't support it. Docker engine only supports these all the CI/CD pipelines. So because of that reason, we need to use only the Docker engine. So in this session or in the videos, I will be using the Linux as the operating system, and I will create a virtual machine, and in that one we will use the Docker engine and we will develop it. So that is what I want to explain to you. So these are the main difference between a Docker engine and a Docker desktop. So this is all about this one. So Docker desktop we will be using it in the Windows, Mac OS, where the graphical user interface is available. We will be using it, and this one is an enterprise edition. So that means for the limited access, it will be provided as a free. But if you want more features and the security updates and all those things means, then we need to purchase a subscription. Whereas the Docker engine is completely a community edition. It's an open source. Anyone can install it and anyone can use that one. So that's it guys about the difference between a Docker engine and the Docker desktop. I will be providing the PPT link below to this description. So if anybody wants this PPT link means, they can have it. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela Web Dev. In this video, we will see how we can set up the virtual machine in our system and also the Ubuntu server. So right now for installing the Docker and all those things, I will be using for installing the Docker engine in our system. So right now I am having the Windows operating system. So I don't want to disturb this Windows operating system. And also I don't want to have the dual booting, something like Windows and Linux also. I don't want the dual booting also. So for this one, so for that reason, the correct option is use the virtual machine. And using the virtual machine, and in that virtual machine, I will install the Ubuntu server. So the Ubuntu server means it will not have any graphical user interface. So right now at the time of this recording, maybe the Ubuntu server is 24, I think, and the virtual box is 7. So these are the requirements which I will be using for my system. So let's try to install the virtual machine. So for installing this virtual machine, I will be using the Oracle VirtualBox. So Oracle VirtualBox download. So if you search for this one, so at the first place you will be having this downloads thing, and if you click on here, you will be able to see the Windows host, Mac OS, and all those things. You will be able to see it. So for the Mac OS also, we are for the VirtualBox 7, we have the support for M1 M2 chipsets also. So right now my system is Windows, so I will be downloading this Windows. You can click on this one, automatically the download will start. I have already downloaded this VirtualBox for this one, so it is already there in the downloads. We'll try to see it. So in the downloads I will try to show you. Let's go into the downloads. Yeah, so this is the VirtualBox which I will be having, and let's try to double click on this one. So install the VirtualBox. So after downloading this VirtualBox, so let's double click on this one. So here it will show you a screen something like this. So the screen is something like this. Let's try to, yeah. So the screen is something like this, and welcome to the VirtualBox 7.0.18. At the time of this recording, the version of the VirtualBox is 7.0.18, and I am clicking on the next, and here it will ask you the path where I need to install the VirtualBox. So here I am taking C program files VirtualBox only. So I am clicking on the next, and it will be asking that network interfaces and all those things will be temporarily disconnected. Okay, fine. So you can proceed with the installation, and I am clicking on the S. And it is telling that it requires the Python core package, it seems, and the Python core package is missing in my application, in my system. So I am proceeding with the installation. So I am missing dependencies also. I am telling that to install. So it is telling that install. So automatically the Oracle VirtualBox will be installed. Already in our Linux course, we have already installed the VirtualBox, but here I am installing it newly. I have uninstalled the previous one, and I am installing it newly. So after finishing this one, it will ask you that I want to create a shortcut icon in the desktop. So I don't want to any shortcut icon. So start VirtualBox after installation. So okay, it is telling to start. Shall I start it? So I am not starting this one by automatically. I am clicking on the finish. Now VirtualBox has been successfully installed. So if you try to see here, Oracle VirtualBox. So here this is the screen which you will be able to see. So let it open. Yeah, this is the screen which you will be able to see. Now I need to install the operating system in the VirtualBox. So what is the operating system right now we are using? So for installing the Docker and all those things, I am installing the Ubuntu server. So previously in our Linux course, I have installed the Ubuntu desktop. So this time I don't want any graphical user interface. Mostly I am dealing with the commands only. So that is the reason I am using the Ubuntu server. So now let's try to go to the Ubuntu server. So for downloading this Ubuntu server, so you can write directly Ubuntu server download. So you can type directly like this, and here you will be able to see get Ubuntu server. So directly you can go on to this one, and here it will ask you that to download the LTS. So download the LTS 24.04 at the time of this recording. So here you will be able to see the ISO image will be downloaded. So it is about 2.7 GB. I have already downloaded this Ubuntu. So if you didn't download it, means you can directly click on this button. Automatically the download will start, and the ISO image will be downloaded automatically. So now in the downloads folder, you will be able to see like this Ubuntu 24.04 live server. So now let's try to install the Ubuntu server in the VirtualBox. So for this one, let's open here, and this is the VirtualBox, right? So what I will try to do is you need to click on the new. So I have clicked on the new, and it will ask you the name of this one. So in order to identify it correctly, the VirtualBox, so I will be creating Docker engine, and I will write Ubuntu server, and you can write something like 24, okay, so that we can understand very easily. So the name itself, I am telling that I am installing the Docker engine so that I can have a clear idea about this one. So I will be creating in the same place, VirtualBox only, and it will ask you to select the ISO image. This ISO image is nothing but whatever we have downloaded, that Ubuntu thing, and here you need to provide the option. So you can go on other if you don't find anything, and you can select this one in the downloads, this Ubuntu live server. So I have selected this, automatically the ISO image will be visible here. So that's it. So now you can click on the next button. Now if I click on the next button, it will ask you for the username and the password. So for the username and password for this unattended guest OS install setup. So here as usual, so I will be using test user. So I am using the test user only, test1234, and the same username and the password I am using it. And here if you want to have the host name, you can have Docker server. Sorry. So you can have something like Docker server or anything. So anything we can give it. So the host name I am trying to take it like this, and here we can have this one. So fine. Next I am going into the next one, and here it will ask you to set up the memory, how much RAM we need to do it. So depending on your RAM, how much it is having. So right now I am in my laptop, it is having 16 GB RAM. So what I will try to do is I will take 8 GB RAM, something like that. Okay, so I will take the 8 GB RAM, and here how many core CPU you want. I have 8 core CPU. I am taking the 2 core CPU for this one. So let's try to click on the next. Okay, so now it will ask how much disk you want. So you can take 100 GB. So I am taking the 100 GB for this one. So 100 GB of memory I am taking, and this is the maximum memory it will be taking. So if you tell 100 GB means right away it will not take directly the 100 GB from your hard disk. So maximum limit how much it can take is 100 GB only. So depending on the file size it is taking, so the memory allocation will be increased up to a maximum limit of 100 GB. So now I am clicking on the next. So these are all the details which you will be having. So after completing the setup, so you can click on the finish. So now it will try to power up. So here the virtual machine is powering up. So let it start. So it will take some time to start. So here it has been started. So now here you will be able to see, and I will try to view scaled mode. Okay, I will close this one. Yeah. So now you are able to see it. So it will take some time. So let it take it. So Ubuntu is getting installed. Ubuntu server is getting installed. Let's wait for some time. Yeah, so it has started Ubuntu 24.04. So let it take. So it is booting. So it will ask you some series of questions to install the thing. So here so something error has happened for me, nothing I think. Let's check. Let's wait for some time. Yeah, it's taking time. Let it take. So now it has asked you what is the language you want to select. So you can select the English, press enter. So I am pressing the enter for this one. So enter, and here okay, done. And it will ask you what is the type of installation you want. So it is asking Ubuntu server minimized. So I am taking the Ubuntu server. So minimized means only some of the packages only will be installed. So here I can press on done directly, and here it will be asking you the IP address and all those things. So let it keep by default only. So I don't want to change anything. So let's press done. And the proxy server, it is asking if you are at the time of connecting to the internet, do you want any proxy address or anything miss. So right now I am not using anything. Let's keep it as it is only. So here it will ask you some mirror to download. So let it download some mirror locations. So now it has so I will be pressing on the done. So let's press on the done, and it will be asking that about to partition the hard disk. So what I will try to do is, so let Linux virtual machine decide the partitioning and all those things. So let's click on the tab, automatically it will go to the done. So I am pressing the done, and here you will be able to see that slash root it is taking about 48.9 GB, and the slash boot it is taking 2 GB, and keeping it as it is only. So I am not changing anything. So let the LVM means our Linux virtual machine, let's decide it whatever the amount it wants to allocate the memory. So I am pressing on the done. Now it is asking that do you want to continue? Yes, I want to continue. And here it will be asking your name. So here we can give something like Leela webdev, and here the server name is nothing but Docker server. I will give like this, and the username is as usual, test user, and the test 1234, and the test 1234. So this is the sudo username. Why? Because so normally in the Ubuntu, so you will be having the root user and root password, right? We cannot directly access the root, whereas in other Linux machines like Red Hat or anything means directly the root we can access it. So using this one, the root user, so we can access the root access. So first we need to log in with this user, then afterwards we can log in with the then afterwards we can go into the root user. So these are all the things we have already discussed in our Linux course. So for more details you can watch there, and I will go to the tab done, and here it will be asking that do you want to have Ubuntu Pro. So for right now, if I am skipping off, I don't want anything. And do you want to install the OpenSSH server means, so yeah, I need to open, so press spacebar so that it will be installed. What is this OpenSSH server is? So you can connect these virtual machines to the from the outside remote machine. So if you want to connect from the outside remote machine to the virtual to this virtual machine means, then we need to have an OpenSSH server installed. So let's go here and press done, and here it will be asking you some of the predefined some of the packages do you want to install. So it is asking Kubernetes, Docker, everything it is asking to install it. So I don't select these all the things. We will install one by one by manually, so by learning. So I don't want to predefinedly install at the time of the Ubuntu installation. So I am going back and I am pressing done. So why? Because Docker and Kubernetes and all those things we will install it one by one. So click on done. So now it is taking some time, and it is installing all the missing packages, and it is installing the Ubuntu. So will take some time to install. So let it install. So when installing this Ubuntu and all those things, it will ask you to, at the bottom it will show you the view full log, and also it will ask you about the cancel update and reboot. So don't select this cancel update and reboot. So I want all the packages to be updated, and after successfully completing all the updation only, then I want to reboot it. So it will take some time. So let's please wait for this one until and unless the installation and updating of the package is completed. Until completion only, then you need to go to the reboot thing. So it automatically, when the installation and all those things is completed, it will show you the reboot now option. So it is taking some time for the installation. So let it take, depending on the internet connection and all those things. So it will take some time. So here you will be able to see now the option we have got it, reboot now. So you can press tab so that you can go into that reboot now. So I am pressing the reboot now option. So it is telling that rebooting automatically, the Ubuntu 24.04 is rebooting. So here let's wait some time for the Ubuntu to install. So it is taking some time. So now, yeah, here it is installing. So you will be able to see some series of commands and all those things. Yeah, so it is rebooting, and I will try to show you after a successful completion of this reboot. So it has checked everything, and no authorized access keys for the test user and all those things it is checking. So fine. So now that means, so Ubuntu is logged in. So if you press enter, it will ask you for the Docker server login. So that is nothing but our test user, and the password is test1234, which I have given, and press here. So now you will be able to see that you have successfully logged in like test user at the Docker server. So now you will be able to see it, right? So now when now you want to see whether what version of Ubuntu has been installed in the system means, you can take lsb_release-a. Now it will tell you that the distributor ID is Ubuntu, and the release version is 24.04. That is the thing you will be able to see. So now successfully we have installed the VirtualBox, and also we have successfully installed the Ubuntu server 24.04 in our system also. In the next video, what we'll try to do is we'll try to install the Docker engine in our Ubuntu server. Hope you understood about this installation. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. So we have, let's start this our Docker engine. So I am starting this Docker engine. So in our previous video, we have successfully learned about the installation of the virtual machine and also the installation of this Ubuntu server. Now it's time for us to install the Docker server in our Ubuntu server. So how we can install the Docker engine in our Ubuntu server? Let's try to see it. So if you go to our, what I want to say it is in our Chrome, and here you can search for the Docker engine install in Ubuntu. Okay, in Ubuntu, on Ubuntu, anything. So if you try to click on this one, so here the first option you will be able to see the install Docker engine on Ubuntu. So let's try to open this one, and here you will be able to see a series of the installation steps how we can do it. So to get started with the Docker engine on Ubuntu, make sure you meet the prerequisites, then follow the installation steps. So what are those prerequisites is, the OS requirements is you need to have Ubuntu Noble to 24.04 or 23, 22 or 20. So right now we are having 24.04, so there is no problem. And uninstall the older versions. So if you are having already Docker installed in your system, so Ubuntu server or anywhere, so first we need to uninstall the older versions. How can we know that it has been it is there means, so the docker.io, docker to compose, so these all the types of files will be available. So we need to uninstall this one. For uninstallation, so they have given the command. So here you need to use sudo apt-get remove $package. So these are all the for loop, they are looping over the for loop, and the package in docker.io, docker doc, these all things, and they are removing this one all. So that's it. So and also we need to check that whether var/lib/docker is available or not. If it is available means then we need to automatically remove. So these aren't automatically removed, so we need to remove this one. So by this automatically the Docker will be uninstalled in your system. So then here the installation. So there are different ways how we can install the Docker engine. So you can install the Docker engine in different ways depending on your needs. So Docker engine comes bundled with the Docker desktop. So the Docker desktop we have already seen about this one. It's an enterprise edition. So I already told you that for Linux also Docker desktop is available right now. So this is the easiest and quickest way to get started. But we are learning about the community edition Docker engine, so we will install it manually. Set up and install the Docker engine from Docker's apt repository. So this is through the package manager we will be installing. So right now we will be installing it like this only, or install it manually and manage the upgrades manually, or using a convenience script. So these are the different ways how you can install the Docker engine in your OS. So right now I will be installing the Docker engine through the package manager, which is the common usage which we will be doing. So if you want to go with the Docker desktop for Linux means this is the easiest way, and you can continue with this one. So let's try to install this one by one. Before that, let's try to on our Ubuntu server. So here this is the Ubuntu server, and Docker login is test user and test 1 2 3 4, right? So now we have successfully logged into this one. So now what is the step first we need to do it is, so if you try to see here, so the first command what we need to do it is, so this is the command we need to copy. So let's try to copy this one. So I have copied this one, okay, and I will try to paste it here. So if I try to paste it here, so now I am not able to paste it here. Why? Because by default virtual machine comes with a connects through a NAT gateway. Okay, so what is this NAT gateway is? So I told you, right? So it is connected through a NAT gateway. So in the context of the virtual box, a NAT means network address translation. So gateway is a networking mode that allows your virtual machines to connect to the internet and other networks without having a direct public IP address. So that means here, so now this is our virtual machine, right? So this one will be automatically connected to the internet, but this one is connected to the internet using the NAT gateway. Oh, this is the NAT gateway. So this NAT gateway, so it doesn't give you the direct public IP address, and it will connect to the internet and other networks also. So how it works is, this is a private network and inbound restrictions will be there. So that means by default the NAT gateway doesn't allow unsolicited inbound connections to the VM, making it more secure. So because of this one, so no direct access. So other devices on the internet cannot initiate the connections directly with the virtual machine. So that means whatever the things you are copying from the outside means, so you cannot paste it here or you cannot connect it through to the from the external through the NAT gateway. How we can overcome this one is through the port forwarding. So you need to configure the port forwarding rules on the NAT gateway if you want external devices to access specific services running on the virtual machine. So that is one thing. So how we can do this port forwarding is, so let's try to see. So normally the IP address connected for this one is IPA. If you try to see, so normally all the virtual machines, the IP address connected will be 10.0.2.15 and it will be connected to the port 22. So this is the common thing which will be connected every virtual machine. So if you have installed the Ubuntu server in your virtual machine means the IP address will be 10.0.2.15 and it will be connected to the port 22. And what I will try to do is I will try to do the port forwarding. So that means, so here where we can do this port forwarding is, so let's try to go here inside this one and let's open this virtual box, and this is our box running, right? And let's go to the settings, and here if you try to see the network, and it is connected to the NAT gateway. Okay, so we are having so many things, but it is connected to the NAT gateway. And if you click on the advanced, so here you will be able to see the port forwarding. Now port forwarding means nothing but, so whenever your local system is connected to a particular port, so let's say that it is connected to a 2222 port, then it needs to connect to the 22 port. So the 22 port is nothing but our virtual machine. So that means whenever any user connects to this 2222 port, automatically this that will be redirected to the virtual machine. So that is the route I am trying to do. So I am telling to the Docker engine or the virtual box that whoever connects to the external the host machine 2222 port means it should be connected to the 22 port of yours. So that means okay, and we can give the okay. And before doing this one, if you try to let's try to remove this one, I will try to show you advanced and port forwarding, and I will remove this one. Okay, and if I try to connect this one through the external things like putty or anything, so if I try to use the putty, you can install the putty directly, you can install it. So you can search for the putty download, so putty download for Windows, so you can download the putty and free SSH and telnet client for Windows, and this is the putty. And I told you, right, the host name is 10.0.2.15 and the port is 22 automatically. And if I try to click on the open, so right now I cannot connect it. Why? Because from the external device I am connecting to the virtual machine, so I cannot able to make a connection. Why? Because of the NAT gateway. So NAT gateway doesn't allow you to connect from the external device to the virtual box. So now what I need to do is I need to allow the port forwarding, so that I will connect to the 2222 port to the connection timeout. So what I will try to do it is, so here in this one, here let's go to the settings, and in this settings, where is this network available? Yeah, and here in the advanced, so I will go to the port forwarding here, and in this port forwarding I will click on the plus, and here I am telling that whoever connects to my host system for 2222, it needs to be connected to the virtual machine that is available in the 22 port. So that's it. Now if I click on OK and OK, and now let's try to open the putty, and this putty is not connected. So let's try to click on the putty, and here I will be right now I should not use the 10.0 point this one. So I need to connect to the local host, and this should be connected to the port 2222. So local host is nothing but our local system. So whenever I try to connect to our local host, there is nothing but 127.0.0.1, and whenever I connect to this local host to the port 2222, it will be automatically connected to the virtual machine which is available in the 22. So that is nothing but we have added in the port forwarding settings. Now the port will be forwarded to the 22. Now if I click on the open, make sure that the Ubuntu server is on, so this box is on, or otherwise it will not connect. And now automatically it will be asking us login as, so with which user you want to log in. So I can give the test user, and the password it will ask test1234. So this is the password I have kept it, and automatically it has been connected. So through putty it has been connected. So like this you can connect with an external thing. Now you can able to copy paste or anything whatever you want, you can do it. And now another way which we can use it, the most common thing the people will be connecting is, so I will close this one. So the most common way how the people will be connecting is through the command prompt. So I will be connecting through the command prompt. So run as administrator. So now I have opened the command prompt. So whatever the command prompt it will be, it's okay. So this is the command prompt, I have opened it. So now I through the command prompt, through your command prompt which is available in your Windows command prompt, if you want to connect to your virtual box means what you can do it is, so you can use the SSH client. So this will be available in your Windows, so there is no need to worry. And -p, p means the which port you need to connect. The port is nothing but 2222, and you need to give the username test user @localhost, that is nothing but the host name. And if you press enter, it will ask you some SSH fingerprint. So you need to type yes here, yes, and automatically it will be asking you for the password. So let's type the password test1234. Now through the command prompt you are automatically able to connect to the what I want to say is to your virtual box. See, now here directly you can use it. So this is how you can connect through the external to your virtual box machine. So hope you understood about this one. Then afterwards what we will try to do is, so I will be starting this virtual box server, but I will not do the coding from here. Automatically I will go to the command prompt and I will connect through the, so if you type exit, automatically you came back, and if you want again you can do the SSH-p, automatically you will be connected to the virtual box machine. So you can do S here, okay, so permanently added, and here you can say test1234. So automatically this one will be logged in. So this is how you will be doing the port forwarding. So you can work on this one. So in the next video what we'll try to do is, we will try to install the Docker engine in our Ubuntu server. Then afterwards we will try to work on the Docker thing. Hope you understood about this NAT forwarding thing, port forwarding. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. So in the previous video we have seen how we can connect to the Docker engine through the external sources like SSH or putty. We have seen it. Why? Because the NAT gateway doesn't provide us to connect from the external resources. So that is the reason. So we have used the port forwarding in order to connect through the external resources like SSH. So now it's time for us to install the Docker engine in our Ubuntu server. So I am turning on the server. So let's switch on the server here. So it is booting. So after switching on the server, so what we'll try to do is, we will connect through the SSH portal. Then afterwards we will install the Docker engine in our Ubuntu server. So here I will be logging with the test user and the test1234, right? So now it is working fine. So let's connect through the command prompt. So I will be not using the commands here. So we will connect through the command prompts. So for this one what we will try to do is, I will be using the command prompt here. I will open with and run as administrator. So you can use any command prompt. I am using Visual 2017, something like that. So let's CLS, clear it out. Yeah. So I will zoom over so that you can able to see the commands what I am trying to type. And here I will try to keep this one aside. And we will see another one is nothing but in this one. So we will see how we can install the Docker engine. Install Docker engine on Ubuntu. So here you will be able to see the first one. And here if I try to make it, I will try to minify this one. So how can I minify this one? So not minify, so resize this one so that we can read one by one. Now I am resizing this. Yeah, fine, right? So hopefully this one is looking nice. I will try to minimize some more, and I will try to, yeah. Oh no, fine. So this is what I will be keeping. And now I will connect to our portal. So that is nothing but SSH-p 2222 and test user @localhost. That's it. So now I hopefully I will be able to connect. Let's connect. It will ask you, it will take some time. So let it take. Yeah, it is asking the password test 1234. So I have, now we are able to connect it. So now all the Linux commands and all those things will work, like control L, clear, and all those things. So what we have learned in our Ubuntu, Linux Ubuntu commands, those all commands will work right now. So this is our thing. So now if you try to check ls-l, so right now we don't have anything, and if you try to go to the cd dot and you will be able to see only one user, that is test user. So this all we have learned it. So I have moved it to the home page. Now let's see here. So install the Docker engine on Ubuntu. Let's go here. So these are the prerequisites. So that means before installing to get started with the Docker engine on Ubuntu, so you need to make sure that you meet all the requirements and all those things. Then only we need to follow the installation steps. So at the bottom, what is the OS requirements is you need to have at least any one of the version of the Ubuntu OS. So right now we are having Ubuntu Noble. So if you want to check that, means lsb_release-a. Now you'll be able to see the code name is Noble and the Ubuntu and 24.04 LTS. We are having the operating system, and here, so the latest version only we are having the latest LTS version. And the next one is what we need to do is, so before installing the Docker engines, first you need to make sure that you don't have any older version of the Docker installed in your operating system. So that means, so we need to uninstall any conflicting packages. So now here, what are the unofficial packages to uninstall are docker.io, docker compose, compose v2, docker doc, podman docker, these are all the things. So now these all the things need to be removed. So what it is trying to do is, here it is giving one command that it is looping over for loop over all the each packages it is looping over, and it is trying to remove each one. Sudo apt-get remove package. So we are sure that the Docker is not installed. So this is a fresh installation, and we are sure that it is not, the Docker is not installed in our system. So we will not continue with the step, or otherwise if you want, means you can copy this one and you can paste it here. Sorry, where did I copy this one? Oh sorry, not the entire thing I need to copy. So I copied this one and I am pasting it here. See, for package it is looping over each one and it is doing the sudo apt remove the package, done. So now let's try to press enter, and now it will ask you. So if you are trying to use the sudo, so right now test user is a sudo user only. So for the first time it will ask you the password, and it will be valid for the 15 minutes, and after 15 minutes it will again ask you for the password. So now when I press enter, so it is checking all the things, and it is telling that, so you will be able to see everything is not installed. So here you will be able to see docker.io is not installed, so not removed, and docker doc is not installed. So it is trying to see all the things to uninstall, but we are sure that the Docker is not installed. This is a fresh installation we are doing, so that is the reason. So we haven't found any package. Now it is also telling that, so then all the volumes and the networks and the containers which you have created, the images and all those things which we will be trying to do in the later courses, later videos. So those all the things will be stored in the var/lib/docker, it seems. So that folder will not be automatically removed. So you need to remove it manually, it is saying. So that means let's check that whether it is available or not. So I can do ls-l/var/lib/docker. So this is the folder, it is telling that it will be existing. So if I try to check, so no such file or directory, it is saying. So that means that directory is not available in our OS. So now, so we are sure that the older version of the Docker is not available in our system. Now it's time for us to install the Docker engine. So the installation methods. So here you'll be able to see there are different ways how we can install the Docker engine in our Ubuntu server. The first method is Docker desktop for the Linux. So this is a straightforward and enterprise edition. Now previously in the earlier we used the Docker desktop is available only for the Windows and the Mac. So right now the Docker desktop is available for the Linux operating system also. So Docker engine comes bundled with the Docker desktop for Linux. So this is the easiest and the quickest way to get started. So if you want, you can install this Docker desktop, but we need to do it manually and we need to install each and everything by ourselves. So that is the reason I will install the Docker engine. And the second one is using the setup and install the Docker engine using the apt repository. So apt repository means that is nothing but packages. So using the Docker package repository, so installing. So we will do the second step. And if you want to install it manually, and if you want to manage upgrades manually, means then you need to you need to follow this step. or otherwise if you follow the convenience scripts means only recommended for testing and the development environment means, so this one you can use it. So right now I am installing the Docker engine through the Docker apt repository. So let's try to see it here. So this is the first step, it is coming. So install using the apt repository. If you click here also, so you will go to this place only. So now if you see here, before you install Docker engine for the first time on a new host machine, you need to set up the Docker repository. Afterwards only you can install and update the Docker from the repository. So that means it is telling that we need to set up the repository. So that means we need to add the repository Docker to the Ubuntu server. So first, before proceeding this one, first we need to run the command sudo apt-get update, or otherwise sudo apt update also you can run it. So whichever it may be. So I am doing sudo apt-get update. So it will read all the package repositories in the Ubuntu and it will try to install everything. So let it install it. Debian package, it will try to install, it will try to read all the Debian packages and it will install it. So finished. So before installing the Docker, so it is telling that we need to install the CA certificates and the curl. So by default, when you are installing the Ubuntu server, so these two packages will be automatically available in your system. But for the safety side, it is telling that you need to install. So for us in our system, almost all the systems, the curl package and the CA certificates package will be available automatically. So if you want to make sure means you can run that command. So here you will be able to see CA certificates is already the newest version available and curl is already the newest version available. So that means the two packages are already available in my system. So there is no need to install. But in order to install the Docker engine, so you need to make sure that these two packages are installed in your system. So that is the reason. So this is the command that has been given before installing the Docker. Then afterwards the second one is, so here we need to create a new folder for the keyrings, for the creating of the public repository, GPG public repository. So we need to create a folder keyrings, etc/apt/keyrings. So let's copy this one and paste it. So now if you try to, and here I will copy and here I will paste it. Yeah. So now if you try to see ls-l/etc/apt/keyrings. So now you will be able to see, so that package, so not that package. So now the folder has been created with the keyrings, and so that's it. There is no file that is created. Now the second command which you will be able to see is so now we need to download the Docker GPG package and we need to paste that keyring in the docker.asc file. So that is one thing. So let's copy this one and here it will copy. So what it is trying to do, it is trying to get the repository keyring GPG package from the download.docker.com GPG and it is pasting in the keyrings docker.asc file. So press enter, automatically this will be placed. So now if you try to see here the ls package, so now you will be able to see a docker.asc file is available in the RWR. So these permissions and all those things also we have learned in our previous Linux course. So now if I try to open the docker.asc file, so cat/etc/apt only, right? apt/keyrings/docker.asc file. If you try to open, so this is the pgp public key block. So I don't want to go too much into this one. So now let's try to go to the next one. So here what it is trying to do, so it is trying to give the all read permissions. So for the both the owner group and also to the others, it is trying to give the all plus a means all plus r means it is giving read permission to the docker.asc. So already the read permission is available. If you try to see, already the read permission is available for all this. To make sure that if it is not available, so it is trying to give the read permission to this one. So let's try to use it. So now nothing will happen. So already we have a read permission, but it is safe for us to run. So otherwise it will permission denied you will get. So now that one is finished. Now we need to add the repository to the apt sources. So now we need to add it to the Debian packages, that repository, that Docker repository. So that is nothing but signed by this docker.asc, and here you will be able to see download.docker.linux/ubuntu, and we will be placing it in the, you will be able to see sources.list.d in the etc/apt in the sources.list.d D folder, docker.list file will be created. Now if you need to copy this one and directly copy and you can paste it here. So directly in the sources.list.d folder, so you will be able to see a docker.list file. So now automatically it will be created. Fine. So now after adding this one, so what you need to do is you need to run the apt-get update. So sudo apt-get update, directly you can run it. Why? Because we have added this docker into our Debian package, right? So that is the reason. So we have read it. So that's it. So now, so we have added these repositories to this one docker setup, docker apt repository, package repository has been set up. So now what we need to do is we need to install the docker packages. So what we will be installing the docker packages. So first we are installing the docker-ce, that is nothing but community edition. So docker community edition we are installing, and the docker ce CLI and the client side docker client we are installing, so that using this docker client only we can communicate to the docker servers or the docker engine. So just like how you will be having MySQL server and the MySQL client, in the same scenario we will be having the docker engine and we will be communicating to the docker engine using the docker client. And we are having the container D. So this is the container D which is used by the docker engine to create the containers. And last one you will be having docker buildx-plugin and the docker compose-plugin. So these are the plugins which is available, which is need to be installed. So let's try to copy this entire thing. Oh sorry. So let's try to copy this entire thing and I am pasting here. So now, so we are installing the docker. So now let's try to press enter. So if I try to press enter, so it will ask you that do you want to install all these things. So okay, fine. So like you can press enter, or otherwise you can type capital Y and press enter. Automatically it will try to download from the docker and everything. So it will take some time to install. So let it install. So if you want to install a specific version of the docker, means you can go to this next tab, and here you will be able to see available versions of the docker available, and you can install whichever the thing you want. So here if you want to list all the available versions, means so this is the command you need to take, and you will be able to get all the versions available in the docker, and you can take that particular version and you can install it. So here at the bottom, select the desired version and install it. But right now I am going for the latest version only, so I don't want to bother this one. So right now the latest version is 26.1.0. So I will try to show you. So that is the latest version docker engine we are having right now. So if you want a older version, if you want to install me, so that is nothing but you can install it. So fine. So everything is installed. So let's try to if you want to check that whether the docker has been successfully installed or not, means then what you need to do is, so just you can use docker-version. So you can check for the version. So right now I already told you, right, 26.1.2 is the latest version. So right now installed. So this is how you will be installing the docker. So that is what about the installation of docker engine in our Ubuntu server. So we have used the Debian auto package manager repository to install the docker engine in the Ubuntu server. Hope you understood about this concept, installing this in the Ubuntu server, the docker engine. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see about the default parameters that are available in the docker engine. So I am switching on the Ubuntu server. So double click on this one. Automatically the docker engine or the Ubuntu server will start up. So let's wait for some time, powering the VM up. But I will be not using this VirtualBox system, so I will be going through the SSH thing. And I have explained you about that, how to install the SSH and NAT gateway, how we can connect externally through the virtual machine. So I have shown you. So that one you can take a look at our previous videos. Now we have also successfully installed the docker engine also in our Ubuntu server. And now we need to check the default parameters that are available in the docker engine. And also we will check whether the docker has been successfully installed in our system or not. So I will try to show you. So now the Ubuntu server has started. So let's go into here. I will minimize this one also. I will maximize this one. And here I am connecting to the docker engine. So here, the docker host machine, that is nothing but the Ubuntu server. So 222, right? Test user @ localhost. So that's it. Now let's try to press enter. Automatically it will try, it will ask the password, that is nothing but test1234. So now it has successfully connected to this one. So now when I go here, now what we need to check, so whether the, if you want, so right now it has been logged in as a test user, so that means it is a sudo user. So if you want to check that it is a sudo user or not, means su-l, I think. So test1234, sorry, that is not the password, sudo-l. So if you type test1234, you will be able to see that this guy is a sudo user and it has all the permissions. So user, test user can run the following commands on the Docker server. All the commands he can run it. So that means he is a sudo user. So fine, test user is a sudo user. Now if you want to log in with a root user, means then you need to type su-i. Su-i, I didn't remember exactly, sui. So sudo-i, I didn't remember exactly how to log in with the root user. Yeah, so sudo-i, then that su means it's a switch user, so substitute user or switch user. So fine, sudo-i means, so we'll log in with a root user. So if you want to come out, means then what you need to do, so you can use the exit, automatically you can come out of this one. So now this is the main thing. So these are all the things we have already covered in our previous Linux commands tutorial. So you can, for more details, you can take a look at that one. Now what we need to do, first we need to verify whether the Docker package has been successfully installed in our system or not. So in order to check this one, so what we can do it is, we can use the command something like dpkg, okay, and Debian packages. In this one we can check -l, and if you press enter, so you will be able to see lot more packages that are available in this one. So I don't want to check in this one. So here what I can do it is, so here let's try to, I will try to search it, grep docker, okay, docker-ce, or docker also you can do it. Now here you will be able to see the docker-ce, docker-ce-cli, docker-ce-rootless extras. So these are all the things that has been installed. If you are able to see here, I is there, II is there. So that means it is nothing but okay installed. So that means if I is there, means it has been installed. So the docker-ce has been successfully installed. If you want to check for the container D, so you can write the same thing and you can write it here, container D. So this container D is one of the package which is useful for creating the containers. So we'll try to learn about these containers also. So just I am showing you that, so this container also has been successfully installed. So the last one which we have installed using the while installing the Docker engine is Docker Compose. So if you want to check it, so here you can write have something like docker-compose. Now you will be able to see that Docker Compose plugin is also successfully installed. So this is one way in the server point of view in order to check whether the Docker has been successfully installed or not. So through the client perspective also we can check. If you want to confirm from the docker CLI command from there, means then you can use something like docker -version. So it will give you the current version, the current Docker version that has been installed, that is nothing but 26.1.2. So this is the way how we can check the Docker whether it is installed or not. We can also see using the command, another one something like docker info. So these command give you the complete information related to the Docker. So if you press enter, so it will try to give you the details, but here you will be able to see that permission has been denied while trying to connect to the Docker daemon, that is where run docker.sock. So this one, the permission we don't have for the test user. We know that this guy is a sudo user, so you can do the same thing using sudo docker info. So I will try to explain you how we can run this docker info without using the sudo command also. I will try to show you. First let's try to see the information related to the Docker. If I press enter, so here you will be able to see the lot more details. Let's try to go one by one. The first one is the information related to the Docker client. I told you about the Docker client, right? So the Docker client means it is nothing but which will connect to the Docker server. Whatever the commands you are trying to write it, you will write it in the Docker client, and the Docker client will connect to the server and it will execute those commands. So that's the thing. So here you'll be able to see the version of the Docker client, and the debug mode is for false, and what are the plugins that has been installed, and where is the plugins, the path of this one, and it is also showing the Docker compose. So where this Docker compose is there, and it is showing the version of the Docker compose and the path where it is located. So this is all related to the client information. And if you come here, you will be able to see about the server. Server means it is nothing but a Docker engine, and how many containers has been created. Right now it is a fresh installation of the Docker engine, so we haven't created any containers. So that is the reason we are having 0 containers. So we will try to create the containers in the upcoming videos. First, at the starting, if you try to see the Docker info, so here you will be able to see what are the total number of containers that has been created. If it is created means how many are running, how many are paused, and how many are stopped. So you can able to see the details of all the containers. And here you will be able to see the images also as 0. So think of these containers as the application and images as an ISO. So for example, think of this container. So for example, if you want to install any application or anything, means you need to have an ISO image, right? For example, let's say that you want to install a Ubuntu server. So Ubuntu server means you need to have an ISO image. So that is nothing but an image, and installing the Ubuntu server is a container. So if you want to create a container or create an install the container means, then you need to have an image. So that is the thing which I want to explain you. So the images which we are having is also 0. And the Docker server version is 26.1.2, and the storage driver it is using is overlay 2. So these are all the different types where these are the different configurations that are available. Login driver JSON file. So how the logging will be happen is in the JSON file, and the C group driver, C group versions, and here you will be able to see the network and the log. So default runtime is the run C, and you will be able to see the container D version and security options, a kernel version, and here this is all about the Linux, the host machine what you are having. So about the Linux Ubuntu server which we are having. So kernel version and the operating system and the OS type, architecture, these are all the things you'll be having. So whenever I tell about the Docker host machine means it is nothing but this Ubuntu server. So the Docker host machine means nothing but where in which host machine the Docker has been installed. So that is called as a Docker host machine. So don't confuse when I tell Docker host machine means it's something else. So the Docker host machine is nothing but this Ubuntu server. Why? Because in this Ubuntu server only the Docker has been installed. Then we can call it as a Docker host machine. And the Docker root directory. So this is also one of the important thing. If you try to see, the Docker root directory is available in /var/lib/docker. So whatever the things all available in the creation or whatever the things we are creating or installing in the Docker means it will be created here in the var/lib/docker. So if you try to check this Docker thing, so then you will be able to see. So for example, ls-l/var/lib/docker. If you try to check it, so we don't have any permission for this one. So let's try to log in within root so that we can able to have it. So now here I want to check ls-l, okay, /var/lib/docker. If I try to show you, so these are all the things have been created by the user root, and the group owner is also a root. And here you will be able to see these are all the directories that has been created automatically. So whatever the things you are creating, those all the things will be segregated here. So if your volumes, swarm, runtimes, plugins, and the containers and the images, network, build kit, everything whichever you will be creating, the plugins and all the things will be segregated and will be arranged according to its directory. So that is all about the Docker thing. So now what is the thing we have observed is, so right now whichever the thing we are trying to do, so if you log in with the root user, we are able to get it. So that means the normal user cannot able to execute the Docker. So for example, let's say that I went back to the test user. So this is the normal user, but you know that this is sudo user. Now normal user cannot execute the Docker commands. So for example, if I try to execute the Docker, we are able to get it. But here if I try to use the Docker info, I am not able to get it. Why? Because the permission is denied. Okay. So that means here this all depends on the requirement. So if you want to run it with a sudo permission means, then you can able to write, you can able to work. So but here the requirements matter. So if you want the normal user also able to execute the Docker commands means, so then you need to add that normal user into a group. So that is nothing but a Docker group. For example, if you check this all the groups list, so cat all the groups will be available in cat/etc/group. Okay, so these are all the groups which are available. So here you will be able to see all the list of all the groups available in this one. Here you will be able to see Docker is available. So if you want to search it, grep Docker. Okay, so if you try to check here Docker, this is the group which has been created, and this is the Docker ID. Sorry, group ID. So Docker is a group. So this is not an user. So if you try to check in the user also, so users all will be present in the password, and you can search for the Docker user. So whether the Docker user is available or not. So it is not available. So that means only a Docker user is there, and you will be able to see it, right? So whenever you are trying to do Docker info, so it is telling that permission is denied, and it should be something like var/run/docker.sock. And if you try to check the permission for this one, ls-l/var/run/docker.sock, right? Docker.sock means you'll be able to see that the owner belongs to this one is a root, and the group belongs to a Docker. So now whenever you are trying to run the command docker info or docker anything means, then it is trying to execute the file docker.sock, which belongs to a group of Docker. So that means when you add this user, test user, to the group of Docker, then automatically so the test user can able to execute this one. Why? Because the owner has a read write permission, and also the Docker has also group also has a read write permission. Fine. So let's try to add the test user to the Docker group. So for adding the test user to the Docker group, so we already know the command, that is nothing but, so let's move on to the root here. So we know the command user mod, and we need to append the groups. Already if the test user belongs to some other groups means we'll keep the groups like that only, and we are appending a new group. So that G means group, and what is the group we are trying to add? Docker, and that is nothing but test user. To which user? Test user. Now if you press enter, automatically test user will be added. Now here if you try to see, you can check whether the user is added to the group or not, means you can check cat/etc/group, and you can search for grep Docker. Now if you press enter, now see this is the Docker is the group, and this is the group ID, and here these are the users which are available, which have been added to this group Docker. Now the test user has been added to the group Docker. Now the test user belongs to a group of Docker. Now if test user belongs to a group of Docker, right? So now he can able to execute the run the what I can say docker.sock file. So now let's try to run this one. So here let's try to execute, and I am back to the test user, and here what I will try to do is I will run the docker info. Let's see docker info, and if you try to see here, so still we are not able to access it. Why? Because maybe so we need to restart the server, I think Docker service, or we need to restart the Docker service in order to check the status of this Docker. So what you need to do it is sudo -i. Let's go here, and in order to check the status of this Docker means systemctl status docker, and if you try to see here, this has been started 13 minutes ago, and it is active and it is running. So Docker has been created here. So 30 minutes ago it has been started. Why? Because so we just now we have started the virtual machine, right? So at the time only 30 minutes ago it has been started. So now, so this is active and running. So what I need to do is I need to restart this Docker service. So in order to restart this Docker service, so what you will try to do it is, so let's try to go here and systemctl restart the Docker. Let's see. So restart the Docker. So Docker has been restarted. So let's see the status, and here you'll be able to see that has now previously it was 13 minutes ago. Now it is 2 seconds ago. So that means the Docker has been restarted 2 seconds ago. Now let's try to reboot the system. So here if I go back, not reboot the system. So let's try to check whether we can able to get it or not. So I am going to exit, and here I will do docker info. Still I am not able to access this one. So if you try to check this group, whether the var/run/docker.sock, if it is available, the group means, so we are able to see that successfully the docker.sock belongs to the group of Docker only. So the only option what we have remaining is, so we need to reboot the system. So let's reboot the system. So test user doesn't have anything. So let's try to do it with a sudo reboot. Why? Because it's a sudo user. So automatically the system is getting rebooted. So here you'll be able to see. So the Docker, our Docker Ubuntu server is restarting. So let's wait for some time. Let it restart. Then afterwards we'll try to run the Docker info with the test user. So now you should be able to execute the Docker info command with the test user. So now the normal user also who belongs to the group of Docker can be able to execute the Docker commands. So let's try to see this one. So now hopefully we are able to login in. Yeah, so it is asking the login, right? So now here I will go into this one, and the same thing like SSH, I am connecting to here, and it will ask me the password. Okay, test 1 2 3 4. And if I try to log in, yeah, so now I am able to log in. Now the test user, so let's try to run the Docker info. So Docker info. Now if you see here, now I am able to get all the details. Now the test user can able to execute the Docker commands. So Docker commands also he can able to execute. So if you try to see Docker container, so sorry, Docker, so here we are able to get these all the things, right? So these are all the commands which you will be able to see. So what is this one? So here Docker images or Docker PS, you will be able to see Docker images. Docker images you will be able to see. So Docker PS means it will give you all the current containers that are available. So like this you will be able to get. So that means now test user can able to access the Docker commands also, Docker CLI commands. So this is how these are all the parameters that are available in the Docker engine. So in the next video we will try to learn about what is a Docker container, and we will try to create a Docker container, first container in our Docker engine. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the concept of Docker container. So let's try to learn what is a Docker container and what are the technologies that are relied behind the Docker container or the Docker engine. Let's try to see. In the previous session, we have understood what are the Docker default parameters and how we can check these Docker default parameters by using the Docker space info. So if you try to type the command Docker space info in your Ubuntu server, so you'll be able to see all the parameters or the Docker in related information regarding the client and the server information, everything you can able to see it. So we have discussed about each one in our previous video. Now let us understand what is a Docker container. Before Docker came into the picture, so we used to have LXC. LXC means it's a Linux container, but it is specific to only one platform. That is nothing but one OS only. So it is specific to only one particular platform. Docker is a cross-platform, which means I can install on Linux, Windows, Mac, or any kind of operating system. So whereas in the earlier we used to have a Linux container in order LXC to create the containers, and that one is only working in only one particular platform, that is nothing but in the Linux. And if you want to use this LXC in another operating systems means we cannot use it. Whereas the Docker is a cross platform, so that means you can use the Docker in any operating systems like Linux, Windows, Mac, Unix, any kind of operating system you can use it. Docker has been written in Go language, and it is released as an open source in 2015 or 2013, something like that. So the Docker, the language which was written, Docker is the Go language is the language which was written by the Docker, not by the Docker. Docker was written in Go language. Docker did not develop any new functionalities. So if you try to understand, Docker doesn't have any new functionalities that has been introduced. It is just using the existing functionality of the Linux. So those functionalities are nothing but kernel namespaces and C groups. C groups are nothing but control groups. And it is having its own functionalities as well. So other functionalities also it will have. So the main functionalities are, it will use this Linux existing functionalities, kernel namespaces, and also the C groups, which has nothing but control groups. That is the reason why Docker became more popular than any other tool. So why it has become popular? Because Docker is a cross platform. So let us discuss what are the components we have in the Docker engine. So whenever I am talking about the Docker server, Docker engine or anything means, so both are one and the same only. Server, if I am telling like that means three are one and the same only. So the first one is the Docker daemon. So here discussing about the components we have in the Docker engine. So the first component is Docker daemon. In Docker engine we have a component like Docker daemon. So it's not a Java, actually it's spelling mistake. We have a component like Docker daemon which is nothing but a server. If you remember, while installing the Docker engine, I have shown you the package called Docker CE. That is nothing but community edition. That is nothing but your server package which is also called as an Docker engine. So this is the Docker daemon. So that is the main thing. And the another one is a Docker client. Next we have a Docker client which you execute the Docker CLI commands like Docker pull, Docker push, Docker container create, Docker image pull, something like that. We will be using different types of commands. So in the Docker client, and this Docker client will talk to the Docker engine or the Docker server. And the last one is the Docker registries. So if I want to create a containers using the Docker engine means first I need to download those images. So whenever you try to create an image, first you need to download the image or we need to use the image. Using the image only we can create a container. Without using the image we cannot create a container. By using that images I have to create a container. Docker registry is nothing but we have predefined images, just we need to use it, that's it. So think of this Docker registry is nothing but dockerhub.com. So like just like the npm registry how you will be having, so all the public npm packages in the same scenario. So you will be having all the Docker images, public Docker images, just you can pull it and you can use that image. If you want to build your own images, if you don't want to use that predefined images means you can do that. Docker registry is an open source, everybody can download images and create a container. For example, let's say that already predefined image you don't want to use it, you need to build your custom images means then also you can do it using the Docker. That is not a problem. The last one is the next one is the Docker objects. So what is these objects? Objects are nothing but downloading the images, managing the images, creating the container, managing the container, creating and managing the volumes, networking services, etc. Technically we call these all things as objects. So underlying technologies that are used in the Docker. So first we have learned all the Docker components. So now we need to learn underlying technologies that are used in the Docker. The first one is the namespaces. It is an existing feature in the Linux OS, means Linux kernel. So those are nothing but PID, net, IPC, mount, etc, UTS. These are all namespaces that are used in the Linux, that are used in the Docker. C groups. You can limit the memory and CPU available to a specific container. So using the control group, you can limit the memory and CPU available to a specific container. Control groups are nothing but, C groups are nothing but control groups. It means I will assign some memory and CPU to the container and it should not cross beyond that. So that will be taken care by the control groups. This will be taken care by the C group or the control group. The next one is the union file system. If you write some content in a container, we need to use some specific file system, right? So whenever you are writing some content or creating some content in a container means, so we need to have some type of file system. So we have something called as an UFS device mapper, BTRFS, VFS, etc. So this type of UFS device mapper, so these type of things are their file system. And another one is a container format. So this is one thing you need to understand. It is nothing but, so whatever the features we have learned it, right? So something like namespaces, C groups, file systems. So these all the things are bundled together and they are made into a particular format, and this format will be used by the Docker. Let's say that for example in our Windows, best example I can say that you have a file and you want to zip that file. So we have different types of zipping. 7z is there, zip is there, tar.gz is there. So these all does the one and the same only. So compressing the file. So we have a different formats in the same scenario. So container formats also we have different formats. We have a container format example like libcontainer, bsdjl, solaris jones. So these all things what it will have contain is, in those it will contain kernel namespaces, control groups, file system management. So these are the things you will be having. And what is the format the Docker will use is the libcontainer. So right now Docker is using the libcontainer in the backend. It is using this particular format to handle multiple functionalities related to the container creation and many more. So this is the image which I want to try to show this Docker architecture. So at the bottom you will be having a Docker server, that is nothing but a Docker daemon, and in between this one you are having REST API and Docker CLI, and the Docker CLI will communicate to the Docker daemon using the help of REST API, and the Docker will manages the data volumes, images, container, networks. These are all the core functionalities of the Docker. So I will try to explain you this. This is the image, and let's go here. In the diagram you can see the Docker server and the Docker CLI. So here you will be able to see the Docker server, that is nothing but Docker daemon, and also the Docker CLI client. We will run the CLI commands and it will reach to the Docker daemon using the REST API call. So that means the Docker CLI will run the commands and the Docker daemon will receive that command using the REST API call. So what are the functionalities we have to learn in the Docker? So the four core functionalities what we need to learn in the Docker is the outside boxes 4 are there, right? So these are the 4 functionalities which we need to learn in the Docker. Images, container creation, networking, volume management, and building custom images. So that is nothing but images and container, networking, and data volumes, volume management, and building custom images. So these are all we need to learn. Not only we are using the existing images, we are building our own images with the concept called Docker files. So existing images means so already predefined images not only we are using. So if you want to build your own images means with the concept called as Docker files, you can create your own custom images also. These are the major core functionalities of your Docker engine. So this is the architecture of the Docker. So you will be able to see primarily there are two things, client and the Docker host. Docker host is nothing but your Docker server, that is you are having Docker daemon. Inside the Docker daemon you will be able to see what are the things it is happening. So Docker daemon will take the existing image and it will create a container out of this one. If the image is not existing means then it will take the image from the registry. And here the commands, the client is sending the commands to the Docker host. So and the Docker daemon is executing the particular command. So that is the architecture of the Docker. In the previous diagram we have Docker CLI, Docker host, and the registry. So these are the three: Docker client, Docker host, and the registry. First we will execute the Docker CLI commands in your local system. So that means in our local system we will execute the Docker CLI commands. Now the CLI commands will talk to the Docker host machine with medium something called as an Unix socket. So how the CLI will send the command means with the help of the Unix socket. Okay, so that Unix socket is present in /var/run/docker.sock. I have shown you about that file also. I have shown you that file in our previous video. It uses a socket layer in order to transfer the information from client to the server and server to the client. So this is the medium what we are using right now with the machine itself. So this is the medium what we are using right now within the machine itself. So within the machine, if you want to talk with the Docker CLI and the Docker daemon means, then we are using the Unix socket layer. That means my server and client are running on the same machine, and it is using the Unix socket to transfer the data between them. So that means the Docker client and the Docker server should exist in the same machine only. That means in the same local machine only it should exist, and that client will talk to the server using a medium called as an Unix socket. Once the data has reached the Docker server or the Docker engine, it will take the request and it will do some particular processing in the backend. Then it will search for the image. Let's say that I am trying to create an Nginx container. First it will see in my local system whether I have the Nginx image available or not. My Docker daemon, first it will see whether Nginx image is available or not. If the image is not available, it will talk to my registry called Docker Hub. I told you, right? And we will see these all the practical implementation. So just I am trying to explain you theoretically. The Docker Hub is a registry where you can download some public images. So if you want to download the private images, then you have to authenticate whatever it is. So if you are having some private images or in anything means, so there you need to have authentication. Then only you can download that image. It will download the image and store it in the local system where you run the CLI commands, and there it will create a container. So that means whenever you want to create a container, first it will search for the image whether it is available in your local system or not. If it is not available, then it will try to download the image from the registry, and then it will store it in our local system. So where you run the CLI commands, and then it will create a container. So this is the process exactly how it will happen. So without an image you cannot create a container. So that means if it doesn't have any image means you cannot create any container. So this is the basic workflow of what happens when you try to run a CLI command. These are two major components which interact with each other with the help of Unix socket. There is nothing but Docker CLI and the Docker daemon. So these are the two major components which interact with each other with the help of Unix socket. So now Unix socket means you will be having some doubt regarding this one. So the Unix socket is available at the path var/run/docker.sock. You will be able to see that one. It is a non-network Unix socket. So this Unix socket is a non-network Unix socket. So that means your CLI and Docker server has to be running on the same machine. Let's say that your Docker CLI and the Docker server are on the different machines. So Docker CLI is on one machine and the Docker server or the Docker engine is on another machine. Both cannot talk to each other using this Unix socket. So whatever the Unix socket right now we are having, both cannot talk to each other. It is not transferred over the network. If you really want to communicate with the Docker server which is sitting in another machine means, then we have to use something called SSH based communication or TLS based communication. So right now in the Docker we are using non-network Unix socket. So this one we'll try to see later in non-networking thing. So right now we are using non-network Unix socket. So this is all about the explanation about the Docker container. Hope you understood about this one. So one thing what you need to understand is the Docker architecture. So what it will try to do. So whenever we try to type the command, whenever we type a command in the Docker CLI, sorry, one second. Where is my, one second. So this is the architecture you need to understand. So here we are having a Docker client and the Docker host. So the Docker client will talk to the Docker host using a non-network Unix socket. So you need to understand that this Docker client and the Docker host should be available in the same machine. It should not be present in another machine. So this one cannot be in another machine and this one cannot be in another machine. And now this Docker client will try to send the command. So using the non-networking Unix socket, and the Docker daemon will take that command and it will try to create the container. So for creating the container, what it will try to do is the Docker daemon will try to check the image whether the image is locally present in the system or not. If the image is locally present in the system means it will directly create the container. So if the image is not available in our local system means, then it will go to the Docker registry, that is nothing but Docker Hub, which is a public repository. It is an open source, anybody can download that images from there, and there it will try to download the image first into your local system, and it will place that image in your local system. Then afterwards, using that image in the local system, it will create the container. So this is the total workflow. Here I am trying to explain it. So then again, if you want to create the same image means already it has been downloaded into your local system, then it will try to create the container directly. So this is the workflow, actually the Docker, exactly what it is happening. So hope you understood about this Docker container. In the next video, we will try to create an Nginx container using this image and this workflow. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see how we can create the container in the Docker engine. Let's try to see it. So I already told you, right? First, what we need to do in order to create a container. So first, we need to get the image. So now what I will be trying to create a container is nothing but the Nginx. So let's try to start the Nginx container, create the Nginx container in our Ubuntu server. So first what we need to do, so in order to create Nginx container, first we need to get the image of this Nginx. So if the Nginx image is available in our local system, automatically we can create the container. If the image is not present in our local system, then what we need to do, so we need to download it from the public registry. The public registry is nothing but in our Docker, it is nothing but the Docker Hub. So first we need to search for the Docker Hub. So first we need to search for the image in the Docker Hub. So let's open this Docker Hub. So here this is our system, right? So let's log in into our SSH. So let's open the command prompt. I am opening the command prompt here. Yeah. So I have opened this command prompt and here I am connecting -p. If you have putty, you can also connect with the putty mobile exterms or something like this. So many SSH tools will be there, right? So you can connect with anything. So just I am using this command prompt SSH. So this will be available natively in the Windows. There is no need to problem. So SSH-p 2222 and the test user @localhost. So now if you try to connect it, it will ask you for the password. So if you are So 1 2 3 4, that's it. So you have logged in into your password. So it is telling that 4 updates can be applied immediately. So let's remove that one. So now what I want to do it is, so I need to download the image. So in order to download the Nginx image, what you need to do is search in the Google for the Docker Hub. So now I have searched here for the Docker Hub, and if I try to open the first website, so this is the first website, and if you try to open this one, so this is the Docker Hub container registry, and here you will be able to see Docker Hub container image library, and you can able to see all the type of images in this Docker Hub, just like the npm registry. So how you will be having the npm packages public one, how you will be downloading it. So like this is the thing, and here I will be searching. So here you will be able to see the search, and the sign in and sign up will be there. So there is no need to sign in and sign up for this one for searching. So here I will be searching it for the Nginx, and if I click on enter, and you will be able to see lot many search results. So you will be able to see so many results for the Nginx search. And how we can able to identify this one is, so here you will be able to see Docker official image. So here you will be able to see a badge. If you try to carefully observe, you will be able to see a badge here. So this is a Docker official image. So we need to give more priority to this one, and here it has been downloaded 1 billion plus, and the stars has given 10k plus, and this is the official build of Nginx. Total pulls has been taken something around 72 lakhs, something like that, and this is the, so this one is the thing which we need to give the highest priority, Docker official image. So this is the trusted one, and if you don't find any Docker official image for the particular search you are trying to do it, then the second one which you need to give it is the tick mark, that is nothing but verified publisher. Then you need to go to the verified publisher, and if you doesn't find any verified publisher also, then we need to go for the sponsored OSS. So at the bottom you will be able to see this is the sponsored OSS, so followed by the least priority. So like this you need to take as the priority. So right now we have a Docker official image, so you can take this one as the more priority. And if you try to search it for this one, so you can click on this Docker official image. So here you will be able to find only the Docker official image, and this one is an Nginx unit, and here this is the Nginx. So this is the thing which we wanted, and I need to download this image. So how we can download this image? So we can click on this Nginx, and you will be able to see Nginx official Docker official image, and you will be able to see the overview of this one. And supported tags means nothing but you can say it as a versions or something like that. So these are all the different types of versions you are having. So whichever the tag you want, you can download it. For particular specific tag you want to download means you can download it, and here you will be able to see everything. And now this is the command which we need to do it. So let's try to copy this command, docker pull and the image name. So for everything, for every image if you want to download means, so you need to use this docker pull and the image name. So let's go to our command prompt, and here I will be using docker pull Nginx. Okay, so this is the command I need to use it. So now it will download it from the Docker Hub, and it will download into your local system. So I will try to show you where it will be copied. So now if I try to pull it, so it will take, by default it is taking the latest one. So if it doesn't mention anything means colon latest will be taken. If you want a particular version means, so you need to provide docker pull Nginx colon and the version name you need to provide, or the tag name you need to provide. By default if you don't mention anything, so the latest will be downloaded. So these are the different layers that is getting downloaded. So let it download. It will take some time depending on your internet connection speed. It will be downloaded. So let's wait for some time. So automatically what I want to tell you is the pull is completed, and now here you will be able to see downloaded newer image. So the new image has been downloaded, and now if you try to check where it is located is, so if you want to check it means, so docker image ls. So if you want to check the images means, so you can check it like this, and here you will be able to see Nginx is the latest one, so tag is the latest one, image id, and the size is 188 MB. So this is how you will be checking the downloaded image, whether it is downloaded or not. So now docker image ls, and docker pull Nginx will download the image. So now we have downloaded this one. So we have verified that in the local system that the image is downloaded or not. So that is completed. Now we need to create a container. So for creating a container, we have two commands generally: docker container run and also docker container create. So we will try to use these both commands. First I will use the docker container run to create a container. So in order to create a container from the image, so what we need to do it is docker container run, we need to use it. And here I need to use an option -d. -d means it is a detached mode. So D stands for detached mode, and there are so many other options also available. We will try to see one by one also. So first you try to understand this one. So docker container run -d is a detached mode, and that means the container will be created and it will be thrown to the background. So it will be running in the container will be running in the background. A process will be so for the container creation, so a process will be created after the container creation and it will be thrown to the background. In the background the container will be running. So that is the reason we will be using -d. So now -d and the option is space nginx. So this is the image name. Now when I try to press enter, automatically the container will be created and this is the ID of the container. In order to check the container list means, then what is the command you need to use is the docker ps. Again for this one there are two commands are there. So prior to that docker 20 version, so we used to have single command that is nothing but docker ps. So after the docker 20 version, so all the commands related to the commands container is divided into docker container ps, docker container list, like this, docker container start, docker container restart, like this. Those commands are divided. And for the image means docker image ls, like that it is there. And for the network means docker network. So like this it has been divided. So now docker ps is the old command. So the latest command is docker container ps. So this is the command. So this command also it will give you. And here you will be able to see the container ID, which we have seen it at the time of creation. So this is a short form it has given. And the image from which the container is created is the nginx. And this is the script file that has been created. So why? Because in order to run the nginx in the background, so this container will make use of this script file. And it has been created 49 seconds ago. And the status is running 47 since 47 seconds ago it is running. And by default nginx uses the 80 port. So Apache or nginx, whichever it may be. So it will uses the 80 port, and this is the default random name it has been created. So if you doesn't mention any random name, any name for the container means a random name will be created for the container. So I will try to show you how we can create our custom name also. So for the first time, so we will see how we can create a container. Now this is the random name which automatically the docker will create for a container if you doesn't mention anything. So fine. So the docker has been running. So now the container or the application is been running. So we need to check that whether the nginx server is on or not. So in order to check for this one, so what we can do it is, as this one is an Ubuntu server, we don't have any browser. So we can make use of this curl option and you can run 17.0.2. And if you try to see here, you will be able to see a HTML page has been open, and you will be able to see thank you for using nginx, and this is the default page for the nginx. You'll be able to see in the /www/html file, you'll be able to see this default index.html file. So now we are able to see that the nginx server is on and it is running in this 172.17.02. So now you will be able to now see the same IP. If I want to try it in the outside, something like in the browser, we cannot work it cannot work. Why? Because that IP address is assigned by it only works on the virtual machine only. So we haven't created anything to work port forwarded anything to work outside. So that is the reason. So it will not work. So now let's go into here. And how can I, now you may be getting doubt that, so I have used this curl option, right? How can I able to know that this is the exact IP address? So for this one, what we can check it is so the status of this one. So what I can say, check it is docker container inspect and the container name. So container name you can press tab automatically, so you can able to get the name. So now if I try to press enter, so you will be able to see the complete details of this particular container. And here at the bottom or somewhere you will be able to see about the network settings. So we will learn about this all the network in our separate session. So network settings you will be able to see. And here if you try to see the networks, it is created by the bridge. And here you will be able to see the IP address, right? So the gateway is 172.17.0. From there onwards, the Docker will provide the IP address for this one, and the IP address for the container for our nginx container is assigned is 172.17.02. So this is the, from here we can able to note. So as I already know, when I am creating this Nginx, the virtual machine will assign this one. So that is the reason I have directly typed this curl 172.17.02. So if you are newer to the Docker and you doesn't know what is the IP address that has been assigned to the container means, so you can use this command docker container inspect and the container name, and it will give you the IP address that has been assigned to that particular container. So that's it. So now if you want to check the container status means, so I already told you docker container ps. So you can able to see that container, and it is starting since 4 minutes ago. So it is up since 4 minutes ago. Now if you want to stop the container, what you can do it? So just you can do docker container stop and the container name you need to give. So you can press the tab and you will be able to get the container name, or otherwise you can use the container ID or the container name also. Both the things you can use it, anything you can use it. So now if I press enter, so automatically if I press enter, what is happening? If I press enter, so the container has been stopped. In order to check that whether the container is stopped or not, what is the command? So for checking all the containers ps. Now you will be able to see that the container is stopped. So we are not able to see the container. So now you may be getting doubt that what are the containers that are available that is stopped means how can I check it? So you need to use an option -a. -a stands for all. So now it will give you all the container list that is stopped, everything. Now if you try to see in our previous videos, I have shown you about the docker info also. So it will give you about the docker info. And here if you try to see, total containers are available is 1, and right now the container stopped is 1 and the images available is 1. So that is nothing but the image which we have downloaded, the Nginx. And you will be able to see the container is stopped and total containers available is 1. So now how can I check the stopped containers? How can I check the list of the stopped containers? So for this one, what you need to do is docker container ps -a list for a list for all. In ls also, in Linux command ls -a means it will give you the hidden files also, like that. Now if you try to see here, you will be able to see the container, and 6 minutes ago it has been created, but it is exited with 0. So you will be able to see with a 0 bracket 0 means, so that means it has been successfully exited. So it has been successfully exited. If it is value is greater than 1 or something like that means, then you need to understand that due to failure of some container or something, it has been stopped. If it is 0 means successfully it has been exited. So that is one thing you need to understand. If it is having exited with bracket greater than 1 greater than 0 means, then it has been stopped due to some failure in the container. So that is one thing you need to understand. So that's it. So now we have successfully stopped the container, and we have checked the container status that is stopped also. Now if I want to start the container means, then what I need to do? So in order to start the container, docker container start and the container name you need to give. That's it. So now automatically the container will be started. If you check in the docker info, now the containers will be 1 and the running will be 1 here. So from the stop to running it has been moved. Now if you want to check the status means docker container ps, and if you want to use like a -a so that you can see all the docker images including the stopped one and everything, you can able to see it. Right now it is running, so it was 21 seconds ago it has been started. So this is how we can start the container. Now if you want to restart the container, then what you can do it is, so we can use a command docker container restart container name. So you can use the tab, automatically the docker will be restarted. So now if you try to press enter, so now the docker the container has been restarted. For that one, how you can check the status is here. See, the status is 6 seconds ago. Previously it was 21 seconds ago when I restarted the docker. So again it has been restarted. So by this you can able to understand that the container has been restarted. So this is how we will be creating the container, starting the container, pulling the image, stopping the container. So this is the basic commands for the creation of the container. Now we have seen how we can check the list of the containers, how we can stop the container, how we can create the container, how we can start the container, how we can restart the container, how to pull the image. So these are all the commands we have checked it. Hope you understood about this container creation. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In the previous video, we have seen how to create the container using the command docker container run. And also we have seen one of the parameter that is nothing but -d, which is a detach mode. And also we have seen how to start the container, how to stop the container, how to restart the container. So these are all different concepts we have seen it. Now in this video what we will try to do is we will see some more other parameters for the Docker container. Now if you try to see the Docker container run -help, if you try to type the command docker container -help, you will be able to see these are all the different types of options that are available. And here -a is an attached mode, so -c means CPU, -d we have seen detached mode, and -i interactive mode. So like this label mode, -m, -p. So these are all the different options we are able to see. So now let's try to create the container with some more options. Okay. So now before that, so how to remove a container? So if you try to see the container docker container ps, so if you try to see here, so we doesn't have any containers, but we know that one container has been stopped. In our previous video we have created a nginx container. So in order to see that container whether existing or not, so you can do it like this. And now we are able to see the nginx container. Now if you want to remove this container, first of all you need to know we need to stop the container, then only we need to delete the container. For example, let's say that I will restart that container, docker container start and the name. So now the docker the container has been started. So now if for checking that one, docker container ps, now you'll be able to see that it has been up in 7 seconds ago. Now if I want to remove this container, docker container rm and the container name, if you try to take this, or otherwise if you try to take this container id and if you try to do it and press enter, and here it will tell that error response from the daemon, that is nothing but the docker daemon cannot remove the container tender napier. This is the container name. Why? Because why it cannot remove the container? Because the container is running. So in order to remove the container, first stop the container before, or force remove it. Force remove means that is nothing but the same command we can give it using the -f option, but this is not the recommended one. So the recommended option is that is nothing but we need to stop the container, then only we need to delete it. For stopping the container, what is the command? So docker container stop, and you can give the container name. Now the docker container has been stopped, so you will be able to see that it has been exited with a status code of 0. So now it is safe for us to remove the container. So that is the command is nothing but, so this is the command. Now if I try to click, so now the docker container has been removed. Now if you try to check the options, so now nothing, no container is remaining. So that's it. So now what is the best approach? Whenever you want to remove the container, first you need to stop the container and then only you can remove the container. This is the best approach. So now that one is completed. Now what we need to do, so now we will create a container, new container with some more options. So let's try to create a container. I am creating a container docker container run, and I will run with a detached mode, and I want a terminal. Okay, so the terminal may be a shell terminal, whether it may be a bash or sh, whatever it may be, and it should be an interactive mode. And the name I need to give the name. So up to now, whenever we are trying to create a container, so the name has been given by the docker randomly, so something like tender, like that it has given it, right? But now I need to give a name for this one. So now I can give nginx-demo. Okay, and I am giving the host name also. Host name means is nothing but the container, for the container name. So this is called as a container name. So this is nothing but a metadata. So for the container reference you are giving it, but this is the actual server host name. So for example, let's say that this is our Ubuntu server, right? So this is, for this one the host name is docker server, we have given it, right? In the same scenario, when we are trying to create a container and we are giving a host name for this one, so that is the thing. And name is a metadata, something like that, and this host name is an actual name of the container inside that one. So here I am giving nginx server, and I will give the image name last. That's it. So we have some more options also. You'll try to give it, but I am trying to show you one by one. Now when I press enter for this one automatically, and it will start the container. So -t means it's a terminal mode, and whenever we log in we can so by using this -t we can log in into the container and we can use the terminal. So interactive mode means it will allow us to execute the commands inside the container. So that is the reason. So now we are logged in. So now we need to verify that whether the host name has been created or not. So for example, let's say docker container ps. If you try to see, so this is the container ID and this is the image from which image the container has been created, and it has been created 29 seconds ago, and the container is up since 27 seconds ago, and the default port it is taking is the 80. Why? Because right now we have deleted the previous container, so that is the reason it is taking the 80. And the name for this one we have given it whatever the name we have given at the time of creation, the same name has been assigned to here, nginx-demo. So there is no randomly assigned name. So now whatever the name we have assigned, that name is applied to this container. Fine. Now we are able to see that the container name is been nginx-demo. So where is the host name? So how can I verify that host name has been applied or not? So in that scenario what you need to do is so you can also check the curl 172.17.0.2. So you will be able to see this one. So fine. Now let's verify the host name. So in order to verify the host name, docker container inspect and the container name, so nginx-demo. So now here, so the same IP address has been assigned. Why? Because the previous container we have deleted that container, so that is the reason. So that IP address is free now. So that is the reason when the IP address is free, so whenever the container we are creating again, if this IP address is free means that IP address will be applied to here. If that container is not get deleted means then another IP address will be assigned to this one. As this one is a private IP address, we cannot access it from the outside, we can access it only in the virtual box. So that is one thing. And if you try to go to the top or somewhere, you will be able to see a host name. So the host name applied is the Nginx server which we have given at the time of the container creation. There is also another method which we can verify the container host name. That is nothing but we need to log in into the container. So in order to log in into the container, so we already have given a -t-i option, right? So so there will be a terminal available for the container, so we can log in into that container. So now in order to log in into that container, so in order to execute the container we have so for this one also we have two commands. One is docker container exec and also docker container attach. So I will use the first one, so something like docker container exec, and I am giving -t-i. So I want to go into the terminal and I am giving nginx-demo, and the terminal I want to use is the bash. So when I click here, so here you will be able to see root@nginx server. So that means we are successfully logged into the container. And inside the container, if you want to check the IP address and all those things means you can do IP-a. But here you are able to see that IP is command not found. So that means IP root 2 has not been installed. So why? Because I already told you, right, this is just a container, it doesn't have any Linux kernel or anything. So the Docker engine contains everything. The container just contains only what are the resources or what are the binaries or libraries needed to run the application only. So it doesn't have anything, something like IP, these all the things it is not present. But you need to understand that inside the container you can contact the external world. So that means internet will be available in the container so that you can contact the external world. So if I want to ping google.com, so if I try to check the google.com, so ping command, so why? Because ping is also not available, so the libraries and the packages will not be available inside the container. I can show you that we can connect to the internet by using the apt-get update. So this is the update command which we will run to update the packages, right? So here if you try to see, so here the packages all are getting downloaded from the Debian, it is not getting downloaded from the Ubuntu. Why? Because this container is created on the basis of the Debian. So the Debian is the basic thing. On the top of the Debian, Ubuntu server has been developed. So here the container is developed on the Debian. So that is the reason it is searching the packages from the Debian. So now here it has fetched successfully from the internet. So that means it is successfully able to connect to the external world. So now if I want to use this IPA, ping and all those things means you can install the libraries or the packages whichever you want. So here I can use apt install hyphen y means I am giving yes to all the things, ip utils hyphen ping and ip root 2. So if I try to press enter, automatically it will download from the internet. So ip ping and everything is getting downloaded. So like this you can install whatever the things you want inside the container. Now you can use the command ipa, and also you can also use the command what is that one, ping. So for example, let's say that I will use ping google.com. okay, now see, you will be able to see that ping command is working. And also if I want to check control x control c, yeah, and if I want to check the IP address for this one is IPA. Now here you will be able to see the IP address for this one, 172.17.0.2. You can also check in the cat/etc/host, so where the IP address will be assigned. So here you will be able to see 172.17.0.2 Nginx server has been assigned to it. So like this we can check it. So it can connect to the outside world, you need to remember that, but outside people you cannot communicate. From outside you cannot communicate it because it is a private address. So 172.17.0.2 is a private address, so that is the reason. So from outside you cannot communicate it. So now if you want to come out of the container, what you need to do is you need to type the exit command. So that's it, or otherwise control D you can press it, so automatically you will come out of this container. So now exit, so there are stopped jobs. So now what is this happening? So let's try to do the control D. Yeah, exit, it has been exit. So now you can do the exit or control D, whichever it mob you can use it. So now upon exiting of the container, so the status of this container will be still running. So don't think that the container will be stopped. So still the container will be running, just we have logged into the container and we have installed some applications, some packages. So but the container will be still in the running state only. So if you want to check the status of this one, docker container ps, now you can check the status of this one. Still it is up in 7 minutes ago. So that is one thing. So if you don't want to log in into the bash into the terminal and you want to run commands without logging into the container means, then also you can do it. Something like, for example, I want to check the IP address for this one means, so docker container exec -t -i, and you need to give the container name and you can run the command, whatever the command you want. So now then also without logging into the container, so it will give you the output. So like this also you can do it. So now if I want to delete the container, what I need to do? So as usual, you need to stop and remove it. Without stopping we can remove it, but it is not recommended, but we need to give an -f option. So now we will check the status for this one, docker container ps. So that is the thing. So now I will try to stop it, docker container stop nginx -demo. So it has been stopped. So now I can remove docker container rm nginx -demo. That's it. So now if I try to check docker container ps -a, so nothing, no containers are remaining. So this is how we can use the other options in the for the container creation. Hope you understood about this concept and the commands which I have used it. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In the previous video, we have seen how we can successfully create the Nginx container using in the Docker engine. We have seen it. Now let's take another example for creating the MySQL in the Docker. So how we can create a MySQL database in the Docker. So in order to create this MySQL, first what we need to do is we need to search for the image in the Docker Hub. So that is the Docker Hub registry, right? So we need to search for this one. So for that, what we need to do, we need to search for Docker Hub. And this is the website, you already know, we have already seen for downloading the Nginx image also. So in the same repo in the Docker Hub registry, I will be searching for the MySQL. So now here I have typed MySQL. And now in this one you will be able to see the MySQL is the first one, and this batch is nothing but the Docker official image. And here you will be able to see a MariaDB, and another batch is also there, is also a Docker official image, and you will be able to see a Percona, and here PHP myadmin and circle ci slash mysql, so bitnamil slash mysql. So like this you will be able to see so many options is there. So right now in this video we are trying to install or create a container of mysql, and this is the official Docker image. So let's try to install this one only. So here if I try to open this MySQL, and you will be able to see MySQL, and this is a relational database management system, that is nothing but RDBMS. So it contains a relational databases, like you will be having a relation like foreign key relations, these all things. So the competitor for the alternatives for the relational database are something like Oracle, SQL Server, PostgreSQL. So these are all the alternatives for the MySQL. So these all comes under the relational database management system. So what is the reason for the MySQL is MySQL is an open source, and also Postgre, these all the things also MySQL is an open source only, whereas Oracle, SQL Server, these are not open source. So this is an open source RDBMS, or the MySQL is an open source relation database, and we will try to create a container using this MySQL image. So here you will be able to see the tags also. So if you come down, if you go to the tag section, and here you will be able to see the different types of tags. So 8 version, 8.08 Debian. So like this you will be able to see the different versions is there. And also we know that this tag is nothing but a version. So whichever you want to install, you can install it. So like this docker pull MySQL colon, and you can give the particular version or the tag. And right now I want to download the image of latest, so I can download it directly this one. So for this one what we need to do, so the first command what we need to do is, so first of all let's check that whether the image is available in our system or not. If you try to see, there is only one image available, that is nothing but Nginx. So this one we have already downloaded in our previous video. So now we need to pull the image MySQL. So let's say that whether we have any containers existing running or not. So I think most probably we have deleted all the containers, I think. So right now we don't have any containers also running in our system or running in our Docker engine. So first let's try to download the image. So docker pull MySQL. So whenever you type this command, automatically it will try to contact the Docker Hub, and by default if it doesn't mention any version or the tag, colon tag means by default it will take the latest. So now it has started downloading the layers one by one. So everything, the container, it will be the image, it will be downloaded, and using this image we will try to create the container. So it will take some time depending on your internet connection. So it will take some time. So for some people it may be finished very quickly, and for some people it may take some time. So for me it is taking some time, so let it take. And what we will be trying to do, so after pulling this image, so most probably this one is completing, I think. So after pulling this image, what we need to do, so we need to create the container. So now let's try to create the container. Without pulling the image also we can create the container directly. You can write docker container run, and using that command you can create it. First it will try to check the image whether it is locally available or not. If it is not locally available means, then it will try to pull the image and it will place it in our system, and then from that image it will create the container. So that in that option also you can do it, or otherwise so you can pull the command, you can pull this also like this, and also you can do it. Now let's try to open this website. So this is the MySQL, right? And here let's go to our overview, and the supported tags you will be able to see 8.488, like this we are able to see it. So now what is this MySQL? MySQL is the world's most popular open source database with its proven performance, reliability and ease of use, it seems. So how to use this image? So how to use this image means, so we need to run the command docker run, okay, -d, it is using the detach mode, and it is giving the name of the container, and we need to give -e MySQL _root _ password. So this is the, and here these are all environment variables. So if you try to see, these are all MySQL _root _ password is an environment variables. One second. So here is, these are my environment variables. So we need to provide these all the environment variables, and here MySQL and the tag you will be able to see. So let's try to see this one. So coming down, so these are all the things we will learn one by one. So right now these are not needed. So So here you will be able to see environment variables. So when you start the MySQL image, you can adjust the configuration of the MySQL instance. So it is trying to tell that we need to give some environment variables. So see also the website here, so it is giving some link, and here you will be able to see all the lot of what are all the environment variables that are supported for this MySQL. So right now, so what are mandatory, we need to give it. So if I go here into this MySQL, let's go down, and where is this environment variables. Oh sorry, I have already moved to down, I think. Yeah, so here you will be able to see environment variables. So MySQL underscore root underscore password. So for every MySQL, so you will be having a root user, and we need to provide the password for this one. So this variable is mandatory. So that means I need to provide this root password, and this for root super user, so the password will be set for this one. So now another one is MySQL database. So if you want to create a database by default at the time of creation only, so you can give this MySQL database. And here if you want to give any other user and the password means, so you can give these two environment variables. And here MySQL hello empty underscore password means, so it will give an empty password, and random root password is nothing but the random password it will be generated. So one time password. So like this it will be created. So these are the different types of environment variables you are having. So right now for this is the only mandatory one. Why? Because so without creating the password for the root user, so we cannot log in into the MySQL. So that is the reason we need to create a password. So now I hope that the Docker image has been successfully downloaded. So in order to check the image whether it is downloaded or not, so we will use the command docker image ls, and now the MySQL image has been downloaded, and it has took 578 MB of size. So fine. So let's try to run the command. So we know the command, that is nothing but docker. So let's try to go top. Yeah, docker run, these all the things we are having, right? So let's try to create it. So here I am creating a container, docker container run -detach mode -t and -i, terminal mode and interactive mode. And now I need to give the name of the container. So I will give MySQL -container. Okay, MySQL container I will give it, and I need to give the host name. So that is nothing but inside that container I need to give the host name for that one. So that is nothing but MySQL DB server. So whatever the name you want, you can give it. And I need to set the environment variables. So the first environment variable is MySQL underscore root underscore password. Okay, so this is the password I need to give it. Okay, so where it is located? So let's try to minimize this one. Yeah, MySQL underscore root underscore password. So what I need to give is equal to I will give test 1 2 3 4. So this is only for the test scenario. So we can set it afterwards inside the container also, but for this is a basic approach which I am trying to show you how to create a container. Because of that reason I am showing it like this. And we have created MySQL underscore root underscore password test 1 2 3, and I will set another environment variable, that is nothing but MySQL underscore root underscore host. So this is nothing but I will give it as an percentage. So that means anyone can connect to this. Outside anyone can connect, or otherwise any IP address can connect to this MySQL server, this one. Or otherwise normally this one is an unsecure one. So for security reasons, so you need to specify only the particular IP address from which you want to connect to this MySQL server. So but right now, so this is a testing purpose, I am giving percentage. So that means anyone can connect to this MySQL. So these are the two environment variables I am giving, and I will give the image name. That's it. Okay, so now if I try to press enter, automatically the container will be created within a fraction of a second. The container has been created. So that's it. So now if you want to check the status of this one, docker container ps, if you try to see, the container has been created. By default the MySQL server will listen to the port 3306. So this is the common thing. If you doesn't mention any port means automatically by default 3306 is the default port for which MySQL will be listening. So if you want to modify means you can modify that port also. And this is the name of the container, MySQL container. So now, so we have successfully connected to this one. And what is the IP address or the hostname that has been, what is the IP address that has been assigned to this one? So most probably 172.17.02 only. Why? Because it doesn't have any containers, right? So all the containers are free, so that is the reason. So it may be having like that. So if you want to check it, means docker container inspect MySQL container, right? So if I try to press enter, and the IP address the assigned is the 172.17.0.2. so now you will be able to see. Now what I want to do it is, so now I want to connect to the MySQL server and see the and I need to check the databases. So how we can connect? So somehow, so we need to write MySQL here. So in order to connect, if I try to press enter, it is telling that MySQL not found but can be installed with like this. So that means in order to connect to the MySQL server, somehow you need to have a MySQL client. So there you mean the MySQL client, you will try to type the commands or the queries and it will be connected to the server. In the same scenario, Docker server will be there and the Docker client CLI will be there, right? In the same scenario, SQL server is there and now I need to connect to the SQL server using the SQL client. So right now the Docker engine is in the same system, the container is running in the same local machine, and I will try to install the MySQL client also in the same machine only, so that we can connect it automatically. Now for this one what I need to do, so this is the command it is telling to install the MySQL client. Okay, so let's copy it and I will install this one. So now it is asking for the password. Okay, let's try to give the password, and automatically it is installing the MySQL client. And after installing the MySQL client, now I can able to successfully connect to the MySQL server, that is nothing but our container. So already our container or the MySQL server is running in the container, so we need to connect to it. So right now both the client and the server is in the local system only, or rather in the same machine only, so we can connect it without any problem. Now if I want to connect, means MySQL -h, the host name is nothing but 172.17.0.2 and user is root and password is -p. Now if I press enter, so it will ask you for the SQL password. So we are already given test1234. Now see, we have automatically connected to this one. So now you will be able to see MySQL prompt is coming. Now if you want to check the databases, show databases, and it will give you all the list of databases that are available. And if I want to create a database, means create database Leela webdev. So now query okay, one row affected, so that means database has been created. So now here if I try to check show databases, so now you will be able to see Leela webdev is there. And if you want to go into the database, means use Leela webdev, so you will select the database and database has been changed, and now you can check the tables and everything. So you don't have any table, and now you can create a table name, and like that you can create it. So right now I am not going deeper into this one. So this is how we will be connecting into the MySQL database. Now if I want to exit from here, means so just type exit, that's it. So now we are successfully came out from the MySQL server. So this is how we will be creating the MySQL container using the Docker engine. So now you hope you understood about this MySQL thing. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela webdev. In this video, we will learn about the container creation workflow in the Docker engine. So let's try to see this one. So I am opening the slideshow. Yeah. In the previous videos in our Docker tutorial, we have seen that how to create the containers like Nginx and the MySQL application. So these are all the different ways how we can create the Nginx and what are the different options also we have seen for creating the container. Also we have seen what are the commands we have to execute and what are the options we have to pass. So what are the different types of commands also, the Docker commands we have seen, and how we can execute it also we have seen, and what are the different types of options for creating the container and what are the different options we have to pass. Those all things also we have completed. Now let us understand when you try to create a container, what will happen behind the scenes or beyond the scenes of the Docker. So now you are creating a container. Now you are able to see that the container is able to create with the help of Docker engine. But what will be happening behind the scenes when the container is trying to create? So while container is creating, what are the things that will happen, or what are the steps which will happen. Let's try to see. We have seen just a high level view that CLI will talk to the daemon. Daemon means here nothing but a Docker server, and the daemon will look for the image. If the image is not available, it will download and then it will start creating the container. So this is the high level view. So that means in the high level view we have seen that the CLI, in the CLI we will talk to the daemon, and the daemon will look for the image. If the image is not available, it will download and then it will start creating the container. That's it. Now let us understand in deep about this container creation process. So Docker CLI is used for executing a command. Like Docker container create, or so what we will be using the commands here in the Docker CLI. So like Docker container create or the Docker container run command. So these are the two commands which we will be using, or any command which you are trying to execute in the Docker CLI, and that Docker CLI is used to execute the commands. Now when you execute this command, these commands will pass the information to the Docker daemon. So the commands will pass the information to the Docker daemon. Now the Docker daemon will receive this information from the CLI with the help of REST API call. So this one also we have seen. So the Docker daemon will receive this information with the help of REST API call. We have seen the Unix socket, right? So I have shown you that it will be available in the var/run/docker.sock. So that Unix socket. So it will be using this REST API call in order to transfer the information from your client to the daemon. So in order to transfer the information from your client to daemon, so the Unix socket will be taking help of the REST API in order to transfer the information from client to the daemon. Here daemon is nothing but a Docker server. So here you will be confusing the daemon. What is the daemon? So daemon is nothing but a Docker server. Now the daemon calls the container D. So here you need to understand that now after receiving the information, the daemon will call the container D. What is this container D? If you remember at the time of Docker installation, I have told you in our earlier videos. So when we are trying to install the Docker engine, we have installed the container D along with the docker-ca, docker-compose, docker-buildx, something like that. So when you are trying to install it, so we have also installed the container D also. This means that the tool which creating the container in the background is not Docker, it is container D. So the container is created by not the Docker, it is container D. That means Docker daemon is calling the container D to create the containers. Docker daemon uses the gRPC calls, which is like CRUD style API. So Docker daemon uses the gRPC calls, which is like a CRUD style of API, to transfer the information to the container D. Now container D will receive the information with the help of gRPC call from a Docker daemon. So how the Docker daemon and the container will communicate, container D using the gRPC calls. How the CLI and the Docker daemon will communicate with the help of REST API calls, Unix socket. Now when you execute a command, Docker container run the image name, that container D will see whether you have that particular image in the local system is present or not. If it is not available, it will download the image from the repository. That is nothing but by default, it will check in the public repository, that is Docker Hub. So here when you execute a command, the Docker container run command with the image name. So you will be giving the image name, right? Docker container run and nginx the image name. So the container will check whether you have that particular image or not. If it is not present means then it will try to download it from the public repository, that is Docker Hub by default, and then it will place it in your local system. Container D will create a OCI bundle. So using that image, it will create a bundle, that is OCI bundle from the image. The image details will be given to your container as an OCI bundle. So here the images and all those things will be created as an OCI bundle. After this, so when the container D creates the OCI bundle, after this runc will create a container using that OCI bundle. So now we will be able to see a runc. So runc will create a container using that OCI bundle. Container D will create the OCI bundle and runc will take that OCI bundle to create a container. So this is the overview. After that, runc interacts with the OS kernel to construct the needs needed to create a container. So here runc interacts with the OS kernel. So we already discussed, if you remember, we have something like a lib container. I have told you about the bundling thing. So it will contain a kernel namespaces, C groups, file system, and all those things. It will be bundled, and you'll be having the Docker by default. It will be using the lib container. In our previous videos, I have explained you. So lib container will contain the bundles like kernel namespaces and C groups, etc. So now your runc will call that particular lib container to do that particular actions. That means by using namespaces and C groups, your container will be created in the backend. After that container process will start, after the container creation, the process will start as a child process under your Docker main process. So now the child process will be created for the container creation, and it will be under your Docker main process. After the container process has been created, so when the Docker process has been created, runc will assume that the container has been created successfully, and then it will exit from the task. So when the container process, the process has been created means then the runc will assume that it has been created successfully, then it will exit from the task. Finally, you will see the container has been created in the container has been created, and it is running in the background. If you try to see the visual representation of the process, then you will be able to see here. I will explain you here. First, the Docker CLI, you will write the command docker container run or docker container create, whatever the command. For creating the container, you will type the command here docker CLI, and the Docker CLI will communicate to the Docker daemon with the help of the REST API. So this will be the help of this Unix socket, and it will use the REST API calls, and the command will be here sent to the Docker daemon. Information will be sent, and the Docker daemon will receive the information that we need to create a container with a image name, so with the particular image, and it will transfer to the containerd using the gRPC calls to tell to the containerd that we need to create an container. So now the containerd will take that image, and it will create a OCA bundle, and it will send it to the runc. Okay, the containerd will create an OCA bundle, and it will send it to the runc. And runc will take help of this lib container, which contains the namespaces and the C groups. So these are all the namespace, and all will take the help of this lib container and all those things, and it will create the container, and a process will be created for this one. So now when the process ID has been created for this one, automatically the runc exits that the container has been created. So now you will be able to see the container status, and in the console output you will be able to see that the container successfully created, or if an error occurs, see the error, whatever the thing it will be happen, the status of the container you will be able to see in the console output. So this is the whole process how the container will be created behind the scenes. So that's it guys. Hope you understood about this high level overview how the container will be created in the Docker engine. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see how we can configure the static IP address to our virtual machine. So right now, if you try to understand the Docker machine, right now it is using the NAT interface. So what is the meaning of this NAT interface? As I already told you, right? The problem with the NAT is outgoing connections are allowed, but incoming connections are blocked. So that means if I want to connect from outside to the virtual machine means it will be blocked. So we need to use some port forwarding or something like that, and we need to connect to the machine. So we connect to the machine. So what is this one? In this NAT adapter, so NAT allows the virtual machine to share the host system IP address and the network connection. So here the virtual machine will share the IP address and the network connection. The host system acts as a router. So that is nothing but the virtual machine will act as a router, translating the traffic between the virtual machine and the host system will in between this one the host system will be there, and it will translate the traffic between the virtual machine and the external networks. So the virtual machines connected via NAT generally have limited direct visibility on the external network. They typically appear as if they are the host system when communicating externally. NAT is oftenly used when you want to conserve IP addresses or when you don't need direct external access for each virtual machine. So when we use this NAT adapter, so when you don't want our virtual machine to be contacted from the external means, then we'll use this NAT adapter. So right now through this command prompt, so I am using this command prompt, right? So from this command prompt, I cannot directly contact the virtual machine, and I cannot directly use it from the remote. Why? So as I already told you, right? So it is connected through the NAT gateway, and if I want to connect it, so what I will be trying to use it. So here in our settings, in our network, if you try to see here in our in the advanced, so we are using the port forwarding 222 and to the guest port 22 here like this. So now whenever we want to contact to the virtual machine, so I need to connect it to this 2222 port. So in this way we are connecting. So that means here if I want to connect means first I need to power on the machine. So let's try to power on, double click it, it will power on. Let's try to start the, and if I want to connect here, so I need to use something like SSH hyphen port 2222, and I need to use test user. So let's connect it at the rate localhost, right? So like this we used to connect it. Let's connect. It will ask you the password, and then we can connect it. Yeah, so now if I try to press enter, it will ask you the password and test 1234. If I connect it, then I will be able to connect to the system. So this is how, so through the port 2222 I am connecting into the virtual machine. But here I don't want to use it. For example, tomorrow, so now we have installed the Nginx application and also the MySQL application. Now Nginx application is connected to the port 80, and what is that one? So MySQL is connected to the port 3306. Now if I want to connect through the external resource, from the external resource means, so I need to use the port forwarding here, something like so here I need to use the, let's go to the network, I can click directly here, and here I need to do the port forwarding. So I need to keep some another TCP rule, and I need to give another host port to the guest port, that is nothing but 3306 and 80 port. So I need to do all the port forwarding. So for every application, so container I want to do the port forward means it will be somewhat confusing for us, right? So that because of that reason, so we cannot use the NAT gateway. So now we can see that whether it is connected to the NAT gateway or means. So how can I check it is? So I can use IP address show. So here you will be able to see this is our ENP03, that is nothing but our Ethernet connection. Okay. So what is the meaning of ENP0S3 means? So it is the name of this Wi-Fi connection or the Ethernet connection which you are having. And here you will be able to see the inet address 10.0.2.15. So this is the virtual machine box in which it has been applied. So now you will be able to see the scope of this one, and it is forever. So it will be valid forever and preferred forever. So the host machine is this one, so the virtual machine. So and for this virtual machine is applying the IP addresses for this one. So now what I want to do it is, so now I want to, instead of having this host machine the NAT gateway, so what I want to do is, let's the router, okay, so let's the router apply give the IP address to this one. So what I am trying to tell you is, so here you need to understand it carefully. So because of this NAT, what I am trying to do is, everything if I want to connect it means I need to do the port forwarding. So how we have did it for the 22 port to communicate to the virtual machine, in the same scenario we need to do for every application. So that is not easy to manage. So this one we have discussed it. Now, so now what we need to do it is, so we need to change from NAT to the bridge adapter. So here I will be showing you. So because of that reason, so we will be changing here from NAT to the bridge adapter. What is the advantage of this one is, instead of getting the IP address from the virtual box, you will get the IP address directly from the router itself. Okay. So here for us router is nothing but the Wi-Fi router which we are having. So the Wi-Fi router will connect to this one. So it will think this virtual box is a physical network which is connected to the directly to the router, and the router will assign a IP address to this one. So that means how my base machine means this laptop or this system, how this system is getting the IP address from the router. In the same scenario, the virtual machine also will get the IP address directly from the router itself. So you will so the virtual box, though there will be no intermediate NAT gateway interface, there will be no internet host name, and that one will not assign any. Now what I want to say is IP address to this one. So how my base machine will get the IP address from the router, similarly your virtual machine also gets the IP address from the router. So now let's try to change it to bridged adapter, and here you need to make it as promiscuous mode allow all. That's it. So here I am using the Wi-Fi. So why? Because I am connected to the Wi-Fi network. Now I am clicking on OK. So now here automatic, if you try to see here, Docker engine is actually running, and automatically I changed the network. Actually this is not the better prefer approach to do it. It's always the best approach is stop the instance and change the network and then relog in. But it's not a problem, so you can connect it like this also. So now once you made the changes, so there is no need to shut down the instance. You can modify that in the running instance only, but the best approach is shut down the instance, change the network, and then rerun the instance. So this is nothing but what I want to tell you is how you are switching the internet from one router to so here we are switching the internet from one router to another router. So for example, let's say that your system is having, and you are having two networks, something like Airtel and Jio. So now if the Airtel internet is not working means, so what will you try to do? You will switch from Airtel to the Jio network. So in the same scenario, in the same scenario, we are switching the network in the virtual machine from NAT to the bridge adapter. That's it. So now how your base machine gets the IPA from the router? In the Windows, if you try to see, this is your Windows, right? So now automatically if you try to press enter, it will be connection will be closed. Why? Because a new IP address will be assigned to this one. So that's why the local host has been closed. So now let's try to see it. So now this is our Windows system. So this is our Windows system, right? How can I get this one? So if you try to check IP config, you will be able to get the IP address for this one. So if you try to see, the IP address for this one is wireless LAN adapter. This one, I think wireless LAN adapter only, right? Yeah. And the IP address is 192.168.1.7. Okay, so this is the IP address which we are able to get, and the subnet mask is 24. So now here the default gateway is 192.168.1.1. so this one you need to remember. So that's it. So now we are able to see that this IP address is attached to this one, right? So in the same scenario, virtual machine also will get an IP address, something like 192.168.1.2, 1.14, 1.15 or something like that. You will get it. Let's try to see that one. So that means the router, the Wi-Fi router is giving the IP address to the base machine and also to the virtual machine means. So now now the virtual machine and the physical system, the base machine, can communicate with each other. So this is the thing you need to understand. So how your base machine is getting the IP from the router, like in the Windows. So instead of virtual machine assigning the IP address to the application, now the router will assign the IP address to the virtual machine. So that's what I want to do it. So that means I can communicate to the internet, and also I can also communicate to the base machine without any issues. No port forwarding or nothing. So let's see how we can configure the bridge adapter. So let's go to the virtual box. So here this is our virtual box, right? And this one is this one is our, where is that? Yeah, this one is our virtual box. And let's log in test user, and I am using test 1234. So I have successfully logged into this one. Now let's try to see what is the IP address that has been assigned to this one. So now if you try to check test 12, so how we can check this one? So I got new IP address. We can able to see IPv4 address, something like that. So now how can I check that one? IP address show or IP A also you can use it. So anything you can use it. Now if you try to see in the second place, you will be able to see 192.168.1.13. So that is the IP address which we have got it. So now I will try to show you. So now we can connect with this one in the command prompt. So here you can connect it directly, SSH. So there is no need to use the port number. Why? Because there is no port forwarding, nothing. So test user @192.168.1.13. So this is the IP address. Now if you try to see here, it will ask you. So okay, plus S, and permanently added this one. So it is asking the password, means it is successfully connected to the virtual box. So now I am using test 1234. See, now I am able to automatically connect to this one. So now if I try to do a IP address show, then you will be able to see. So this one is, so here you will be able to see 192.168.13.1.13. So here you will be able to see 192.168.1.13. So this is the thing, it has been attached to this one. So now you need to understand that, for example, let's say that I will restart, I will sudo I will do the reboot for this one, test 1 2 3 4. So it will reboot it. Okay, let it reboot. So now you need to understand one thing is, so 192.168.1.13 has been assigned to this one. Fine, it's fine, perfect, it's nice. But you need to understand that when I restart the virtual machine, or tomorrow if I come, for example in your home, for example, when you try to communicate your device to the router, automatically you will get an IP address. So that's okay, fine. So you got the IP address. So now you need to understand that, let's try to log in with this one. So test user and test 1 2 3 4. So now we got it. Now if I try to use IP address show, let's try to see it. Now for example, let's say that, so you need to understand one thing is, so now one second, where is our thing? Yeah, so now when I switch on the virtual, when I switch on this box, and tomorrow if I want to communicate again, so I cannot able to, so there is no guarantee that the same IP address will be allocated to this one. Why? Because it is automatically, DHCP is enabled, dynamic host is enabled in your system. So that's why you are getting an automatic IP address. So the router is assigning the IP address for you because DHCP is enabled in this one. So that's why you are getting an automatic IP address. But in this one, for example, let's say that tomorrow, in your home, for example, when you try to communicate your device to the router, automatically you will get an IP address. This concept is called as a DHCP. So for example, let's say that your friend came to your home, and the phone, the mobile or something like that, it will be there, right? If he connects to the router, means an IP address will be assigned to that mobile automatically. Why? Because DHCP will be enabled in this one, and automatically the IP address will be assigned to this. So now the problem with the DHCP is, that is nothing but the IP address is not fixed. So whenever you come and connect again means, so we cannot guarantee that the same IP address will be allocated to you. So the IP address will be, if it is available means it will be allocated, or otherwise another IP address will be allocated. So that means if you switch off your Wi-Fi and switch on again, so for example if the power goes off, the Wi-Fi is switched off and switch on again means, so we cannot guarantee that we get the same IP address from your router. Same applies here also. If I shut down the virtual machine and tomorrow, and if I switch on the machine, I cannot guarantee that I will get the same IP address. So that is one thing. So for that reason, what we need to do is, we need to make an fixed IP address, means a static IP address. So we need to make the static IP address. Static IP address means that doesn't never change. So let us see how we can configure the static IP address in the virtual machine of Ubuntu. Now we have connected here, right? So earlier we used to do -p22, something like that. So here I can use SSH test user @ now 192.168.1.13. So now here it will ask for the password. Okay, so password we have entered it. So now we have successfully entered into this one. So now we need to configure the thing, right? So we need to make it as an fixed IP address. So let's try to check it. So in order to make this fixed IP address, so what we need to do it is, so there will be a process, it is involved in this one. So long process will be there. So this one we need to learn it. So converting to a static address is involves several steps. So first what we need to do is, first identify the current network configuration. So here I can check it something like this. Okay, and now what we need to do is, we need to edit the net plan configuration. So net plan Ubuntu 24.04 uses a net plan for network configuration. You need to edit the net plan configuration file to get it, to set the static IP address. So where it is located is, so let's try to check that one. ls/etc/netplan, that's it, -a will try to see it. So you will be able to see a 50-cloud-init.yaml, right? So we need to edit that file. So let's try to edit this file. So we need to edit this 50-cloud-init.yaml. Okay, let's try to edit it. So for that one, I am using the nano editor. You can use Vim editor or VI editor, anything you can use it. So I am using nano editor and sudo nano /etc/netplan/50- like this we need. So here you will be able to see. Now here you need to use DHCP false. Okay, so we need to use it DHCP as false, and we need to change some more configuration also. So So I will try to explain you. So we will be having some list of code which we need to add it, and we have added this one DHCP as false, right? So now another one which we need to do it is, so we need to add the, one second, yeah, so we need to use this DHCP, and here we need to use the IP address which we are using. So right now the static IP address which I want to use it is the 192 dot like that, right? So let's try to go it here. Yeah, addresses, I need to use the addresses, and here 192.168.1.13, and the subnet mask we need to use is the 24. So normally it will be 24 only, and the another one is routes. So this is the routes. Normally we use the gateway 4. So here the in Ubuntu it has been changed. So the route will be to default. There is no need to remember. I am not going too much depth into this one. So just we can change it via 192.168.1.1. This is the gateway. You will be able to see it. At the first time we have seen the gateway, default gateway. And if you want, you can use on link true. Okay, on link true you can use it, and we need to use the name servers for this one. So name servers, normally DNS name servers. So name servers, I will be using the Google name servers. If you want, you can use CDN, Open CDN. So these all the things are there, Cloudflare DNS, these all things also you can use it. So I am using the name servers, that is nothing but 8.8.8 for the DNS, and also the another one, if it is failure means, then I will be using 4.4. Two name servers I am using. Hopefully this is the code, we can change it. DHCP is false and Ethernet we are using it, right? Yeah, fine. So control S, control exit, and now if I want to check it means, so what I can do it is, so sudo netplan apply, that's it. So now if I try to press enter, so if you didn't get any errors means automatically it has been applied. Now if I try to show IP address show means, then you will be able to see this is the IP address. Now when I switch off or switch on, so whenever I do it, so this is the static IP address that will be applied to automatically to this one. So this is how we will be converting, this is how we will be doing the converting from dynamic IP address to the static IP address. So now you can connect directly to this one. So without any problem you can connect it. So that's it. So these changes, so now this is how we will be changing it. Now I can connect all the time. So this IP address will be connected to this one. I can connect all the time. So hope you understood about the static IP address configuration. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see how we can access the application from outside of your Docker machine. Let's try to see this one. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see how we can access the applications outside of your Docker host machine. So access the applications means, so for example, if you are having the Nginx container or anything means, and if you want to access that container application outside of your Docker host machine, like your base machine or outside world, if you want to access that means, how we can do it, let's try to see it. So let's click on the slideshow. Yeah. So in this video, we will see how to access our applications from outside of the Docker engine, which means how to access applications running inside the Docker engine. As I told you before, by default, all the applications which are running in Docker engine will not be accessible from the outside. Why? Because it is using a private address. Let us see that particular behavior. Let's say we have a Docker host machine, and on that particular Docker host machine, the Docker host machine means you will be getting confused that it is nothing but where you have installed the Docker engine. So right now we are having a virtual machine that is nothing but Ubuntu server, and in that Ubuntu server we have installed the Docker engine. Then it is called as a Docker host machine. So you can say it as an Ubuntu server or virtual machine or a Docker host machine, anything you can say it, or server also. That particular machine is called as an Docker host machine. On that particular Docker host machine, I have told you how to configure the static IP address using the bridge adapter on VirtualBox. So right now our IP address is 192.168.1.13. It is the IP address we have configured. In your case, it may be the different IP address depending on the router. So whenever you install the Docker engine in your machine, by default a Docker 0 interface will be created and that will be available. So that means whenever you install a Docker engine, a Docker 0 interface will be created and that will be available. Everybody can see the interface, the same IP address. So here how I am showing you the Docker 0 bridge interface, and the same IP address is 172.17.0.16 by 16. You can execute this, you can see that in your virtual machine by using IPA or IP address show command on your Docker host machine, and you will see a Docker 0 interface with this IP address. So let's try it. I will try to show you, and this is our IP address, right? So here if you try to type IP address to our IPA, and here this is our Wi-Fi or the LAN network ENP0S3. In your case, depending on the ISO on your operating system, so here you will be able to see ETH0 or ENP0S3. And here this is the Docker 0 interface which I am trying to tell you. The Docker 0 interface will be created and the IP address is 172.17.0.1./16. So for everyone the same IP address will be there, and this Docker 0 interface will be created when the Docker engine has been installed. So this is the concept which I am trying to explain you. Now let's go back to our slideshow. So whenever you install the Docker engine on your machine, by default a Docker 0 interface will be created, and I have shown you that about the Docker interface also, and everybody can see the same interface, same IP address. Fine. You can execute IP address show command which I have shown you on your Docker host machine, and you will see a Docker 0 interface with this IP address. So what does it mean? So this is the program they have written by the Docker engine package to create this particular interface. So that means when you install the Docker engine package, the program has already been written to create that particular interface. So that means now every container will get an IP address from this particular interface. So now the container which you are trying to create in this Docker engine will get the IP addresses from this Docker 0 interface. And this interface one end will be connected to the ENP0 S3. So that means that is nothing but your route, your ETH0. So that is nothing but your connection. Sometimes you will see ETH0 or sometimes you will be seeing ENP0S3. It is like switch. Assuming that at your home you have a switch or router, something like that. One end of the router will be connected to the LAN cable from your internet service provider. So what I am trying to tell you is, so this is the ENP0S3. So let's say example I am telling that, assume that in your home you have a router. Let's say that you have a router, and what it will be having, the router one end will be connected to the LAN cable like your Airtel connection or Jio connection, whichever it may be, the internet service provider. The LAN cable will be connecting to the router one end from your internet service provider. Assume that ENP03 is nothing but your internet service. Assume that ENP0S3 is nothing but the internet cable which you are trying to see it, and from that you have attached a cable to your Docker 0 interface. So from the router, from another end you have connected to a Docker 0 interface. Though it is not physically available, just I am trying to explain with a real-time example what we use in a daily basis. So for example, let's say that I will try to open the Paint and I will show you. So if you get confused. So let's say that this is our router, so which you will be having in your home, and you will be getting the connection from the outside, and you will be connecting from the other end to the laptop or anything. So assume that this is the ENP0S3. Okay. So here you got, this is the internet service provider. So you got the internet, and from end this ENP0S3 you have the internet, and another end it is connected to the Docker 0. Okay. Docker 0 interface. So ENP0S3, from one end it will be getting the internet, and another end it has been connected to the Docker 0 interface. So this is the concept which I am trying to explain you. Let's go back to this one. This means that Docker 0 interface, another end will be connected to ENP0S3, where you can communicate to the outside world. So that means, so what I am trying to tell is, so in this Paint, so this Docker 0 interface, one end is connected to the ENP0S3 So through the ENP0S3 where you can connect to the outside world. So that means outside laptop or internet or anything you can connect it. So where you can communicate outside world. And another end of your Docker 0 interface will be connected to the container. So that means another end will be connected. So this Docker 0 interface will be connected to the containers. Whatever the containers are there, it will be connected to the containers like this. I will show you the diagram also. I have drawn this diagram. So like this you will be having. So this is the internet service provider and ENP0S3 is connected to the. So I haven't drawn this line. So but this one end is connected to the ENP0S3 and this completely is a Docker host machine, that is nothing but our Ubuntu server, and ENP0S3 and the other end it is connected to the ISP, and this one is connected to the Docker 0 and Docker 0 will be connected to the containers. So like this. So we have this Nginx container and this now we have this Nginx container. If you try to see, we have the Nginx container and this container will be using some IP address from that particular Docker 0 series. So here I have shown you, right? So 172.17.0.1 is a private address which the Docker 0 interface will be having. So from another end through the Docker 0 interface the containers will be attached. So now what I am trying to do, so whenever you are trying to create a containers and this container will be using some IP address from that particular Docker 0 series. So the IP address will be assigned will be like 2, 3, 4 like that. So that means so 172.17.01 has been assigned, right? So whenever you create a container and 170.17.02, so another container means 3, 4 like that, the IP addresses will be created. With this particular network series, almost we can use IP address like 65,535 IP address minus 2. So now one of the IP address get assigned to my container called Nginx and this Nginx container is listening on a port number 80. Now this particular Nginx container will attach it to the Docker 0 interface to get the IP address. So that means I have created a container with Nginx and it is listening to the port 80. So I have created a container like that. And now for this Nginx particular container, it will attach to the Docker 0 series and it will attach to the Docker 0 bridge interface in order to get the IP address. Now if my Nginx container wants to talk to the internet, first my packet will go to the Docker bridge interface. Let's say I am typing ping google.com. So here let's say that in the Nginx if I want to talk to the outside world, let's say that here I have used ping google.com or something like that command I have used it. And this command first it will go to the Docker 0 bridge interface and then it will go to the ENP0S3 and then it will go to the outside world. Let's say I am typing ping google.com. When I execute this command first, it will send this particular request to the Docker 0 interface. Now this particular Docker 0 interface will say where is google.com. It is not there in the local system. And now what it will do, it will send that request to the ENP0S3 interface. From E to 0, it doesn't know where is google.com again. And now this particular packet will travel to the internet. So why? Because ENP0S3 is connected to another end is connected to the internet. Then it will get the response and it will send back the response to the Docker 0 interface and from there it will go to the Nginx container. So like this it will happen. Now what I mean to say is that Nginx IP address 172.17.02 is not reachable from outside. So if you go to the browser of my base machine, so here let's try to say that base machine means, so this is the base machine which we are having. On the top of the base machine I have installed the VirtualBox. And on the top of the VirtualBox we have created the Ubuntu server, that is nothing but our virtual machine. And in that virtual machine, so the round circle is nothing but the container, Nginx container I have created. So now the Nginx container, from the base machine, if I want to contact the container means I cannot contact it. So that means from the outside world I cannot communicate to this, what I want to say is to this container. So on the base machine I am using the VirtualBox. On this VirtualBox I have created a particular virtual machine which is nothing but Ubuntu server. Now in this particular virtual machine a container is created. So this is what I am trying to explain. Now the container IP address what you are seeing 172.17.02, here it will not be reachable from the outside, means from the base machine as well. That is the default behavior of your Nginx IP address, which is nothing but Docker 0 IP addresses. These IP addresses are nothing but private address. So these are all private address. So that is the reason. So it cannot be accessed from the outside. You can take the example of another container as well. Let's say Apache web server. So let's say that another example, like I have created another container. Let's say Apache web server. Apache web server also listens to the port 18 number, and you can see a new IP address here has been created. Now this container will get the IP address from the Docker 0 interface. How the Nginx got the IP address. Now here you'll be able to see. So now I have created an Apache new container, and actually it should be connected to this bridge interface. And now a new IP address has been assigned by the bridge interface 172.17.03. And again this one is also listening to the 80 port number only, and this one is listening to the 80 port number. And two IP address has been assigned by the Docker 0 bridge interface. Now by default everybody will get the IP address from the same Docker 0 interface, like 2, 3, 4, 5 like that. Now these containers by default will not be accessible from outside of your Docker host machine. Now how to access them? So what is the concept we have in the Docker engine? So that is the main funda, right? So in Docker engine we have a concept called port forwarding. Same concept we have seen in the NAT interface as well. So in the first, at the starting also we have implemented this NAT interface. When you have configured your port forwarding from your SSH port number 22, the same concept applies here also. Now when I am using a port forwarding for my Nginx container and Apache container, you can see the port forwarding in the diagram. So this is the diagram. So now what I am trying to do, so this 172.17.02, this has been created, the new IP address has been assigned. So now here 1890 ports, the port forwarding I have did. So whenever the user types 1890 or 1880 means, so then it will connect to this Nginx and Apache. Now 1890 is the port number. What I want is to bind on my Docker host machine to my container called 80 port number. Now you are trying to bind your 1890 port number to your 80 port number inside the container. This is called as a port forwarding. So if I go to my browser in my local laptop or local base machine, and if I type 192.168.1.13:8090, it should be able to access my Nginx application. So this is the port number. Now if I want to access the Apache web server as a container means, now I need to do another port forwarding for this container. And remember, we can't use the same port number when I have used it for one of the container. So for 1890 I have used it for the Nginx, right? So I cannot use the same 1890 port number for the Apache web server also. I need to use it another port number. So I have to use a different port number. In this example, I will be using the 8080 port number. Now this 8080 port number is getting binded to the 80 port number inside my Apache container. So this is one of the another port forwarding what I have done for the Apache server container. How many containers you want to access from outside of all the containers? You have to do this port forwarding. And remember, this has to be decided while creating the container only. Once the container has been created, you can't do this particular action. That means you have to plan first. So whenever you want the container to be port forwarded means for the time of creation only you need to decide. You need to decide, do you really want to access this particular container from outside or not? If you really want to access it means, then if you want to use a bridge network, then you have to go for port forwarding. That's it. So this is how we will be doing the port forwarding, or how we can access the application from outside. So now I hope you understood about the diagram. So let's try to show you again the diagram. So this is the diagram. This is the host machine we will be having. So that means this is the ENP0S3. So which is we are having 192.168.1.13. And this one will be connected to the another end will be connected to the Docker 0 bridge interface. And this Docker 0 bridge interface, you will be having all the containers attached to this one. And all the containers, the IP address will be assigned by the Docker 0 bridge interface. Now when I want to access this 172.17.02, I can only access in this bridge 0 interface local machine only. That is nothing but Ubuntu server only. Why? Because this is a private IP address. Now when I want to access this one outside of this base machine means, so in this Docker host machine only I can able to access. Outside the Docker host machine, if I want to access means, I cannot able to access this one. So what I will be trying to do, so I will be doing a port forwarding here. So that means 192.168.1.13.8090. If somebody access this one outside means, so automatically it will be redirected to this 80 port number, this one. So like this we will be doing the port forwarding. So hope you understood about this concept. So in the next video we will do the practical session for this one by creating both this Nginx container and Apache container, and I will do the port forwarding so that you can have a clear idea about this one. If you have any doubts or any suggestions, please post the comments below to this video, and if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In the previous video we have seen the implementation, how we can implement the port forwarding or how we can access the container application outside of the Docker host machine. So we have seen it. So in this video we will see the practical implementation of this one. In the previous example I have shown you how we can create the Nginx container and Apache side container, and how we can access that one using the port forwarding. I have explained you. In the same examples we'll create the Nginx container and we'll keep the Apache container, and we'll try to access both the things outside of our Docker host machine. So let's try to implement this one. So first of all, in order to implement, first I will try to switch on the server. So I think mine is power off. So let's try to switch on, and you know that this one is running with 192.168.1.13. so you know, right? So these all the things we have did it. And now let's try to, we have also fixed this all static IP address and all those things we have did it. Let's try to run it. So the server is getting run. So now we need to install first we need to create the container, that is nothing but Nginx container, and afterward we need to create the Apache container. So first we will create the Nginx container. For this one, first what we need to, so Docker is logged in, so let's try to log in with the SSH actually. So SSH test user @192.168.1.13. so it is asking for the password. So let's try to the password. That's it. So now this is so we have successfully logged in. Now what I want to do it is, so first we need to check the image, whether the Nginx image is there or not. So for that one I am using Docker image ls. So now we are able to see that the Nginx image is already present. The latest image is already present. So what I want to do, I want to create a container. So here directly I am creating the container, Docker container run, and I am using detach mode, and I will try to give the name Nginx-demo or Nginx-container. Okay. And what I want to do is, right now we need to do the port forwarding, right? I have already explained you that port forwarding, how we can do it. So here I want to do it -p, and here we need to use 8090 port. So this is the port number of the Docker host machine. So from the Docker host machine, which port number I want to bind it, and this and colon, and we need to give the 80 port number. So this is the port number which I want to contact inside from the container. And the container port ID, the left side will be always the Docker host machine port number, and the right side will be the container's port number. And I need to give the last one is the image name. That's it. Now when I press enter, automatically the container will be created. So if you want to check the container details, container ps-a, if you try to see, so we are able to see the Nginx container, and it has been created 7 seconds ago, and the status is 5 seconds ago. And if you see the port number, you will be able to see the port number, right? So 1 second, let's try to. So if you try to see the port number, and this one is something like 0.0.0.8090, and this one is the public port number, and it is accessing with the 80 TCP, right? 8090 to the 80. So here we are able to see this one. And now let's try to delete this container, MySQL container. So for this one it is already stopped. So Docker container rm, and I can give this container name. Automatically the container will be deleted. So here Docker container ps-a, and now only the Nginx is running, and the port you will be able to see, that is 8090 port from the Docker host machine, it is trying to listen. Now that means we can able to access from the 8090 port number. Now if you try to check it, so let's try to check it. So now for this one what we can do it is, so I will try to show the AP address show, and here you will be able to see this is the Docker 0 interface, and the Docker 0 interface is connected from the end with the 192.168.1.13. so this is the IP address which you will be having. And if you want to check the localhost loopback, so this is the 127.0.01. so this one is the local loopback IP address, or this is the IP address which will be available for all the local base machines, local machine and the base machine. This is used for the internal testing purpose. So if you try to check your local base machine or anything, you will be having this IP address 127.0.01. so this is used for the internal testing. Now if I want to connect to this one, curl 127.0.0.1 colon 8090, you will be able to see this Nginx and everything is able to get it. So this is how we can access it. That means we are able to access it from the outside. So 127.0. So you can also use this 192.168 also. So that is your IP address. So for this host machine, the IP address 1.13:1890 also you can use it. But so we are using from our Docker host machine, right? So you can use this internal IP address for testing 127.0.0.1:1890. Okay. So now you can able to access. So now Nginx is working fine. So this is, so now we have installed the Docker container. So now we have installed the, what I want to say is Nginx. Now the same scenario we will try to install the Apache also. So for this one, what we need to do, so right now we don't have the image, right? Docker image ls. So we don't have the Apache image. So first we need to download the image. So for this one, what we need to do is we need to search in the Docker hub. Okay. So let's go to the Docker hub and I will search for the Apache. So what is the image name for this one? So now here Apache, if I try to search it, here you will be able to see HTTPD. So actually in Ubuntu and the Debian OS it is called as an Apache 2, whereas in the Red Hat, Fedora and all the remaining Linux operating system it is called as an HTTPD. So that is the reason. So the Docker image is also the name of the HTTPD. Don't think that HTTPD is not an Apache. So normally it is called as an HTTPD in a Fedora, Red Hat, Linux type of thing. Only in Ubuntu and Debian type of operating systems it is called as an Apache 2. So let's try to use this image. Now I will show you another process how we can create the container without pulling the image. So I will try to show you. So here you will go here. So I am trying to create the Docker container ps-a, right? So we have created the Nginx container, sorry. So let's try to create it. Docker container run, and I want to run with the detached mode, and I need to give the port number. Okay. And port number is nothing but, so I need to connect to the Docker host machine 8080 with the 80 port number. Don't so this 80 port we cannot use again that 8090 port number again. Why? Because so the Docker host machine will contain only the single IP address will be connected to the single container. So you cannot use like this. Whereas here 80 port you can use it multiple times. Why? Because I already told you, right? The containers are isolated from each other. So each container will have its own IP address and each one will be having its own isolated thing. Because of the kernel namespaces and the C groups, it can have its own IP address and the own ports. So you can use the multiple ports, same ports for different containers. Whereas the Docker host machine, so you should have a single port number connected to a single container only. So one port cannot connect to the multiple containers. So that is the thing you need to understand. Whereas each container will be isolated to each other, so it can have the multiple same ports can be connected to the different containers. So this is one thing you need to understand very clearly. And here we need to give 8080 port number. It should be connected to the 80, and I am using the name. So name is nothing but Apache -container. Okay. And last one is the image I need to give. So image is nothing but HTTPD. So now I haven't downloaded the image, right? First what it will try to do is it will check that the image and unable to find the image HTTPD latest. Now it will try to download the image automatically. So now it is downloading the image. After downloading the image, it will create the container automatically. So instead of pulling the image, so we are directly running the container. It will try to check the image. If it is not, means it will download, and afterwards it will create the container. Now if you try to see Docker image ls, automatically the HTTPD is also downloaded and the container is also created. So if you see Docker container ps-a, and here you will be able to see Apache container also. Now it is listening to the 8080 with the port. Now if I try to check here curl 127.0.0.1:8080 means automatically you will be able to see the output. Now this is all okay, fine. So now can I able to access from the outside? Yes, we can able to access from the outside. So this is our outside base machine, and from the outside if I want to access means 192.168.13 actually. Yeah, 138080 means automatically the Apache is connected. And for the same thing if I want to connect to the 1890 means, then so you will be able to see welcome to the Nginx. Now we are able to successfully access the containers outside of our Docker host machine. Now I am able to access the containers from the Nginx container. I'm able to access the Docker outside the Docker host machine, and also I'm able to access the Apache also outside of the Docker host machine. So this is how we will be doing the port forwarding in our Docker host machine. So hope you understood about this port forwarding. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. In this video, we will see about the container restart policy. So let's try to learn about this. What is this container restart policy? In our previous videos, we have seen about the Docker creation process. So how we can create the process and the port forwarding, configuring the static IP address in the virtual machine, and all those things we have seen it. Now in this video, we need to learn about the container restart policy. So what is this restart policy? First of all, you need to understand why we have to use this one. As an administrator, so for example, if you are a DevOps administrator or anything, so who is managing these particular containers and all, if he creates a container, sometimes if I create a container, let's say that I am administrator, so sometimes I need to shut down my particular server automatically. So containers will get stopped. Again, I need to start the virtual machine or bare metal server or any cloud instance. So for example, here what is happening is, what I am trying to explain it is, so as an administrator who is managing the particular containers and the thing. So for example, if he creates a container or anything, sometimes so the containers and all those things, the particular server shut down the particular server automatically. So that means he, for some reason, he need to shut down the particular server automatically. So here what will happen? Containers will get stopped automatically. Again, what we need to do? So again, we need to start the virtual machine or the bare metal server or any cloud instance. Then the containers will come up. If the container doesn't come up, my container will be on down status until I started with the docker start command. So for some reasons you are restarting the server. So for example, particular server, if you want to shut down and restart means, so if you shut down the particular server means automatically what are all the containers present in that server will be stopped. So that means when you restart then what you need to do? So again, you need to start the virtual machine or the cloud machine or anything, whichever things, the server you need to start, and then the containers will come up. If the containers doesn't come up, so if the containers doesn't come up, the containers will be on down status until I start with the docker start command. So manually, if I try to start it, then only it will start. To avoid these kind of challenges, we have to use something called restart policy. As administrator, we cannot restart all the containers, right? So why? Because, so for example, for some reason you have shut down the server. Now you have started the server. So when you start the server, all the containers will start up, fine, it will come up, fine. So some containers, due to some reason, so it didn't get started means it will be in the down status until we start it manually. So here these challenges will be there. So for example, then what we'll try to do? So administrator, if all the containers got stopped means he cannot restart all the containers, right? So whenever I do a restart of my node, I cannot start all my containers in that particular node. Actually, it is not an easy task for the administrator. To simplify that particular job, we use something called as a restart policy. So in this register policy, in the Docker registry, we have totally in this restart policy, actually, we have total four types which are supported in the Docker engine. One is no, always, on failure, unless stopped, and the last one is unless stopped. So these are the four restart policies that are available at the time of Docker creation. The first one is no or never. So if you see this particular parameter, it is set by default. So if it doesn't mention anything for a container means it is set by default. No or never is a default one. Default restart policy that get assigned when we create a container without passing -- restart. So this is the parameter we will be passing with. If you doesn't pass anything -- restart means, or otherwise if you pass the parameter has -- restart no means, then this default restart policy will be applied. This means, let's say I created a container and I never passed a parameter called -- restart. Till now, while we have created, we haven't used this option. So up to now, when we are creating the container, we haven't used this option. So if you pass -- restart, what will happen? If you doesn't pass if you pass only -- restart, what will happen? The default restart policy will be applied. That is no. If it doesn't pass also, it will apply. If you pass only -- restart means the default policy is nothing but no will be applied. No in the sense means your container will never get started automatically by your Docker daemon. So you have to start it manually. So right now what we are trying to do, that is the only thing it will be applied. Whether if it is failed due to some reason or not failed due to some reason, or for everything you have to do it, you have to start it manually. If it is failed or not failed, something happened or anything, so if the container is stopped, means if you manually stop it or anything, whatever you do it, so you have to start it manually. That means with this policy, no container will not get started by the Docker daemon when a container gets exited with greater than or equivalent to 0. So that means the Docker daemon will not start this container when a container gets exited with greater than or equal to 0. For example, let's say that when you check the container status using command, so docker container ps, one of the container got with exit status as 0. So let's say that when you are trying to check the containers with the docker containers ps, so you know you came to know that one of the container got exited with status 0. What does it mean? There is no error in the application, it has stopped successfully. So that means in that container there is no error, it has stopped successfully. For example, you shut down your virtual machine, which we are using right now as a Docker host machine. So right now for the virtual machine which we are using, the Ubuntu server, so we have shut down our virtual machine. So when you shut down your virtual machine, automatically all the containers in that virtual machine will get stopped, which we have discussed it. So it is a successful exit actually. So that means the exit code will be 0 if the container shut down. Again, if I start my virtual machine, Docker daemon will get started. After that, my container will not get started. That is the default behavior of no. So whenever you start the virtual machine again, Docker daemon will get started, but the containers will not get started. That is the default behavior of no. You have to start it by using the docker container start command. This is the default behavior of no status, which is by default assigned to the container if you don't pass any -- restart policy. So this is the concept which you need to understand. Hope you are clear with this one. So the exit status can be checked with the two commands, that is nothing but docker container ps-a and also the docker container inspect container name. So if you want to get accurate details or more details about the container, means you can go for the second command, that is nothing but docker container inspect and the container name. Next restart policy is the always. If you want to create a container with always, you need to pass the parameter as -- restart always in the docker container run command. The purpose of this is the Docker daemon will attempt to restart when the container gets exited with any value greater than or equal to 0. So that means the Docker daemon will automatically restart the container whenever container gets exited with greater than or equal to 0. Let's say that for whatever reason your container has stopped. The exit code could be 0 or greater than 0. For whatever reason, the Docker daemon will try to attempt to restart. So that means if the container has stopped for any reason, it could be anything, any value, 0 or greater than 0, anything. So for whatever reason it is, the Docker daemon, what it will try to do, it will try to attempt to restart. If the container is stopped manually, so if you have manually stopped it, the Docker daemon restart is needed to start the container again, or we need to start if we don't want node restart. Okay, so the Docker daemon is needed to start the container again. For example, let's say that I stopped my container using docker container stop. That means you have intentionally stopped it. Remember that with this restart policy, it will never try to start your container when you stopped it. What you have to do, you have to restart your daemon manually. Then the changes will be applied. Means the restart policy of always will be applied, or you have to reboot the node. So when you apply for a container -- restart always, so you stop the container, means automatically the restart policy will not apply. So what you need to do is you need to restart your daemon, or otherwise completely you need to restart your node. Then only this -- restart always will be applied. Don't think that you apply the restart always for the container start, and you don't think that container will be the daemon will be starting that container always. Don't think like that. So you need to restart the server when you apply this restart always to the container. Rebooting the node is not an easy solution because all the applications will come down. Again your node has to come up. After that all the container has to come up, and you have to test your applications whether they are working or not. So this is not easy for production grade applications. So restarting the entire machine or the bare machine or the node or the virtual machine is not an easy solution because all the applications will come down. Why? Because I told you, right, all the containers will be stopped when you shut down your node. So then all the containers has to come up. Then we need to test the applications whether they are working properly or not. So this for production grade applications, this is not the ideal option. So for that reason, what is the best option is you have to restart the daemon. So restarting a daemon will not affect your applications. Always means for whatever reason it got stopped, your container will get started using the Docker daemon. So that is one thing. The third restart policy is the on failure. On failure means you have to pass the parameter. That is nothing but hyphen restart on hyphen failure colon max hyphen retries. Let us discuss this in detail. Containers will get restarted only if the exit code is greater than 0. So here in this one, the containers will get restarted only if the exit code is greater than 0. Whereas in the always greater than or equal to 0, the containers will get restarted. Here in this one, the containers will get restarted only when it is greater than 0. Only if the container got stopped due to some failure, means exit code greater than 0, then the Docker daemon will try to restart because you have written on failure. So that is the thing. If you stopped the container manually or the container got exited with a status code of 0, Docker daemon will do any restart of a container. You have to start it manually. So that means if you stopped the container manually or the container got exited with status code of 0 means Docker daemon will not do any restart of a container. So here I have written will not do any restart. You have to do it manually, where that is nothing but on failure maximum retries. Optionally, you can set how many restarts can Docker daemon will try. You have seen caller max retries, right? So you can also set how many restarts the Docker daemon has to try. What does it mean? As if you mention maximum retries. Docker daemon will try to restart first. The container did not start. It will try to do a restart again, and it will do a restart again. Like that, how many times it will do it is you define in the maximum retries. That many times it will try. The last option is unless stopped. So it looks similar to the restart always, but there is a slight difference between the unless stopped and the always. So if a container is stopped manually or exited with a 0 status, the Docker daemon will not do any restart on the container. So here unless stopped means so the Docker daemon will not do any restart if it is stopped manually or if it is exited with an 0 option. But what it will do on always, it will do a start, but whereas in this status it will not a start. So in the restart always it will do it will not always start it, but whereas in this status it will not start. This is the basic difference. But if your container is exited with greater than 0 means the Docker daemon will do a restart on the container. So in this status, if the container is got exited with an exit code of 0 greater than 0, then the Docker daemon will be restarted in this container. So this is all about the container restart policy. So now let's see some important notes in the restart policy. Restart policy can be set while creating a container or even after the container has been created. So this restart policy, which we have seen the extra parameter, so you can write that parameter at the time of the creation, or otherwise even after the container has been created also you can set the restart policy. Whereas the port forwarding, we cannot set it. You have to remember at the time of creation only. So this one you have to remember it very careful, that port forwarding you cannot set it. So port forwarding need to be decided at the time of the container creation only. Whereas the restart policy, you can use it, you can add it at the time of the container creation, or otherwise after the container has been created also you can set the restart policy. Container by default has never, that is no policy. We can set it after the container has been created also. Policy will affect after the container has started successfully and up for at least 10 seconds. So that means here the restart policy, if you have set for the container, the policy will be applied only after the container has been up for at least 10 seconds. For example, let's say that you have created a container. For some reason in less than 10 seconds the container itself is restarting. Then the container restart policy will not be applied. So container needs to be started and it should be up at least 10 seconds. Then only all the restart policy will be applied. Why? Because at the time of container creation, so all the configurations and all those things need to be applied, and it will take some time for the container to get up and started. So when the container is started up successfully, then we should wait for 10 seconds, and then only the restart policy will be applied to that container. So this is the another one which you need to understand. So hope you understood about this container restart policy. So we have totally 4 types of restart policy, that is no, restart always. So another one is on failure, maximum retries, and the last one is unless stop. So these are the 4 restart policy which we are having. So let's try to show you where it is. Yeah, on failure, unless stopped, no, always, and unless stop. So hope you understood about this restart policy. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the practical implementation of this container restart policy. So in the previous video, we have learned about the different types of restart policy what are available. So normally there are available 4 types, right? First one is never, and the another one is always, and the next one is what is that one? On failure, and last one is the unless stop. So these are the 4 things which we have learned. Now let's try to see one by one. The first one is which I want to tell you is, for example, let's say that, so right now I don't have any containers in my Docker host machine. If you try to see, nothing is there. So let's try to create one container, Docker container run -d and --name nginx -demo. I will try to give it, and I am not giving any restart policy. So that means by default the restart policy will be no, but we'll discuss about that one afterwards. And now when I try to click on this one, so it is asking the image name. Okay, sorry, I forgot to give the image name. Now a container has been created. Now if you try to check the container for this one, so now the container for this one is, it has been created and it is up 7 seconds ago. So now what I will try to do here, so now I will try to reboot my entire virtual machine. So now when I reboot my entire virtual machine, so what will happen is, so automatically the system will be shut down. So again I will be restarting my system. So now when I restart my system, all the containers that are present in this system or in this virtual machine will also be stopped. So just like your laptop, when you shut down your laptop, all the applications that are present in that laptop will be shut down, right? Will be closed, right? In the same scenario, if you try to close the virtual machine or reboot the virtual machine, then all the containers that are present in this one will be stopped. So I will try to show you the demo by default. This is by default. So now if you try to check here, I will reboot it, sudo, I am doing the reboot. So now it has been rebooting. You can check it here automatically. So it is rebooting again. So let it reboot. So now if you try to check the status of this container, so if I try to open, so this is something like SSH what I want to say is tool only. So this is one software application, mobile exterm. You can use it putty, or otherwise you can use with the, what is that one, SSH command prompt also you can use it. Why I am using this one is automatically my credentials and all those things will be saved directly. See here, network error stopped, right? So let's try to close it. When this one got on, so now this one on, right? Now what I will try to do is, I will start this one automatically. Here, so my system will be solved. So there is no need for me to type the password. So that is the reason I am using this one. So fine. So I am closing this one. So now let's try to check the status of the container. So if I try to check the Docker container ps-a, then you will be able to see that it is exited with 0. So that means, so previously when I am trying to restart this one, so here it is in the running state, right? But when I try to stop this one, automatically the container also got stopped. So what we need to do, if the container got stopped, we need to manually start the container. So this is one thing. And for example, let's say that if I want to update the what I want to say is the status of this container. If you want to update the status of this container, you can update it. As I already told you, right? The Docker container, what I can say is the Docker container, when you have already created the Docker container, you can update the status of the container. You can update the restart policy after creating the container also. Whereas the port forwarding, which we have learned it, right? So the port forwarding that should be added at the time of the container creation only. So you need to understand the difference between these two. So if you try to check the Docker container update -help, if you try to check here, so this is the Docker container help, and you'll be able to see everything. You'll be able to see, so CPU and memory, so process ID limits, and last you will be able to see a restart. So that means we can use the restart policy. So if I want to update the restart policy, means what I can do is docker content update hyphen restart. So I can give something like no, that is by default, and you can give nginx demo, that's it. So automatically the docker status will be updated. So if how can you check this docker status means, so docker container inspect the docker name. So if you try to check it here at the top somewhere, you will be able to see a restart policy. Maybe it will be mentioned or not, I don't know. Let's try to see it. Yeah, here you will be able to see a restart policy and the name is no. So this is how you can check the restart policy, what it has been applied for the container. So this is a default, this is the default restart policy. So whenever the container got stopped or the container is in the running process, means it will be never restarted again. So you need to do it manually. So whenever the container got stopped by any reason, whether it is manually stopped or anything, so the container will not restart again. So you need to do it manually. So this is the first one. So that's it guys. So if you try to check the docker container ps-a, so it is got exited. So how we can start this container? So we can start the container only docker container start, and you need to use the nginx hyphen demo. So we need to start the container like this. Now let's say that I will update the container with a restart always. So we know, right? So the second one is restart always. So we have checked about the never. Now the second one is restart always. So if I try to check docker container update hyphen restart, I am changing it to always. Okay, and for which one I am changing nginx hyphen demo, that's it. So now I have updated this container restart policy. Now if I want to check it, means, so here in order to start means we need to start this one. So I already told you that for the restart policy to apply, the container should be up at least 10 seconds. So now if I try to check the docker container docker container ps, now you'll be able to see it has up in 50 seconds ago. And if you want to check the restart policy whether it is applied or not, so you can check it with the nginx hyphen demo. So here at the top you can go and you will be able to see the restart policy automatically. So here always, and the maximum count is 0. So we are able to see the restart policy has been updated. Now what I will try to do it is, so let's try to check the container ps. Now the status is running, right? So I will try to stop this container. So docker container stop this nginx hyphen demo. So docker container stop nginx hyphen demo. So it has been stopped. Now if I try to check the status for this one, so now it is stopped. Now what I will try to do, I will try to reboot the system. So then, as this container has a restart policy of always, so if I reboot the system, automatically the container also should be started. So let's try to check it. Sudo reboot, and I will be using test 1 2 3 4. Now if you try to check, so it is rebooting. So it will take some time to reboot, and if you want you can check it here, the status. So here it is rebooting. So that means the virtual machine is getting, or the Docker host machine is getting restarted. So now what I need to do is, so if I log in into this Docker host machine or this one, automatically the container also should be up. Whereas in the restart policy, no, the container didn't get started. So we have did it manually to start the container. Whereas here in the restart always, automatically the container should be started. So if you try to check it again, so here if I try to on, so maybe this time it will connect, I think, maybe I'm thinking, yeah, so it got connected. Now if you try to, so now if I try to do it, what I want to do is docker container ps-a. If I try to check it, now see it is up 16 seconds ago, automatically the container also started. So this is about the restart always. So restart always will always start the container whenever the exit code is greater than or equal to 0. At any means when the daemon got restarted or the what I want to say is the container got restarted means then automatically it will be restarted. For example, let's say that I will stop it. I will try to show you another scenario also. So nginx-demo, I stopped it. So now if you try to check the container, it has stopped, right? Now instead of rebooting, I will restart the daemon, docker daemon. So for check, in order to check this one, systemctl status docker. So I have showed you this one. So test 1 2 3 4, let's log in, and you will be able to see that 1 minute 4 seconds ago the docker status is active and running. So now what I will try to do, so here I will try to restart this one, or otherwise restart the docker. Sorry, yeah, it has restarted. Now if I want to check the status of this one, see 3 seconds ago it has been started. Now if I want, so now I have stopped the container, right? So let's try to check the container status. So if I try to check the container status, automatically the container also got started. So that means there is no need to reboot the system. If you reboot, if the daemon also got restarted means automatically the container restart policy will be invoked for the particular containers and the restart policy will be executed. So these are the two parameters that are available in the restart policy. In the next video we will see the other remaining restart policies like on failure, max retries, and another one is unless stopped. So we'll try to see it in the next video. Hope you understood about these restart policies. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn about the another two restart policies, that is on failure and also unless stopped. So we have learned about the never restart policy and also the always restart policy also we have learned it. So in the previous video. So the remaining two things left out is the on failure maximum retries and also the another one is unless stopped. So let's try to check the first one. That is nothing but on failure max tries. So here what I will try to do is let's try to check the containers whether we have any containers left out or not. So right now we don't have any containers. So let's try to create a container, docker container, run -d and hyphen name nginx -failure. So just I am creating the name, that one, and I am using the restart policy on failure. Okay, the on failure, and the maximum retries is 3. So you need to mention it like this. You need to give the image name. So let's try to create it. Automatically the container has been created. So now when will this container will be restarted? For example, let's say that let's try to check the container. So docker container, what is the PS, right? So now the what I want to do is the container is up. Now let's try to stop this container. Docker container stop nginx -failure. So now I have stopped this container. Now if you want to check the status of this one, so it is stopped. So if you try to check, that is exited. So now you need to understand that this is exited with the status code of 0. So on failure, when the container will try to restart, so whenever the container has been exited with a status code greater than 0. Now here I have manually stopped it. So now let's try to see whether it will be starting or not. So now here if let's try to check it. Sudo systemctl docker restart. Restart docker. So I am restarting the docker daemon. So let's try to restart the docker daemon. So test 1 2 3 4. So now let's see. I have restarted the docker. Now let's see that whether it will be started or not. So still it is not started. Why? Because so here when you have used this restart policy on failure, so if you have exited with a status code of 0 means it will not be started. So but if you start the container, for example, let's say the docker container, and I will try to create another one. So docker container run -d -name nginx -never. So I will try to use the nginx -never. So with a no never restart policy, and I will give the container nginx. If I doesn't mention anything means the restart policy is never only. So I have created another one, Now let's try to check the Docker status of this one. So one is up and running, and I will try to start this another one also. Docker container start the nginx hyphen failure. So that's the, so these are the two things. Now if you try to check the status, both the containers are running. Now what I will try to do it is, so I will try to stop this container with an exit status greater than 0. So for this one, what we can check it is Docker container inspect, okay, inspect the nginx hyphen never. So I will try to stop this one, and I will use the grep status and PID. I want to get the PID of this one. So 3331 is the process ID that has been created for the container. So I will try to stop it. Sudo kill hyphen 9 and 3331. So I have killed that one. Now if you try to check the status of this one, so it has been exited with the status code of 137, and now it has been exited. So that means the container is not running. As this container has a restart policy, that is nothing but never restart policy. So the container will not restart again. So I will try to do the same thing for this one nginx hyphen failure, but this one is having a on failure restart policy. So that means if the container has been stopped by any means, so other than 0 means, then immediately the container will try to restart. That also maximum tries it will try to give it is the 3 times. So let's try to kill that one also. So here you will have nginx hyphen failure. So I want to get that. I want to get the process ID is 3463. So let's try to kill that one. Oh, sorry. So where is it? Yeah, 3463, right? 3463. So I have killed it. Now let's try to check the status for this one. So now if you try to check the status for this one, so previously the container started about a minute ago, but still immediately the container has been started up 2 seconds ago. It has immediately started. So that means whenever it has been exited with some status code greater than 0 means, so immediately the container will start again. So that is the nothing but nginx unless on failure. So on failure restart policy parameter is nothing but whenever the container has been stopped with an exit code status code greater than 0 means immediately when the daemon restarts or the anything. So anything means it will be restarted. So it will be restarted, not the daemon restart also. It will be restarted immediately. It will try to check it. If you manually stop that one means, so the container is not responsible. So the restart policy is not responsible for that one. So this is about the on failure. So now let's try to learn about the another one, that is nothing but unless stopped. So this one I have already told in our previous video when we are learning about the theoretical part on the restart policy, that always and the always and the unless stop both are one and the same only, but a slight difference is there, where always when you try to stop the container manually, it will restart it again when the daemon restarts or it will restart it again. But here when you try to stop it manually means then it will not be restarted, but for any case if it has been stopped means it will restart. So I will try to show you this one. So now I will delete this one. So I will keep this nginx hyphen never and nginx hyphen failure I will delete it, so that we can have a clear understanding about this one. So that one is up and running, right? Docker container stop nginx hyphen failure. So I have stopped it. Docker container rm nginx hyphen failure. So I want to remove this one. So I have deleted it. So now I want to create 2 containers. That is nothing but docker container run hyphen d hyphen name nginx hyphen always. So I want to have a restart policy of always, and I will have this one, right? So now from the nginx image I want to create it. So now I have created it, and again I want to create another container, that is nothing but unless stop. So that means it is nothing but stopped. I will do it, and here it is an unless stop. Unless stop. Okay. So this is the restart policy. Now let's try to create it. So now both are created. So now if I try to check the status for this one, so now 3 of them are there, and I will try to start this one also. Docker container start nginx never. So I have started this container also. Now if I try to check the status for this one, all the three containers are running, are started are running actually, and nginx -stop is having the restart policy of unless stop, and always has a restart policy of always, and nginx never has a restart policy of never. Now by some means I have stopped these three dockers. Okay, so with manually, so docker container stop nginx -never nginx -stop nginx -always. So I am stopping all the three containers. All the three containers has been stopped. Now if you try to check, all the three containers has been stopped manually. Now what I will try to do, I will try to restart the daemon. So if when I try to restart the daemon, so which container will be started automatically? So as usual, nginx -always will be started automatically. Why? Because it will start. So now if I try to run, so here I will do sudo systemctl restart the docker. So I am restarting the docker daemon. So when the docker daemon has been started, if you try to check it here, see, so nginx -always has been started automatically. Why? Because when I restarted the docker daemon, so if you can reboot it also, not a problem. Instead of rebooting it, I am restarting the docker daemon. So now nginx -always automatically started, but nginx -never or nginx -stop has not been started. So nginx -stopped will be started only when the status code is when it is exited other than 0. So other than 0 it is started means then it will be restarted. So that is the main difference for this one. So now let's try to start it. Docker container start nginx -stop and nginx -never. Okay, so now I am starting the containers again. So if you try to check the status, all the things are running. So what I will do is I will reboot the system. So that means I am shutting down the docker. So now let's try to see. So now all the containers will be stopped. So let's try to see what will happen. So now the container has been restarted. So let's see what will happen. So it will take some time to restart the server. Why? Because so here if you try to check my thing, so it is restarting again. So it will take some time. Let it take some time. Yeah, it is starting. Let's go to the mobile extern, and here I am closing it, this one, and I am again trying to restart the session. Maybe, hopefully, I think maybe I will get it, or otherwise we'll try to reconnect it again. It's trying to connect, but still it is running, right? So that is the reason it is not able to connect. Let's try to close this one automatically. I want to close the following device anyway. Yes. So let's try to open it again. Now maybe this time it will be connected. So whether the docker, yeah, now this time, yeah, this one is connected. Fine, right? So now let's try to check it. Now if I want to check the container status for this one, see, so what it is having, nginx -stop is running and nginx -always is also running, but nginx never will not start again. Nginx -stop, I told you, right? So whenever it has been whenever it has been exited by any reason, if it doesn't other than manually stopping, means the container will restart again. Nginx -always means, so whenever you do it, automatically when the docker daemon restarts or anything, it will automatically start. So this is the difference between these all the restart policy. Now we have learned the 4 restart policies. The difference, one is nothing but never, and the another one is always, and another one is on failure max retries, and the last one is the unless stop. So these are the different types of restart policies available in the Docker engine. And I want to tell you some important points to remember. So before closing of the session, so if you create a container for some reason, so you have, for example, let's say that you have created a container, and for some reason the container is going on restarting, so it doesn't get started. So it is container is starting and it is restarting, so going on restarting. Then if you apply a restart policy to that particular container, means, so you have, when you try to update restart policy for that container, means then it will not be applied to the container. Why? Because so the container is going on restarting. So you need to understand that the container has to be up and running for at least 10 seconds. So which we have discussed it in our earlier videos. So if you want a restart policy to be applied to a particular container, means the container has to be up and running at least 10 seconds. So then only the restart policy will be taken into effect. So why? Because the Docker daemon, after container start, then the Docker daemon tries to monitor the restart policy of that container. After the container starting only, it will try to be monitoring. So if you have manually stopped a container, restart policy will be ignored and it will be applied when your daemon is restarted. So for any restart policy, you have stopped your container manually, means just like the NGX always also. So when your daemon is restarted or your system is restarted, then only the restart policy will be applied. And the last point which you need to remember is that the restart policy will be available only for the Docker engine. It will be not available for the Docker Swarm, which is another tool for the Docker community. So this restart policy is exclusively available. This option is available only for the Docker engine in the Docker community. So this is all about the container restart policy. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. In the previous video, we have learned about the container restart policy. So what are the different container restart policies that are available? We have seen it. That is nothing but 4 container restart policies parameters are there. That is never, always, on failure, maximum retries, and the last one is the unless stop. So now in this video, we will see how we can deploy the WordPress application in a Docker engine or container and how we can access that WordPress application. Let's try to see. So what is this WordPress application if you try to see? So it is a content management system. So it is developed using PHP language. So it is a content management system. So content management system means the name itself indicates about the managing the content. So for example, let's say that if you are having a business, let's say you are having a business or you have started a business or anything, it may be a small or medium sized business application. Now you want to develop a website for that one. So what you need to do, so just you will be having a simple, what I can say is simple pages like home, about us, contact and feedback or something, contact us like that. So let's you will be having a 4 or 5 pages in that one. So that is a website page. Now, in order to design the web page, you doesn't know anything about this web development or anything. So, so what you will try to do, first of all, you will contact the UI developer or the front-end development team, and you will try to design the pages, and you will try to deploy the website. So this is how we will be doing it. Instead of contacting a front-end developer and all those things, so just using the WordPress. So you by selecting the templates, you will be having a series of templates, either it may be a paid version or a free version. So you'll be having a WordPress templates. You can select the template and you can make the website up. So that means there is no need to have a programming knowledge in order to make the website. So using the WordPress, we can develop the website without having any programming knowledge. So that is one thing. So almost 25% of the websites currently running in the internet are of developed using the WordPress technology only. So there are other alternatives with the WordPress also, like Joomla, Drupal. So many CMS management is there. So WordPress and these all things are under PHP, and other programming languages also maybe we will be having CMS sites. So these are very famous CMS concept. So now that is all about the WordPress application. So now how we can launch this WordPress application, let's try to see. So in order to launch this WordPress application, so what are the requirements we need to have? Let's try to understand it. So here I am taking something like an presentation so that I will show you how we can, before implementing the, creating the containers for the WordPress and all those things, just I will try to explain you theoretically. So what are the steps we will be trying to do in order to create the WordPress application. So let's try to see. So let's say that I am having a red color I am taking, here. Let's say that let's try to, so let's keep it like this only. So here I will be having a very big box, that is nothing but, let's assume this is a Docker host machine. So this one is a Docker host machine. So what is this Docker host machine? So what I will be trying to tell you is Docker host machine is nothing but our Ubuntu server or the virtual machine which we will be trying to do. So which we will be trying to install. So right now in this one, so ours is Ubuntu server. So this is our Docker host machine. Let's have application. And this Docker host machine so is connected to a network that is nothing but ENP PS03 or OS3 or something like that you will be having, and this is connected to a network something like 192.168.0.12 or 13, so something like that. So mine, in my case, that is 192.168.0.13. in your case maybe different, 1.40 or something, 1.30 or something like that you will be having. So depending on your configuration you will be having. So that is the network you will be having. And now, so in this Docker host machine, so we will be installing the Docker, right? So so whenever you install the Docker host machine, so you know that a Docker interface will be created with the name Docker 0. So Docker 0. So a Docker interface will be connected, and it will be having a IP address that is nothing but 172.17.0.1/16. So these are all private address, and Docker 0 on one end is connected to the Ethernet, that is nothing but ENP-ACRC, that is nothing but 192.this one. And here the Docker 0 is responsible for creating the for assigning the IP address to the containers. Now I will be creating the application that is nothing but WordPress application. So here the container is WordPress. Okay. So in order to install the WordPress or thing, so we need to have two things. So WordPress, for installing the WordPress, so it requires a database. So why? Because it needs to store the content. So where it will store the content is, by default you will be using the MySQL database. So MySQL database, it will be storing the content. So that means we need to have a MySQL container also. So we will be having two containers, that is MySQL. So now you need to understand that which one I need to install first, which one I need to create a container first. So here you need to create MySQL container first. Why? Because so WordPress needs the MySQL. So that means when you are trying to create a WordPress container, so it needs the MySQL container to be established, so or otherwise to be present. So that means first we need to create the container MySQL, then only we can create the WordPress. So that means MySQL container will be created first. So then for this one, Docker host machine will give an IP address that is nothing but 172.17.0.2. So this is the IP address which will be created, and by default you know that MySQL database will be listening to the port number 3306. Okay, and afterwards, after creating the container MySQL, then we will be creating the container WordPress, and WordPress by default the Docker 0 will give the IP address 172.117.0.3. So this is the IP address for the container, and by default this WordPress will be listening to the port 80. Why? Because in this WordPress you will be having the web server that is nothing but Apache. So Apache by default will be listening to the port 80. So that is the reason. Now the WordPress, so this one you will be having, this is the IP address you will be having, and this is the IP address you are having, and this one will be listening to the 80 and 3306. Now you need to understand that this is all in the Docker host machine only. So these are all private address which is available in the Docker host machine, and these addresses we cannot access it outside the Docker host machine. Within the Docker host machine you can access the WordPress MySQL and you can do it whatever you want, but outside the Docker host machine you cannot access it. Why? Because these are private address which is applicable only in this Docker host machine. So what we will try to do, so we already learned about the concept, that is nothing but we will be using the port forwarding. So which container, so you need to understand that which container I want to make it visibly public. So we know that WordPress, so WordPress is the thing which you need to make it. So then what I will try to do it is, I will try to do the port forwarding with the port number of 8090. Okay, so that means whenever the user tries to use this one 192.168.0.13 colon 8090, then automatically it will be port forwarded to this container. So this is how we will be doing the port container, and here in between this one internally, so this can communicate with each other. So there is no need to do the port forwarding and all those things. Internally this can communicate with each other. If you want, you can also do this port forwarding. I will not do the port forwarding. Why? Because there is no need for me to use this MySQL outside. So MySQL will be used internally with the WordPress. So here it can communicate with each other. So this is the whole total concept which we will be trying to do it. So we will be installing the WordPress and the MySQL, and we will try to install it. So hope you understood about this installation process. So in the next video we will see how we can practically implement this WordPress application development by using the Docker engine containers. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In the previous video, we have seen the practical implementation of installing, how we can install the WordPress and also the MySQL database in our Docker container. So in this video, we will try to see the practical implementation of installing the WordPress and also the MySQL database in our Docker container. So right now here I am using the Docker container. So you need to understand that. Let's check my IP address. What is the IP address for this one? I am checking the IP address for this one. IP address show. So here if you try to check the IP address, so this is my static IP address which can be accessed outside of the Docker machine. And 172.17.0.1 is the Docker 0 by default interface IP address. So that means whenever you are trying to create the container, so the Docker will be assigning the IP address to this one. There is nothing but 170.17.0.2.0.3 like that. So now we need to install the WordPress and also the MySQL. So which one we need to install first, WordPress or the MySQL? So let's try to see here. So if I go into here and let's go to the Docker Hub. Okay. So I will try to check the Docker Hub. In the Docker Hub container, so what is the first one which I need to download? That is nothing but WordPress. Now let's try to open this one. Yeah, here I will be searching for WordPress. WordPress I have searched it. And if you try to see here the Docker official image, so I will be checking for the Docker official image, and this is the Docker official image for the WordPress. Now if I try to open this WordPress, and here you will be able to see the WordPress, and so it will be using the PHP, and we already know fast CGI, and the Apache server it is using in the backend, and the PHP version is 8.3. so that's it. So now if you try to see bottom, so you'll be able to see WordPress is a free source. 22% of the websites are used by WordPress only, and this is the command we need to run. So do we need to run this command first? Let's try to see it. Docker container run. So they are giving the container name and giving some network, and also -d WordPress they are doing. And if you try to see bottom, and if you like to access the instance from the host without a container IP address means, so we will be doing the port forwarding. So that's a different thing. So fine. So for here we need to have a DB host, DB username, DB password, and also a DB name, and also table prefix. So that means, so in order to install the database, so we need to have a database. In order to install the WordPress, we need to have a database first, so that I can provide the DB host, DB user as environment variables, or otherwise the WordPress will be asking randomly. So that means we need to install the MySQL first, so database first, then afterwards by using that MySQL database we will be installing the WordPress container, and in the WordPress, so we can give this all MySQL database credentials. So let's try to install the MySQL first. So depending on the situation, which one we need to install the container, we need to understand. So here in the Docker Hub, I will be searching for the MySQL. So already we have the image, I think, MySQL. Just I am opening it. In order to have environment variables, what we need to submit it. So MySQL, if I try to press MySQL, and also we need to have a Docker official image. So that is nothing but this is the MySQL Docker official image. Now if you try to see here MySQL, let's go down, and this is the content. This is the thing we need to run, and here we need to provide the MySQL root password. So if you come down here, the environment variables, so here you'll be able to see MySQL root password we need to give, and also the MySQL database we need to create. And if you want, other than root password, if you want to create any other users means, you can give the MySQL user and the MySQL password. So that's it. So we have already in our previous videos, we have installed this MySQL container, right? So in the same scenario, we will be creating the MySQL container. Now let's go to the mobile xterm. So there is nothing but here I have already connected to my server. Now here let's try to see whether any available or not. If you try to see here, so we are having some Nginx container and Apache container. So what I will try to do is I will try to remove these two containers. So I will clean up these two containers. So Docker container rm Apache container, yeah, and also Nginx container. So I will be deleting this Nginx container. So press enter. So all the things will be, all the containers is deleted. So if you try to check my containers, so nothing is there. So fine. So first, what is the container we need to create? that is nothing but MySQL container. So for MySQL container, let's check that whether image is available or not. You'll be able to see that MySQL image is available. So let's try to create the container using the MySQL image. So docker container run -d in the detached mode, and we will be not using the port forwarding. Why? Because we don't want this MySQL to be exposed to the outside. Now -d is there, run -d is there, and we need to give the name of the container. There is nothing but MySQL container I will give. And another one what we need to give, if you try to check here, the environment variables, first MySQL root underscore password and MySQL underscore database. Okay, so here I can give -e MySQL underscore root underscore password is equal to test1234. So just I am giving test1234 for the demo purpose only. So now MySQL underscore database. So for the database I am giving the WordPress. So you can give whatever the database name you want, you can give it. But at the time of WordPress installation, if you WordPress asks what is the database I need to means, you need to give the WordPress whatever the database name you have given it here, that is the same name only you need to provide it there also. That's it. So these are the thing, and at last what we need to do is we need to give the container name. That's it. Now when I try to press enter, automatically the container will be created. So container will be created within no time. So docker container ps-a. Now you will be able to see MySQL container has been created, and it is listening to the port 3306. Let's see that whether I can able to connect to this container or not. So MySQL. So we know that MySQL client is installed in this one. So -h 172.17.0.2. This is the thing, and -u root and -p. So it will ask for the password. There is nothing 1234 and cannot connect to the MySQL server. So why it is cannot able to connect it? 3306 it is there, right? So MySQL container, it is up. Okay, so let's try to check docker container inspect MySQL container. Okay, let's try to check it, and the IP address it is assigned is 172.17.02 only. So fine, without any problem. Let's try to check it again. So maybe the container immediately got started, right? Let's try to connect again. So MySQL -h 172.17.0.2 and -u root and -p password test1234. So now it is connected. See, so we are able to connect it. So fine. Now let's try to check the databases. Show databases. So we are able to see a WordPress database has been created there, and if you try to use that database, use database WordPress. So I'm going to use WordPress. Let's try to use it directly. WordPress has been used. Now if you try to check the tables in this one, so nothing tables are there. So now MySQL has been successfully installed. Now it's time for us to install the WordPress also. So exit. So fine. Now the second image which we need to install is the WordPress. So if I go into this WordPress, so this is the WordPress we need to install it, and everything is there. So where we can create this WordPress. So now we have the DB user and all those things, right? So one thing is, so you know about the DB user, that is nothing but WordPress DB user is root, and DB password is test1234 which we have created, and DB name is the WordPress, and we doesn't have any table prefix like WP underscore or some prefix. We can add it at the starting of the table, so that that prefix will be there. So we haven't added any prefix for that one. So these are all the things we can provide it as an environment variables, or otherwise after installing of the container, the WordPress also will ask you these are all the things. So let's try to do it in the so instead of providing the environment variables, let's try to provide it through the UI dashboard only. So here I am creating the container, so something like docker. So right now I don't have the image, right? So right now I don't have the image of the WordPress. So first I need to download the image, right? Docker pull. So I'm not pulling the image directly, I'm creating the container without having the image. So that means what it will try to do, first it will try to check in locally whether the WordPress image is there or not. If it is not there means then it will download the WordPress image and then it will try to create the container. So let's try to do the second version. So docker container run -d hyphen name WordPress hyphen container. That's it. So this is the name I have given and this is the thing I have given. Now what I will try to do is I will give the port forwarding. So -p 1890 should be listened to the 80. Okay, so we should give gap or not, I don't remember exactly. Yeah, so that's it. So 1890 port will be accessed from the 192.168.0.13 and 80 port is the default port of this container. Fine. So that's it, and I will give the last is the WordPress image. So it's enough. So these are more than enough. And if I click here, unable to find the image WordPress latest locally, and it is pulling from the Docker hub. So it will take some time to download this WordPress, as that WordPress image is little bit larger in size than other images. So depending on your internet connection, the WordPress image will be downloaded. So let it download. So it will take some time. So now the Docker server has been, sorry, not the WordPress has been installed. So if you try to check the status container -a, if you try to check the status of this one, Docker container ps-a, now you will be able to see both the WordPress and also the MySQL's containers are started. So now let's check the image also, whether the image is available or not. If you try to see, the WordPress image is also available, that the total size is around 685 MB, little pretty much big, that one. So fine. So now we got the WordPress image also, and also we have did that port forwarding with the 1890 port. Okay, now what is the IP address of this Docker host machine? So Docker, sorry, I will try to do not Docker, IP address show, and this Docker host machine. So here the Docker 0 host machine is 172.117.0.1 and it is listening to, and the Docker host machine is 192.168.0.13. So now I can use something like in the browser. If I go into this browser, and here I can search for 192.168.0.13 colon 1890, and if I try to press enter, automatically the WordPress installation will open. See here it is asking you English, continue, and here it is telling that welcome to WordPress. So the database is not existed, so do you want to create a database? Okay, let's go. And here it is asking you the details. Database name, we know that we have given the name as WordPress only, and the username is root, and the password is test1234, and the database host is not localhost, that is nothing but 172.17.0.2. So in this place the container has been installed, right? Table prefix, if you want you can give wp underscore, or otherwise you can leave it. So click on submit. Now see, the database has been successfully created. So now done. So site title is asking, okay, we can give something like leelawebdev, and here username. So let's try to create the username for this one, and I will create the weak password. Fine. And here you can give the email ID. Okay, so now install WordPress. That's it. So now the WordPress will be successfully installed. So it is taking some time to create. So here you'll be able to see the WordPress is loading. So here it will take some time, I think. Yeah, it has been created. So okay, so login. Okay, login, and here you know the test user and the test 1234, and we are able to successfully log in into the WordPress dashboard. So this is the dashboard which you will be able to see, and if you try to see, these are the posts. So if you want to create a new post, you can create it, and if you want to visit the site means directly you can click it here, you will be able to see the website. So this is how we will be installing the WordPress and the MySQL in the Docker host machine. So now we have completely installed the Docker host machine. If you try to see Docker container ps-a, we are able to see the two containers are up and we are able to access the WordPress outside of the Docker host machine. Hope you understood about the installation of the WordPress and the MySQL. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel leelawebdev. In this video, we will learn about how we can install or how we can deploy the Jenkins CI/CD pipeline container in our Docker engine. Let's try to see it. So before learning about this one, so just I will try to explain you the steps how we can deploy the Jenkins CI/CD application. So for example, let's say that this is our Docker host machine. So here let's try to go to draw and I will select this one. Yeah. Oh, what happened? Yeah. So this is our Docker host machine. Let's assume. So this is our total Docker host machine, and this one is called as a Docker host machine. Okay. And this one will be having an internet that is nothing but ENP0S3, right? So let's try to decrease the and ENP-S03. So that is nothing but 192.168.0.13 in my case. So in your case, the IP address will be. So this one will communicate to the external world. And this ENP0S3 is one end is connected to a Docker 03. When you have a Docker engine installed in your Docker host in your virtual machine, so then Docker 0 interface will be created with an IP address of 172.17.0.1/16. Okay, and this one end will be connected to the ENP0S3 and ENP03 will be connected to the external world. So now, in this Docker 0, one end will be connected to the containers. So here I will be installing the Jenkins CI/CD pipeline. Okay. So for CI/CD pipeline, so the IP address will be 172.17.0.2. Okay. And we know that this one we cannot access it outside of the Docker host machine. Inside the Docker host machine, you can access it like 172.117.02. So that means this is a private address. So this is a private address and this one will be accessed only inside the Docker machine, and we cannot communicate to the outside of the Docker machine. So we cannot access it. So that means if it wants to communicate to the external world means, so it will connect to the Docker 0 and Docker 0 will be connected to this one, and this one has an access to the external, and this one will be sent automatically to this one. But if you want to send any information to this one means you cannot send it. So this is one thing which you need to understand. And by default Jenkins will be listening to the port 80. And now what we need to do, as we already know, so we need to do the port forwarding. And here the port forwarding will be, so it will be listening to the 8090 and we will be doing a port forwarding to the 8090. So whenever you try to access 192.168.0.13, 8090 port means it will be connected to this Docker host machine. So these are all the concepts we have learned it. So just I am explaining an overview how we will be implementing the Jenkins CI/CD pipeline deployment in the Docker host machine. So now you hope you understood about this concept. So let's try to understand some basic information about the Jenkins. So what is Jenkins and why we need to use this Jenkins in our development process. So I have designed a PPT for this one. Let's try to see. So Jenkins application deployment. So let us understand why we have to go for Jenkins as one of the CI/CD tool. So Jenkins is one of the open source for the CI/CD implementation. So here why I am telling is Jenkins is a CI/CD tool. So that means continuous integration and continuous deployment tool. So why we are going for the Jenkins is an open source for CI/CD implementation. As DevOps culture came into picture, we need to automate everything. There should not be any manual intervention or manual work. So that means when the DevOps came into picture, so everything should be automated and there should not be any manual intervention. So that means manual work or manually deploying or anything should not be present. So we have Ansible, we have Terraform and so many tools like Ansible, Terraform. So these are our automation things. So we have so many tools. Let's say for example, a developer will write a code and developer will push the code to the version control system. So it can be CVS or distributed control system. So that means, so as a developer, we will write the code and we will commit the code into the virtual control systems like Git, like GitHub, Bitbucket, AWS repos. So whatever it may be, whichever thing you are using, GitLab, anything. So it will be pushed, the code will be pushed into the version control system. So when I push the code, the Git repository, someone has to do the job. So when we have pushed the code, so that means our job is, as a developer, the job is finished. So when we push the code, someone has to do the job with the pushed code. That particular tool is nothing but your CI/CD tool. So the next job is done by your CI/CD tool. In that tool, I am choosing Jenkins because it is an open source. Everybody can download the code, no license key, and we can start using it. So that means everybody can download the code. There is no need of license key and anything, and we can start. Everybody can start using it. Since it is an open source, we have plenty of contributors to this particular development. So that means, so many collaborators will be there for this particular development. We have so many plugins that we can integrate n number of services or n number of tools to your Jenkins. Jenkins was developed on Java program. If you are really comfortable with Java code, means it will be really comfortable for you to customize your Jenkins application by using some Groovy script. Jenkins listens by default on the 8080 port number. So this is one thing you need to understand. It listens on the 8080 port number. Jenkins will have one more component called as slave. So in the Jenkins, we have one more component called as slave. But here in this application, I will be not deploying the slave. Just I am explaining you about an overview of this Jenkins. Slave is nothing but Jenkins worker node. Now, if my master wants to communicate with the worker node, then it will use a port number called 50,000. So that is why I am mentioning here. By default, Jenkins dashboard will be listening to the port 80, and Jenkins also has a slave which is called as a worker node. And that worker node, if it wants to communicate with the master thing, it will use the port number 50,000. Jenkins master can have a slave. Now master wants to communicate with the slave, or slave wants to send data to the master, means it is done through the 50,000 port number. That's why we have two port numbers in the Jenkins. 80 port number is to access the Jenkins dashboard. 50,000 port number is to Jenkins server to access your slave. And next comes the data, the application data or the Jenkins data. It will be stored under var/lib/Jenkins. If you have installed the Jenkins not as a container, if you have installed as a bare metal server or a virtual machine with the help of package manager or something like that, or the cloud in the cloud or something like that, then the data will be stored in var/lib/Jenkins directory. That is the thing. So if you have not installed the Jenkins as a container, means as a Docker container, if you have installed directly like a traditional way, means then you will be having a data folder or something like Jenkins. If you install your Jenkins as a container in a Docker or Kubernetes, for example, then the default location will be /var/Jenkins_home. So this is the folder where the data will be stored. We can customize this based on your requirement, but by default, if you are using official Jenkins image, means then the location will be var/Jenkins_home. After this, you can see Jenkins uses a lot of plugin to create action specific to the task or a job. If you write a particular pipeline, if you want to write a particular pipeline, means so everything will be a plugin based only. For example, for every task in the Jenkins to do, we have plugins. That plugin will do the actual action to that particular task. For example, Jenkins want to talk to the GitHub, means we have a separate plugin for it which is called as a GitHub plugin. Now that particular plugin will help Jenkins to communicate to your GitHub with the necessary actions. That's it. So everything is a plugin based. So you can install the plugin, everything will be available. So you can install the plugin and you can start using that one. For every particular task, you will be having an actions for that one. We can build CI/CD jobs using DSL or Groovy language. For example, if I want to write the pipelines in the JavaScript, Jenkins means we can use that DSL or we can go for Groovy script as well. So for that, what we can do it is, so for that means for that you need to know the Groovy language. If you don't want to learn Groovy language, means you can go for a simple DSL, that is nothing but domain specific language also. This is the basic information about the application which we are going to deploy in the Docker engine, which is called as a Jenkins CI/CD pipeline. So just I am giving you a basic overview of this one. So hope you understood about the Jenkins, about the information. Those who doesn't know about the Jenkins, just I am giving an overview why we use the Jenkins in our DevOps culture and the developer thing. So what is the use of this Jenkins? So hope you understood about this Jenkins CSD CD pipeline. So next in our next video, we will start practical implementation deploying the Jenkins container in our Docker host machine. So hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will see how we can install the Jenkins CI/CD pipeline in our Docker host machine. So in the previous video, we have learned what is the use of this Jenkins application and why we use this Jenkins application instead of having so many other CI/CD tools like Bamboo and all those things. So let's try. So we have seen those all things. Now let's see how we can install this one. So for installing this one, so as I already told you, right, we need to have an image, Docker image. So for that Docker image, what we need to do, so we'll go for a dockerhub.com. Let's open this dockerhub.com, and in this dockerhub.com, if you try to see here hub.docker.com, and in this one, let's open. Yeah, we need to search for the Jenkins. So okay, fine, let's search for the Jenkins. And if you try to search for the Jenkins, and this is the Docker official image. If you are able to see, this is the Docker official image. As we have learned that first we need to take the priority as the Docker official image. So first we need to take the priority of this Docker official image. Then only afterwards only we can go for the verified publisher, sponsored OSS. So like this hierarchy we need to maintain. Fine. Let's go to this Docker official image. And if I click on this Docker official image, and here you will be able to see that this is a duplicated, and we need to use the Jenkins :LTS instead. So that means they are telling that this image has been deprecated for over 2 years in favor of the Jenkins LTS. So that means if you want to install the Jenkins image or the Jenkins container, if you want to create, means we need to use Jenkins :LTS. Okay, fine. Let's try to use it. So for creating the container, what we need to do is, so here I have opened this one. So I have on that our Docker host machine Ubuntu server, and let's try to see whether we have any containers available or not. So if you try to see, so we doesn't have any containers created. So this is a brand new thing, and let's try to create a container. In order to create a container, we need to first download the image. So instead of downloading the image, we can directly run the container. And what this Docker will try to do, first it will try to search for the image whether it is existing or not. If it is not existing, means then what it will try to do, it will try to pull the image, and then afterwards it will create the container. So let's try to create the container directly. Docker container run -detach mode, and what I will try to do, I will give the name of the container, that is nothing but Jenkins _container. Whatever the name you want, you can give it. Just I am giving Jenkins container. And we need to have a port forwarding, so that should be 8090, and this will be listening to 8080 port number. And if you want to know more details about this one, means, so you can go into this here and you can see more details about this one. So how to install this Jenkins and all those things. So here you'll be able to see Docker pull and all those things. And I don't think that they are giving the information. So fine, so let's try to create it. So I will not go too much into this one, and I need to give the Jenkins :LTS. So this is the image name. So that's it. These are all the options which I am trying to give. Let's try to click enter, and here automatically the container has been created. Why? Because I already have the image installed in my Docker. So here Docker image ls, if you try to see, I have already downloaded this Jenkins /Jenkins LTS version tag LTS, and the size is around 470 MB. So already the image is there. So that's why the container has been created successfully. If you don't have this image, means it will try to download and it will create the container. So no need to worry. So now the Docker container has been created. Docker container ps-a. If you try to see, so this is the container, and the status is it has been created 37 seconds ago, and the status is it was running 35 seconds ago. So now it is listening to the port 8090, port forwarded to the 8090 from the 8080 port. So fine, everything is working fine. So now what I want to do it is, so let's try to check that whether we can able to access this Jenkins or not. So if I want to access this Jenkins, so what I want to do, I need to know the IP address of this host machine. So IP address show, or otherwise IP config A also we can do it. So here you will be able to see 192.168.0.12 is my static IP address. Okay, let's go to the Google here, and what I want to do it is, so here I am creating colon 8090. That's it. So now if I try to open it, now I am able to access the Jenkins. So here it is asking me that, so this is the opening or the welcome screen, and it is telling that to ensure Jenkins is securely set up by the administrator, a password has been stored in the login file in the server, and this is the place where the password is there, and in this place we need to read the password and we need to type the password here. Please copy the password from either location and paste it below. So fine. So we can find the password in two locations. First I will try to tell you, when at the time of Docker creation, so the logs will be there. So you can check the logs for the container here. So I will try to show you the logs. Docker logs and the container name, that is nothing but Jenkins underscore container. That's it. So now if you try to click the logs, and here you'll be able to see, so the Jenkins container has been created, and the Jenkins initial setup is required admin like this, and this is the password. Okay, and we can able to find the password at this location they are saying. So here in the logs also you can able to see the password. If you want to check the password in this location means, then you need to log in into the container. So you know that we have already seen how to log in into the container. That is nothing but docker exec hyphen interactive terminal, interactive, and the terminal I want to open, and that is nothing but Jenkins underscore container, and the terminal I want to open is the bash. That's it. So now we log in into the container. So where it is located, in the where Jenkins underscore home, in the secrets it is located. Okay, let's go to the /var/Jenkins underscore home. If I try to check the ls, so you will be able to see a secrets folder. So let's go into the secrets. Oh sorry, this one is secrets. Yeah, I went into the secrets, and if I press ls, and you'll be able to see a file initial admin password. So you can do the cat initial admin password, and this is the password which we are able to see in the logs also. So now we are able to get the password. So fine, let's go here and we will type the password and click on the continue. And this is the first time we are logging to the Jenkins. That is the reason it is asking the password that which has given in that particular file. Fine. So now as we are new to this Jenkins pipeline, so we doesn't know what are the plugins need to be installed. So it is better for us, let's the Jenkins install the suggested plugins. So let's try to click on this one. Automatically the plugins installation will start, and if you want to check the status of this one means, so you can check it again in the logs. So let's try to exit here, and if I want to check the logs, so this is the thing, and if I want to check the latest logs means you can type the -f. Now you will be able to see the real-time logs. So here everything it is getting downloaded. So downloading credentials, downloading build timeout, downloading the plain credentials. So like this it will be showing you all the things, and if you try to check it here, and here one by one the the plugins are getting installed. So now you will be able to see clearly. So this is how the Jenkins, all the plugins will be installed. So depending on your internet connection and all those things, so it will take some time to install. So let it install, and these are all the different types of plugins which we will be using. So right now this is not the course related to the Jenkins CI/CD. So in the future we will do the CI/CD course also. In the future we will do it. So right now just I am showing you how we can set up the Jenkins container in the Docker host machine. Just I am trying to show you. See, one by one is getting installed. So everything is getting installed. If you try to see in our log also, so here it is, everything is getting downloaded. So one by one jQuery 3, eCharts, JUnit, and everything is getting installed. So let it install. So now if you try to see, all the plugins has been successfully installed, and at the time when we logged into the Jenkins, we have logged in with a temporary admin. Now it is asking you to create the first admin user. So let's try to create it. So I am using the test user only. So I will be using the password test1234. So just for the case I am creating it, and if you want to write it full name you can write it, and here also I am giving the like this. So like this you will be creating the first admin user. So don't click on the skip and continue as admin. So click on the save and continue, and if you try to click, So now this is the Jenkins dashboard URL, and this is the dashboard URL which is trying to tell it. And now let's try to click on the save and finish. And now the Jenkins is ready. Your setup is complete. Start using the Jenkins. Now you will be able to see using the Jenkins. Now if you try to see, this is the Jenkins dashboard. So this is how we will be installing the Jenkins container in our Docker host machine. So hope you understood about this concept. So if you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you. Hi guys, this is Leela. Welcome to my channel Leela WebDev. In this video, we will learn some of the basic commands of the container create and also the container run. So which we have forgotten when creating the container. So let's try to discuss about this container create versus container run and also the container exit command. So let's try to see it. So normally how we will be creating the container, as you know, the Docker container run -d and you will give hyphen name. So let's say that nginx -demo, let's assume. So and another one is let's say that -m. So I will give ubuntu -demo. Okay, so the name I have given it, and I am running it in the detached mode. So let's say that I will not run in the detached mode, and I will use something like -rm. So what is the option, what is the meaning of this one is, so now automatically I will try to log in into the container. Okay, and after coming out of the container, automatically this container will be removed. So that is the meaning of this one. So that means I need to log in into the container. So for login into the container, what I need to do, so here I need to use an terminal and interactive mode. And what I need to do, so here I need to give the image name, that is nothing but 20.04. I will try to give it, and I need to log in with a shell, that is nothing but bash shell. So I will use any shell, you can use it. So bash shell I am using. So here I am running container, I am creating the container, and I am automatically logging into the container after creation. And when I come out of the container, automatically the container will be removed. So now when I click on enter, so automatically the container will be created. And if you try to see the root, so you will be able to see the root at the random number, that is the host, so server name. So here the container has been created. Now we have automatically logged in into the container. So that means when I run ls-l, automatically you will be able to get it. And if I try to run apt-update, and you will be able to update the Ubuntu packages, apt index, those also will be get updated. So like this we can use whatever the commands you want to run, you can use it. So for example, if I want to check the IP address of this one, so we can also check it, IP space a, so command not found. Why? Because this is the Docker. So we can install apt install IP route 2, so that we can able to execute the commands, IP related commands we can execute it. And now we are able to install it. Okay, press enter and it will be installed. So it will take some time depending on your internet connection. So it has been installed. Now what I can do, I can run the command apa. So this is the IP address of this one, 172.17.02. So this is the IP address that has the Docker engine has given to it. So like this you can do whatever the things you want. And when I exit from this container, okay, when I exit from this container, automatically the container will be removed. So if you try to see Docker container ps-a, so nothing is there. So container will be automatically removed. So that is the option of this -rm. So when you want to log in into the container directly, and after performing some actions or anything, so if you come out of the container, if you want to get the container automatically removed, means you can pass this option -rm. So this is one option. And another one which I want to tell you is, so now for example, so this is the run command, we have used it, right? For example, let's say that I will run the command -name nginx -demo. Okay, so I want to run it in a detached mode. And what I want to do, so the image I want to give it is the nginx. If I try to create it, automatically the container will be created. The run, what is the use of this run? -d detached mode means a process ID will be created and it will be thrown to the background. Now if you try to see the Docker container ps, now you will be able to see that created and status is up. So this is the Docker container ps. Now it is running, right? So the thing is running. So what is the reason, what is the meaning of this container run? So when you create a container using this run command, automatically the container will be created and it will be in the running state. So now I will try to create another command using the create. So we have learned about this create also, right? So I will try to use the create command and I will use ng-demo1. So now this is the -d. So I will try to remove this. So there is no option like -d for the create command. Why? Because the container will be just created. So but the container will not be started. So if I try to create here, automatically the container is created. If you try to check the PSA and nginx-demo1 has been created, but the status will be in the created state, but it is not running. So if you want this container to run means you need to manually start the container. So that means docker container start the container name nginx-demo1. That's it. Oh sorry, the spelling mistake. nginx-demo1. So the docker container will be running. So if you try to check the docker container PSA, so both the containers are running. So this is the difference between a container create and a container run. So container create means the container will be created and there will be no option for this -d. You should not provide the -d. Why? Because the container will be just created. It will not be running. So if you want to run the container means you will run the container. You should run the container manually. So why this one is useful is, for example, if you want to create a container and afterwards if you want to check the configurations and all those things means, so you will be using the create container. And if you, in order to save time or something like that, you want to create a container and you want to run it upfront means you will be using this run container. So depending on the options you can use it. But I am telling you the difference between this create run and also the docker container run and also the docker container create. And another one, the last one which I want to tell you is, before closing of this docker containers, how we can log in into the container. Okay, so not all the images you can log in. So there will be only some images which you can able to log in. So not all the images you can able to log in into the shell command. So using the bash or some other shell also you can log in. So that depends on the image. They will be providing you the option whether you can able to log in into the image or not. So for example, let's say that for this nginx-demo I want to log in into the container means what I need to do, docker container exec, and I want to log in into a terminal in interactive mode, and I want to give the nginx-demo, that is nothing but the container name, and I want to tell the shell name. So what is the shell name? So right now I want to use the bash shell. So you can use whatever the shell you want. So depending on the image, whichever it supports. So if I try to press enter, automatically you have been logged into that nginx-demo. Now if you try to run whatever the commands you want, you can run it. Okay, so here you can run it, and also here you can run the apt update also. This time it will be pulling the packages from the Debian. That depends. So for the Debian package also apt update will work. So like this, so all the commands will work in this container. And if you want to log in out of the container means, then we need to press the exit. So depending on the like internet speed, so it will take some time to download. So let it download. We have already did this one. So we have already logged in into this container previously in our videos, but I am trying to tell you that we can also log in into the container using this exec command. So there is also another way. So actually there are two approaches by which we can log in into the container. So this is one way, you can directly log in into the container and you can write the commands. And another approach is how it will be is, so I will try to show you. So I am exiting, I am coming out of the container. So we want to run the container without logging into the container. I want to run the commands against the container. Then what I need to do is, so we can use the same thing, docker container exec. So I want to write the container name, that is nothing but nginx-demo, and here I need to provide the command. So here I can provide something like ls-l. So you can do it like this. So let's try to see whether we can able to see it or not. So like this we can able to see, without logging into the container we can able to see the contents in the home page. So if I want to see the etc/host means, so you can check it like this. See, like this we can able to see. So like this, without logging into the container, if you want to run the commands against a container means, so you can use this exec command and you can provide the command whatever you want. If you want to log in into the container means, you need to provide -t-i and also the shell name. So now and also one thing you need to understand that not all the containers will support this logging in depending on the images. So if they support means you can log in, or otherwise you cannot able to log in. So that is one thing you need to understand. So we have learned in this video about the create command, run command, and also -rm option also I have shown you, and also the exit command, how many ways the two approaches, how we can log in into the container and execute the commands. So these are the different commands, basic commands which we will be using while creating the containers. Hope you understood about this concept. So this is all about the containers thing. In the next video onwards, we will try to learn about the images. So what is a Docker image and how we can create an image, how we pull image and all those things. We'll try to learn in the next videos. Hope you understood about this concept. If you have any doubts or any suggestions, please post the comments below to this video. And if you like this video, please do support me by subscribing to my channel. Thank you.